Hi everyone, good morning and thanks for coming. We're just gonna get started, so if you wanna come here in front and approach the stage, we're gonna get started just in the next minute. All right. Good morning, everyone. Thanks for coming. Again, it's great to see many faces of the community here today. We have a quite packed agenda, so I'll get started so that we can get to the more interesting things. But yeah, welcome you all from the team of PIs for the NSF Award that has been supporting this event. So on behalf of me, Tommaso and Manu, welcome, as well as from all the people that have been working to get this event going, as well as to support the hackathon and the school that has happened in the last, in the first part of this week. So just to quickly review the agenda, I'll briefly do an introduction to the event. We're going to go to a keynote speaker. We have Alex Choi from the Aeron Alliance. And then the next part of the morning will be focused on community presentations from the open source projects that are here today, as well as NTIA. After lunch, we have 4 panels scheduled, so I hope we're going to stay awake after eating with some discussion and some interaction also with the audience. We'd like you to ask questions, anything that comes up to your mind. And interestingly, at 3:15, we're also going to review what the 6 teams that participated to the hackathon have done in these last 3 days. Before introducing Open6G plus AI and this initiative, I'll hand the stage to Tommaso Melodia, the director of the institute who's hosting this event, for a quick introduction.
Good morning, everyone. Welcome. It's a pleasure to have you all here today. We're excited to launch this workshop that comes at a very pivotal time, I think. 6G is starting. 6G is becoming real, right? We've been talking about 6G for a number of years in this community at this point, but we are at the point where 6G is actually getting into, it's becoming real technologies, real standards, real discussions that are shaping the future of connectivity. They're also shaping much more than the future of connectivity. They're shaping the way that the most transformational technology of our generation, AI, is shaping up. And 6G is going to be a crucial part of the AI revolution, right? It's going to be, we think it's going to be a significant part of the inference layer, and it's going to be a significant component of the data collection, data factory component of the AI revolution, right? 6G is going to be what brings models close to the physical world and what gets data from the physical world into models, right? And that's what the next wave of AI is going to be about. This workshop is going to try to talk about foundational piece of what 6G is going to be about, and that is open source software. We're in a very different place with respect to where we were a few years ago with open source software. We are at a place today where open source software is starting to get competitive with production systems, right? It enables a large community of developers, researchers to experiment with systems that can be, and with technologies that can be brought into production systems rapidly with development cycles that are very different from what we were experiencing a few years ago, right? When we were just looking at simulations. What we want to do with this workshop, and that is part of the activities of our institute in general, is really create a community, an ecosystem around these technologies that brings together technology researchers. Obviously, Northeastern researchers are very much engaged with these technologies, but we want to bring together partners, industry, non-profits, government, and advance these technologies together. Obviously, this cannot be done in silos. We need to open up collaborations, we need to open up interfaces, and we need to do it in an open way. And for the telecom industry to play a key role in this space, we need to have a generation of engineers and technicians that develop these technologies that understand in depth all of the details, that understand the full stack, and understand what is behind an interface, right? We can't just rely on closed systems. And so this is really what we're trying to do with this workshop. Michele has been the driving force behind the entire POSE project that we're doing with Manu and myself, and has put together a fantastic program, and I think everybody's going to enjoy that today. Just a little bit about our institute that hosts this event today, Institute for Intelligent Network Systems. It's really coalescing the Northeastern strengths in the areas of networks, wireless. We changed our name from Institute for the Wireless Internet of Things to Institute for Intelligent Network Systems earlier this year to better reflect the focus of what we do and the aspiration to really be this glue between the world of intelligence and intelligence applied to systems, the world of connectivity and the world of networks. Research is our main goal. We also do a lot of work in technology incubation, developing open source software, developing IP. There's an ecosystem of spin-offs that have been created around the institute, and we think in many ways we're just getting started, and we want to partner with all of you and find opportunities to develop these technologies and bring them together to the next level. Thank you, and I'll give it back to Michele for the interesting stuff.
Thank you. Thanks, Tommaso. So just a quick introduction on what is Open6G plus AI. You've heard me and Tommaso mentioning NSF POSE. So this is a program that we are performing for these NSF pathways to enable open source ecosystems. I believe the name slightly changed recently, but the core of the program remains the same, which is to support the creation of communities around open source ecosystems, understand what are the gaps from a governance, from a community point of view, and support these kind of rich and vibrant ecosystem also with testing facilities, testing tools, best practices in security, and so on. So here we are supported by this NSF POSE award, and specifically we are looking at an ecosystem that we all, I hope, care about, which is the open source ecosystem around end-to-end 5G networks. And if you look at it from a broad point of view, right, it really comes with a large variety of projects, of many contributors, many different institutions and communities that are involved around this. Going from the radio access network at the bottom of the slide, where we've seen many changes coming in the last few months, all the way to the top, where you have on the top left, it's actually taken from a Linux networking foundation, a picture of the edge and cloud components, and on the top right, the core network options that you have. And interestingly, we've had a version of this slide for a number of years at this point. I think the first version of this slide was from 2020, and we've kept evolving it, and we're always happy to see that there are new projects that come up and become part of this ecosystem, but also that the projects that are here mature, evolve, and become more robust, and as Tommaso was mentioning, closer to real-world systems. So as part of the award, we did last January and February, we went through an ecosystem discovery phase, part of this NSF iCorps program, to understand what are the gaps and challenges in the ecosystem. And this helped us also inform how we shape the program for this event. So we spoke with 100 plus users, contributors, funders, and stakeholders in the ecosystem, and you can see a breakdown here in terms of like academia, industry, government, project leaders, as well as testbed operators. So we try to cover the different personas that contribute to the open source ecosystem. And the key insights that we derived out of this exercise, so this is basically a keyword count, the percentage of how often this topic came up across the different interviews. And you can see basically some of the direction that we'd like to explore today, and in general explore as part of this program and improve, help work with the different projects to improve and facilitate within the ecosystem. So first one, I think, is it's difficult to translate a lot of development that is happening for research and for testing into actual contributions that get to the open source project. Something that came up a lot is lack of incentive. So why should someone care about open source? And I think this is also on us probably to communicate better. The second most mentioned area has been around testing and validation. So especially around wireless, it's challenging to kind of get to work with the software, deploy, test it, and develop software that is reliable, that works across corner cases and so on. And we actually have a panel this afternoon that will look at some of these challenges. There's a tension between open source, seeing as a resource and development tool, and some production or commercial ambitions. This is something that I think is changing as we speak. The ecosystem is evolving in this space, but I think something to keep in mind as we continue and evolve. Documentation is always a point that comes up and something that can be improved. And then the funding cycles, right? We spoke with people primarily across North America, South America, Europe, and also some folks from South Africa, and different countries have different funding cycles, different ways in which open source is funded directly or indirectly, and sometimes this kind of heterogeneity and also periodicity in funding makes it difficult to plan in the long term. So these are the issues that came up when talking to these 100 plus people, and we see Open6G plus AI, this award that we have, as a platform to potentially address these issues and work with the community to advance this. So as I was mentioning, this is an NSF award where we're working with the OAI Foundation and AT&T to define a platform for community discussion, which is hopefully what we're doing here today and what we've been doing for the rest of the week, as well as an open source blueprint that can be used for streamlined deployment of this kind of system, toward basically creating a community of communities around end-to-end 5G system, rather than different projects working in silos, trying to bring them together to streamline and facilitate deploying these kind of systems. And so we have a number of activities planned, from sustainability to growth, and for us, success eventually translates into how will this system be used in 5 to 10 years, maybe 3 to 5 years from today in R&D, but also deployment. So we have a proposed blueprint that brings together different kind of projects. This is basically an end-to-end 5G system that identifies different kind of software components that can be used to deploy it. And we'll have more chances to talk about this during the day. Just to close this introduction, I want to touch on what we did from Monday to yesterday. So this workshop is the final event of a week that has involved 37 students that came to Northeastern from different institutions across US, but also the world, and engaged in a school and a hackathon to get a real hands-on experience on this kind of systems and on the blueprint that I was showing earlier. When the goals, also connecting to what Tommaso was mentioning, right? Community, so get to know more about the other projects with which you maybe are familiar with, but don't know the details or don't know who's working on this project. So we try to bring together different people from different community, hopefully so that you can discuss and engage. This is why we have panels in the afternoon. Please get questions ready and ask away. Hopefully you can understand how you can approach this project and contribute, especially for like students and researchers who are working in this space. How can your research be useful to the project, and vice versa? How can the project be useful to your research? So as I was mentioning, I won't spend too much time now because we have a dedicated session this afternoon, but we had a hackathon with participants from 37 different institutions running over 3 days, actually 3 afternoons, and using the Northeastern infrastructure to get a hands-on experience and develop some scheduling code for the OAI stack. And we'll present the results in the afternoon. So there's 6 presentations that will come up, 2 slides each for the different teams. So just to close the introduction before getting Alex on stage, some questions to kind of think through for the day and kind of start some discussion. What's next? The ecosystem is vibrant and is growing. That's good. How do we best support this growth and make sure it goes toward making this open source software more successful and more with more contribution, with more adoption, both in R&D and production use cases? How do we support testing, security, and robustness for this ecosystem? AI run is for sure perceived as a catalyst. There are several use cases in which having access to the full stack and open source software facilitates development of AI run and also Open Run software. Documentation probably is the lowest hanging fruit to address, especially in this day and age of AI tools. But then also I want to keep it open and I want to look forward to the feedback and the thoughts that you all have around this. I'm happy to engage during breaks. We have lunch today for networking. We also have a reception tonight in this space where we can continue the discussion and kind of see where they lead during the day. I'm gonna stop here and we're going to continue the conversation during the day. Next, I'm happy to invite on stage our next speaker, Alex Choi, chairman of the Iron Alliance. who is going to give us a keynote around how do we basically leverage advances in AI for AI run development itself. Alex, over to you.
Thank you, Michaela, and thank you, Tommaso, and thank you, where's Manu? Yeah, Manu, for inviting me to this precious event this morning. So, good morning from my side. My talk, or before I start my presentation, maybe I need to introduce myself properly. I'm Alex. That's my English name. And I'm working for SoftBank, Japan. This is my second year working in Japan for SoftBank. Before, I lived and worked for Germany, for Deutsche Telekom, for about 7 years. That's quite long. And before Deutsche Telekom, I worked for another operators, SK Telecom, for about 6.5 years, in South Korea. That's all. I was a CTO there. So overall, my operator's journey is in total over 15 years. And before the previous 15 years, I worked in the vendor side. So started as a silicon semiconductor engineers and designed the chips. Firstly, a base station chips. I used to play with the FPGA, all this DSP, but then later on, it was a long time ago when I worked at the LG Electronics, where they have a business line for the telecom infrastructure business. Now it became a joint venture of started with the Nortel, so it was a LG Nortel. And then now it's Ericsson, because Nortel is gone. So it's LG, Ericsson LG in Korea, still live, and they're also very active. So I started my job as a semiconductor engineer, chip designers for the base station, in the channel card. So I designed the chip, and then we manufactured it at TSMC. That was a long, long time ago, believe it or not. And then I also designed another silicon ASIC for the devices, LTE. Very, if you Google it, you can find that I'm the guy who commercialized very first the LTE modem chip for devices in the world. And the customer was Verizon. So after we commercialize it, this chip, and then we put it into the dongles, data card, and supply to the Verizon when they started their LTE service launch back. I don't even remember when exactly was it, but it was a long time ago. So, and then I also extended my work scope and then become a system engineers, mostly radio access network, started from 3G, 4G, 5G, you name it. And because I'm on the vendor side, I used to do a lot of field tests on behalf of operators. So that gives me a lot of field hands-on experience, and it's helping a lot. And while I was at SK Telecom, sorry for the long introduction, but I think I have a long, thank you for your generosity. I have a 1 hour time slot, so I can finish my presentation maybe in 20 minutes. And then of course I will take questions, of course. But anyway, let me finish my introduction. And I did a lot of field engineering, and for the 3G, 4G, and 5Gs, and also CDMA, because it was a legacy network in South Korea, and one of the few CDMA countries. So yeah, I enjoyed it. And then what else? Okay, when I was at SK Telecom, one day, Facebook, they found me for some reason, and they asked me to take the lead of the TIP, Telecom Infra project, back in 2015, 16, something like that. a long time ago, already a decade ago. So I became the founding chairman of TIP, together with Facebook and Intel, of course, and then Nokia was there, and Deutsche Telekom, and later on Verizon joined, and so, and then 2 years after I left SK Telecom and joined the Deutsche Telekom, so I have to step down the TIP chair, and then interestingly, when I joined the Deutsche Telekom, so they also asked me to, chair, not the chair, to take lead, join the leadership position in the ORAN Alliance. So back in 2018. So the ORAN Alliance was officially launched at the Mobile World Congress 2018. So I was one of the five founders. So the other founders are Andre Fuchs, AT&T, and Docomo, and China Mobile, Orange. Yeah, that was the five horses or five co-founders. So the first chair was Andre Fuchs, AT&T, because AT&T is really the technology, and they are the biggest stakeholders for the Open RAN. Started with the XRAN project. XRAN is led by the Professor Sachin Katti. Interestingly, he changed his company multiple times, and he had his own startups called Uhana, and then he joined Intel, and then after he left Intel, he joined the OpenAI. Now he's the leader of AI data center infrastructure in OpenAI. So it's quite a journey. So congratulate him. So yeah, that was the story of my ORAN Alliance. So after Andre Fuchs retired after 4 years, 2022, I took the chairmanship from him. So I run the ORAN Alliance for about 2 years, I guess. And then I left the Deutsche Telekom and joined the, SoftBank, and Soma and Wakikawa-san. He found me for some reason, and then they asked me to take the lead of the AI RAN Alliance. So I became the founding chair of the AI RAN Alliance. It's quite a journey, I never volunteered, but but anyway, it's a long story. Sorry. So my talk today, by the way, I made this presentation slide using the AI tools. It's a notebook LM. I really like notebook LM. How many of you are using notebook LM? Yes, I like it really. So bear with me. So my talk today is going to be very technical because the week this here is this event is all about researchers, engineers, programmers, developers, open source communities. So I intentionally make this slide very, very technical, so please bear with me. So for decades, the RAN has been complex and manually intensive and largely closed ecosystems. And the progress was always measured in years, and the innovation was constrained by the high friction of proprietary hardware and software stacks that locked operators into slow vendor-driven upgrade cycles. So this presentation will outline how the convergence of two key breakthroughs, open source RAN software and agentic AI, has shattered that old model entirely. So I will explore how this new automated factory approaches built on the foundation of AI optimized or AI accelerated platform and open source projects such as OpenAI interface, and also, of course, the newly emerging alternative, which is Okudu, and it's transitioning how the static manually managed network yesterday into dynamic self-evolving 6G of tomorrow. So the transformation, here's a clicker, okay. Okay, so the transformation to a new reality for the telecom industry rests on three foundational pillars as shown here. First, shattering the development of bottleneck. The traditional months-long cycle of manually developing XFs, RFs in C++ is obsolete. And this entire process is now evolving toward a frictionless end-to-end automated workflow driven by AI and large language models. And also nowadays, agentic coding tools. The second pillar is in the middle, the open foundation. So automation requires the RAN to be open, inspectable, and programmable software stack. The OpenAI interface and the OCUDU, and recently the NVIDIA's area, 5G area, which is also open sourced, they are providing the critical high-performance inspectable code basis for AI agent training and also executions. So without this open codes, the agent cannot learn or validate their outputs. So next chart is ORAN bottleneck. Let's start with addressing the ORAN bottleneck and how agentic AI technology can overcome these major bottlenecks or friction point. So on the left-hand side, you see three frictions. First friction is a complex specification analysis. And now with a technology like retriever augmented generation, RAG, enabled agent, now it can instantly scan, interpret, and resolve contradictions in thousands of pages of 3GPP ORAN specification and eliminating months of manual interpretation, which is very, very relevant and very extremely helpful because I never counted how many pages we have in total, the 3GPP specification. Probably from here, reach the ceiling, right? If you stack it, all this 3GPP document, So it's just overwhelming. So this kind of AI, technology tools is going to be extremely helpful. And second friction point is a manual coding bottleneck, which is I'm going to address in more detail later on. So now this AI coding tools, Cloud Code and Codex, they can write not only the C++, but then also can do much high-level programming languages, Python and Go programming. So, and on top, NVIDIA's is one of the co-founders. Kuntal is here, is one of the co-founder of AI RAN Alliance. Generously, they open sourced all this area source code, and they also open up the relevant tool chains, and it can automatically compile this Python code, not the C++, but Python code, because Python is the most popular dominating languages in the AI community. It's not so popular in traditional telecom community, but the AI community, Python is the most popular languages. So they generously donate all the source code and then and associated tools in which you can compile this Python code directly into the something that you can run on GPU, yet meeting all these real-time constraint, real-time requirements, which is the beauty. Usually Python is very abstract, easy to program, but it's not. It's known as it's not so proper for the real-time, programming real-time systems. But NVIDIA has done a fantastic job. So you can use Python, yet still you can run it on top of, for the real-time system, such as radio access network here. And the last one is friction point is, of course, as already Michaela mentioned, addressed, testing, testing. So this is the key frictions. So the entire testing process, including the very complex cases like a near real-time RIG, E2 interface, and now it's a DApps, true real-time interface validation, can be finally fully automated in a digital twin environments where AI agent can generate test cases and validate results. Yeah, we have a BJ back there. So his team has done a fantastic job how we can auto-generate the test cases and validate, even validate the test cases. That's a fantastic job. I'll talk about it later, more detail. So this automation compresses the development time from 6 months for specialized engineers to mere hours for AI agent, achieving higher consistency and fewer defects. Sorry, I'm a little bit biased because I'm talking about NVIDIA and also Okudu. But so let's take an example. So there are new assets available to the developer community, which is Okudu and NVIDIA area. These two can form the foundation that enable us the agentic factory, which I will address in more detail later, and demolish this bottleneck. And of course, OAI can do exactly the same job. Yeah, so don't get me wrong. So Okudu was launched in the Mobile World Congress last month, and it provides carrier grade of 5G layer 1, 2, 3. They always highlight, it's going to be a carrier grade. For the CU and DU. And of course, SRS ran, based on their code base. And they offer both OAI and the Okudu offers the complete inspectable code base that AI agent can learn from and also modify and use to generate new functionalities. And every core radio access network functions, for example, MAC scheduler, E2 handshake, and layer 2 RLC buffer management, is now become visible and learnable. For example, when an agent needs to understand how the handover procedure works in practice, or how the scheduler allocate resources under congestion, it can read the actual, Okudu or OAI implementation rather than, looking at this 3GPP or ORAN specification documents. Second, NVIDIA AI area, 5G, and then 6G, of course, area platform, also open sourced last year, and this is a full suite of production quality CUDA accelerated radio access network libraries, including CUFI, CUMAC, and coupled with the, like I said, Python to GPU compilation, which is important, Python to GPU. Tool chains called, they call it area framework. So I'm take this moment to thank Kuntal to make this happen for your generous contribution to the community, AIRAN community. And it allows us, the AI agent, to program the most performance critical parts of the radio access network using Python. And together, Okudu, OAI, and Area can provide the missing ingredients, a massive inspectable, modifiable, high performance training and execution environment at scale. And this gives AI agent access to the complete source code of a production quality radio access network from physical layer all the way to RIG and SMO, and fueling the agentic revolution. So for OpenStack AI RAN, for open source AI RAN stack, let me talk about it. By the way, this morning we saw there's some building, looks like a stack, the Boston University. they told me it's a data center, kind of a data factory. Yeah. They say it's a computer science. Okay. So, yeah. So it looks like a, yeah, it's the same stack, like a AI RAN stack, it looks to me. I'm a little bit biased. So the stack is a fully programmable and inspectable architecture, as shown here. At the bottom, of course, you have a hardware layer powered by, AI optimized computing platform. It could be GPU. It could be advanced CPU. CPU also has a capability of running, AI models for sure. There's a NPU IP inside. So, but the truth is, NVIDIA's GPU, something like that, is performing by far, better when it comes to the parallel processing and also AI machine learning neural network. And but this bottom layer, hardware layer, is providing the foundational computation powers. Yeah, and one of the questions I'm hearing frequently is, okay, always, do we need really a GPU for the AI RAN computing? My answer is simple: yes, you will need it. You will need it eventually. You can start with the CPU, but eventually you will need a GPU. And on top of these hardware layers, we have a software foundation layers. It features two pillars, OAI, OCUDU, and the NVIDIA Aerial's CuPy, CuMac libraries, which provide the GPU accelerated physical and Mac layer functions. So, of course, you have other alternatives for this, software foundations. And on top, it's a bridge layer, which is the most critical layers. It's a new layers. And these bridge layers can enable the entire, OCUDU OAI, RAN stack to run, fully AI optimized environment or AI accelerated environment. It integrates AI inference directly into the data path user plane as a fully integrated co-processing architectures. And as you see, DeepSeek, we have a team here, and they are playing a very important role in these new layers. And then on top, there's finally a brain layers. I mean, you can add additional one more layer in between the top layer and the second layer in this picture. We can call it agent layer. Yeah, then it's going to be a 5-layer stack. But anyway, the top layer is a brain layers, which I will highlight later on. This is the layer for AI agent harness. And AI agent harness is the top orchestration layer, managing specialized LLM agents to automate the entire life cycle. For the first time, the entire RAN, radio access network, can be a coherent, open, fully programmable software system ready to be molded by AI. And realizing the AI RAN Alliance or the whole, this industry's vision through open source software and AI accelerations. So next is the rise of agentic AI. Why telecom needs a harness? So let me say a few words. So general purpose LLM excel in software engineering. They always score very high on the SWE benchmark, but they fail critically in telecom domain, telecom use cases, especially the real-time systems, because they lack context and grounding. So when generating network configuration, general AI models or LLM easily hallucinate, and therefore they make logical errors. That would be catastrophic in live networks. So this failure is mainly due to the lack of understanding of wireless network physics and telecom protocol semantics and the real-time timing constraints. Therefore, more domain customized or specialized AI agent harness is going to be absolutely essential. So this AI agent harness acts as a mentor or governor or guardrail by providing a deep specific context through, again, RAG, retriever augmented generations on, standard document, and also massive corpus of training data, which can be directly derived from the Okudu OAI and all this open source and NVIDIA area code bases. This training data sets, corpus, is very challenging, and because it's not a technical issues. Operators are afraid of exposing some kind of confidential or private information to the developer community. So they tend not to share all the operational data sets. So therefore, you can go with either using the synthetic data. Now synthetic data quality is getting better, but it's not the real data. Still synthetic data is very helpful, but you still need some real operational data, right? So this open source RAN can be the solution. Open source RAN combined with like a real digital twin or testbed environments like the one you have in Northeastern here in the campus, the Open6G and etc., X5G. So now you have a solution. You can have both synthetic data and also real operational data directly from the open source code-based testbed, indoors and also outdoors. So not only the lab environment, but also field environment, you can collect the operational data. Because it's open source, you can put some hooks there, and then you can collect all the data directly. It's not exactly the same operational data as the operator has, but it's good enough and close enough, so you can use it to train your AI algorithm or models. So this is another question I'm getting a lot. How you get a training data sets? Operator is not going to share with you. So how? Okay, synthetic data is okay-ish, but it's not the real data. So how they can find the real operational data set for their training steps? So this open source solution, I strongly believe, it's going to be the solution for that. Operators is not going to share their operational data. No way. So for many reasons, and also there is a regulation hurdles. And lastly, the strict guardrails to prevent actions that compromise network stability. Operator side, their nightmare is simple. Their nightmare is a network outages. So any disruptions to their network operation, they're not accepting at all. So their KPI is always, it's not throughput, it's not latency. Their KPI is network outages, network reliability, network security, network outages, availability, etc. That's the most critical KPIs. So you have to address that. Sometimes I'm feeling that, okay, a developer community or a vendor side, vendor has good understanding, but open source community like this, they are not fully understand, what's the operator's priorities. Operator priority is always number one is network outages, reliability. You have to address it first before you address the other KPIs. So please keep that in mind. So in that sense, adoption of the AI technologies, especially the generative AI technology, nothing's wrong, which is very good, but it has a problem, hallucination, and some others, other issues, which is critical. So therefore, you will need some kind of a harness. Make sure that your AI LLM models behave within the boundaries and never cause any outages or disruptions on the network operation, which is absolutely critical. So once again, these guardrails, when it comes to the AI adoption of AI, LLM, Gen AI technologies for the telecom network operation, this is the most critical point, requirements from operator side. They will test it, they will validate it, make sure that it doesn't cause any network disruptions. So until they feel, fully validate that they are not going to massively deploy. They may try some pilot, but they are not going to deploy massively. So very important for the developers and researchers. And this knowledge and enforcement transform the general purpose LLM into more domain-specific LLM and also carrier, like I said, carrier-grade reliability. And the AI agent harness resides in the brain layers that I showed you just before, the top layer on the 4 layers stack, the brain layers. Okay, so that brings me to this picture, a little busy. So let's talk about agentic factory. Agentic factory. This is the third pillar. I didn't mention it when I started the presentation, but it's on the right side of my first slide. It's a third pillar. And let's talk about how this agentic factory works. So it should be based on, it'll be based on 4 phases, 12-step automated lifecycle, as shown here. And started with the phase 1, architectural phase, intent, requirement, and design. And followed by phase 2, development and implementation. And phase 3 is testing, validation, and CI/CD. And finally, phase 4, deployment, ops, and evolution. So phase 1 is all about defining high-level goals into machine-readable specs. It's important, machine-readable specs, and resolve ambiguities by cross-referencing standard and also open source code, code base, and produce formal contracts. And phase 2 is code generations. This is the phase that you start utilizing, coding capabilities of Gen AI. And there's a specialized coding agent and can generate the code for the interface specification and the core logic implementation and AI model developments, and according to the contract developed in the phase 1. And phase 3 is a testing, validation, CI/CD, in other words, the quality assurance. Okay. Do you have a timer? I'm just lost my track of time. 20 minutes, okay. So let me finish it very quickly, and then I will take questions. So testing, phase 3 is a testing, validation, CI/CD. And the last phase is development, ops, and evolution. Here, agents handle deployments, monitor real-time performance, and autonomously detect optimization opportunities that will re-trigger the entire 12 steps workflow and creating closed-loop continuous self-improvement. So, yeah, now I'm getting, thank you. I get the timers on screen. Okay, so let's get into more details for each phases. Phase 1, first, it's an intent refinement. Agent automate the lengthy requirements gathering process by translating vague operators' demand requirements into precise machine-readable specification and KPIs, including specific throughput latency constraints. And the specification, the next step is a specification analysis, as shown. So use AI tools to scan, like I said, 3GPP or standards, and critically cross-referencing them with the actual open source code or Kudu OAI implementation. And this grounding step resolves ambiguities in the prose specification using the live code base. And next step is a design synthesis the architect agent synthesizes this input to make critical design decisions, such as optimal function placement between CPU, GPU, and CU and DU, and generate precise formal contracts that govern the entire downstream development process. Phase 2 is all about, first started with the interface agent, focuses on generating boilerplate communication code. It produce type-safe open API stub and critically generate, for example, ASN.1 decoders, which is always a very painful ASN.1, by referencing OCUD OAI codebase, ensuring bit-for-bit compatibility with the live network stack. This will eliminate weeks of manual error-prone interface developments. And it writes a core business logic in the form of XF RFs. It's strictly constrained by the phase 1 contract to ensure Python code fits perfectly and respecting all interface boundaries, schemas, and the timing constraint. And finally, AI ML design agent. For the machine learning task, this agent will select the appropriate model architectures and integrate it with the RAN data plane using, for example, NVIDIA's Pi area or Siona, for simulations. The entire AI machine learning pipeline from data generations to inference is automated and integrated into the workflow. And so this is the one I mentioned, Python to GPU pipeline. I don't want to go deep dive, but it's very, very useful tools. So you can use a Python for real-time systems. So, and then phase 3 is all about testing validations. And this phase, as you noticed on the left-hand side, there are 3 different LLMs, Gen LLM and Val LLM and Debug LLM. So I borrowed this from, where is a BJ? Oh, yeah, his lab. And there's a link on the down there, AI 5G test. If you click this link, it'll take you to the relevant site, even the academic papers and all the relevant materials you can access with this link, AI 5G test, all done by Vijay and his team. So here, Gen LLM writes a series of complex edge case test scenarios, so it generates the test case scenarios. And Val LLM, it verifies the output by cross-referencing signaling flows against the 3GPP ORAN standard, etc. So if there is an anomaly detected, then Debug LLM activated, and it performs the root cause analysis and suggests the targeted fixes. So I think this loop framework is quite solid. And if you want to know more detail, he's here. He's going to be around, so I can talk to him. And that leads me to the final stage, phase 4. It represents the operational life cycle. First step is a deployment, and it managed by a specialized deployment agent, AI agent. This agent handles the entire release process, managing accept RF's descriptor and orchestrating Helm chart releases for containerized deployments into the Kubernetes platform. And it performs automated health check and canary test, and to ensure a new function is running correctly without impacting the network stability. And the second step is runtime monitoring, relatively straightforward, and finally triggering the factory, meaning once you complete the loop, there are tools, monitoring tools. For example, NVIDIA's net analyzers. It can identify some anomalies, and if you found it, then it retriggers the entire loop workflow, 12-step workflow, by feeding it to its insight back to the phase 1. So this kind of a closed loop, transforming the network into a continuously self-evolving, self-healing systems that creates a pace of innovation no manual process could ever achieve. And then AI RAN Factory, it can be built on top of this architecture, Agent RAN, which was invented right here in Northeastern University. And it represents as a intentional infinite loop, a continuous virtuous cycle of self-improvement that never requires manual interventions to sustain. So this process starts with an optimization opportunity such as performance degradation or new business goals, which can be detected by the runtime monitoring agent. And this will initiate 12-step agentic workflow of generation, testing, and deployment. So the deployed network functions generates a new live data, and this live data then be fed back to the monitoring agent and inevitably revealing further opportunities that autonomously retrigger the entire workflow. So it's an endless, virtuous cycles. And the ultimate goal is to create a system that manages and evolve itself and freeing human engineers to focus on more valuable strategic innovations. And the factory also achieved exponential intelligence through this open source flywheel, as shown here. It's a self-reinforcing virtuous loop where each component accelerates the others. So as you see, there will be a lot of closed loop, multiple closed loop, a hierarchical closed loop, which is necessary. The catalyst is the modular architecture of ORAN systems, which allows specializations among agents. This modularity is the first stage open source code base where you produce a production-grade RAN stack code from Okudu OAI area, provides essential reference materials. And this will lead to the next step, which is a massive training data. I already mentioned it. You will get massive training data set, real training data sets. As this telecom-specific corpus, fine-tune LLM, and any other Gen AI models, and drastically reducing hallucination rate and imbuing them with a deep understanding of RAN protocols and constraints. And the result is, super agentic output, fine-tuned LLM. And finally, the agent harness, it provides the robust, multi-layered safety framework, which is essential for governing agentic AI in telecom network, acting as a concentric vault of protection to ensure carrier-grade compliance. So the core in the center, core AI agent core, is surrounded by three circles. First is a sandboxed environment. Here, all code generation execution occur within physically isolated. This is very important, physically isolated. There should be an air gap, and Docker-based containers, ensuring that the unexpected or malicious code cannot impact the broader system. The second outer loop is more guardrails, I would say, and also some MCP, model context protocol. So this here, guardrail will ensure and define the permissible data flows and actions for any given task. And the outermost circle is the latency timer. So the harness, this latency timer harness use profiling tools and to enforce a strict control loop of budget. And finally, we have a ultimate safeguard here on the bottom of the picture. It's a human in the loop. So I'm sure you know what human in the loop means. So this is my final chart, finally. Sorry about that. Telecom sui bench. We need a telecom sui bench. Absolutely. Today we don't have it. So there's an urgency. I urge or whole ecosystem, and it's a part of our job, AI RAN Alliance. We should develop a telco sweep bench. And secondly, we need more detailed standardization of interfaces around the AI machine learning, and also the guardrails. And then safety certifications. So like I said, we need safety and certifications. And finally, it's more business issues, but it's important, especially when it comes to the open source IP and licensing. So those are the 4 topics that I really would like to address here, and urge all of us to do something, to make something before it's too late. So of course, AI RAN Alliance, we will take some of the initiative here, ensure that we have Kuntal, he's a chair of TSC, so it's gonna be his job, to deliver something in this topics. All right, and yeah, that's it for me. Yeah, and thank you for your attention. Sorry about the lengthy monologue, but I'll take questions. I still have 7 minutes.
Thank you, Alex. Any questions?
Alex, thanks for the exciting keynote. I think this was great. Music for my ears in many ways. And at Northeastern, we're very aligned with the vision that you have outlined here. Then obviously you come from the world of operators. You've spent a lot of time with operators, so you know very well the reality on the ground, right? And I guess my question for you is, where is the inflection point where operators, the world of commercial wireless, starts embracing this vision, right? And in many ways, I think I've been saying for a while that to embrace a vision like this, operators today buy systems that are by and large closed and not really programmable, not open. To embrace a vision like this, operators need to become something a little closer to deep tech technologies, right? Or big tech technology companies, and have the technical expertise in house to manage a lot of these systems, right? How do you see that unfolding with respect to the reality that exists today? And are there big new revenue opportunities that could unlock this for operators, right?
Yeah.
That's I know it's a...
There are many questions. Yeah. Firstly, operator perspective, we have Tracy, and she's did AT&T for many, many decades, so she can also share some of it. My perspective, my 15 years of experience in operator community, there are 3 triggers for operators to start to make a investment, significant investment, not the incremental. Number 1, new spectrum. When you receive the new spectrum, okay, then it's time. You have to make an investment, big investment. And the second is, of course, I would say new applications, new services, new devices. And new devices always help. So we are welcoming the eyewear glasses. Still, it's slowly picking up the market, but operator welcome such kind of new devices, new gadgets. That will be the second trigger. And third trigger is a technology breakthrough or paradigm shift. Cloudification. It started with SDN, software-defined networking, and then cloudification, virtualization, cloudification. Now it's AI technology. So whenever we see there's a big technology innovations in broader across the board, then operators start to look at, and there was also one big wave, which was big data, and and network APIs is also or network as a network as a platform, network service as a platform, and those are the key triggers. So new spectrum, new service device, new applications, and new technologies, innovations. So those are the triggering point. And operators, I have to say, is not truly a technology driven. It's more rather finance driven, unfortunately. So they always, look at, when they can achieve the return of investment, which is always critical or challenging, especially AI technologies. Everybody agree we need to do something. We need to adapt, and we have to integrate into our whole network operations. But no one was really clear when operators can achieve the return of investment. So this AI technology is a little bit exceptional because there is a willingness to try, the adoption of AI technology. But this is very exceptional. Usually, they always count the numbers and figure out when can they achieve the return of investment. Otherwise, they're just watching what others are doing. And
because there is a big risk in sitting this opportunity out also, right, for operators. So I think that's why they're also more less risk averse with respect to AI, right?
Yeah, true. Yeah. Maybe Tracy, you want to say something?
So I really enjoyed your talk.
Thank you.
And I think we'll see as fault tolerance of these complex networks and systems goes up, the ability to be a little more inventive will go up. I think it's no secret, there are numerous studies. Most outages are a direct result of human error. That's probably why there's excitement and confidence in everything that you just described. But resilience is key. Yep. The more you have fault tolerance and resilience, the more you can do cool new things without adverse consequences. So that's all I have to say, and good to see you.
Yeah.
Hi, Alex. Nice to see you.
Hey.
So, wearing my telco hat, if I can still, but I think telco would argue that, along with Ericsson's and Nokia's of the world, that an FPGA and ASIC would be sufficient to handle today's telco workload. Bearing in mind that the GPUs consume a lot of power, etc., right? So what's your argument for that? And corollary to that question is, where does the traditional tier one vendors fit in this AI-RAN alliance?
Yeah, I mean, my company, SoftBank, and also my previous company, SK Telecom, both operators are very aggressively adopting the GPU computing platform. And
but isn't power an issue? Like,
I mean, there are some preconditions. You have to centralize the site first. So you leave only the antenna radios on the cell site, and all the base station processing has to be pulled back to the central office, and there you can leverage the so-called pooling gain, and then adoption of a GPU makes a lot of sense, despite of this increasing power consumptions. And the thing is that it depends. I remember Kuntal has a fantastic presentation at the Nokia Summit, talking about there's some wrong perception about the power consumption of a GPU. So if you look at the token generation rate, or token generation per watt, GPU is really outperform the traditional CPU. So it depends how you look at it. If you use the different metrics, you will see the truth. You want to say something?
Yeah. Thanks.
Yeah.
These are all great points also for the panel discussion later. We have time for a couple more questions. One here.
Thank you, Alex. I have a number of comments to make, but I'll start with thanking you for highlighting AI 5G test. I would really call on the community to try it out. It's a really useful tool, and we are happy to help you if you need some help. So coming back to the challenges, I would like to ask community not to work on it just yet. We have developed the telecom SW bands already. It has 27,000 questions for Okudu. It will be out in a couple of weeks or so. And the second piece, the MCP, we have also built Tele MCP. We will make it available as a library very soon, and hopefully we can also contribute to Okudu and other efforts. So please either work with us or wait on it a little bit before you start working on that. Otherwise, it will be I guess, a duplicate work in a way. But coming back to your comments there, right? I see these three issues with AI RAN at the same time. I see the potential, and I guess that's why I'm also working on it. But I see the issues on the other side of the idea here, right? Which the gentleman here also pointed out, right? That there is such a huge cost involved with GPU. And if you think about it, right, most GPUs are used for training purposes, but once you have learned it, it all kind of becomes a huge, useless cost because you don't really need all those GPUs. And today when we talk about AI, we are mostly talking about LLM. If you want to kill me, you don't need a missile, right? You probably just need a knife or maybe a strong fist, right? So you don't really need LLMs for everything. It's probably useful somewhere, but in most cases, it's probably not useful. So I think we should look at that let's look at the economy of AI, not just get excited by AI, and use LLM for everything and anything that comes in our way, right? So I would like to I would like you to comment on that. And second, I would like to really understand what is the goal of AI RAN Alliance, except showing some demonstration at some amazing places like GTC and MWC. Thank you.
All right. First of all, thank you for taking the initiative and providing kind of a sweet bench for telecom, and also yeah. So, or the AI RAN Alliance, our KPI is to maturize the ecosystem first. So kind of nurturing especially the startups, academia, and make them much more relevant to the real business cases. So that's maturizing the ecosystem around the AI RAN. AI RAN means, you have to figure out how to integrate, AI into this mission critical real-time network systems, cost efficiently. So we are not there yet, but we are looking at more mid, long-term aspect rather than short-term aspect. Short-term, like you said, there are some constraints, including cost and et cetera. So we are more aiming for mid, long-term perspective. So in addition to maturing the ecosystem, our vision is to clearly to deliver a practical, deployable blueprints. So practical and deployable blueprints to the end users of the AI RAN technologies, which is could be mostly it's going to be a service provider, but also it could be other stakeholders like enterprise and even national security issue domains, etc. So those are the two KPIs. Kuntal, you want to add something on top?
Software, checking the, your how do you test things, all those things, right? So there is of course applications of different types of AI and inferencing at different layers of the telco stack. So what Alex was presenting today was an overall vision where mentioned a lot of LLMs there, but we don't use LLMs, large LLM models for everything. So we need to understand that. And as I think also you had a comment about inferencing versus training. If you look at inferencing, it's almost more than 99% is done on GPUs today. And GPUs are evolving too, because we understand that inferencing is a different workload than training workload. So if you look at the latest announcement from GTC, it's all inferencing. Our Blackwell and Vera Rubin is all inferencing designed chipset. And I urge you to go and look at those points so you can better understand why the direction the industry is going towards.
Yeah, and if I add my comment, not all LLMs are the same. There will be LLMs supporting real-time services. For example, live translation services. You need the real time, right? And live translation will be done by real-time LLM. And the LLM, this AI spectrum is broad, extremely broad, with the very traditional, tiny, small, traditional model, regression models, all the way to large scale, trillion parameters AI models. And there are probably hundreds, thousands of different models in between these two. So it's your job, how to choose, how to choose the different models for which works for your use cases at the right cost point. So AI Red Alliance will do the job to providing such kind of insight in the form of white papers. So it's not available today yet, but it will be available tomorrow. So it's kind of a guidance, how you choose the different computing platform depending on, how to choose the different AI models depending on various types of use cases. I mean, the AR glasses also another use cases for requiring real-time LLM services because the backend, they should talk to you in real time, right? You are walking or racing, driving on the street. So real time is so critical. So I'm pretty sure there is a real new emerging market for the real time LLM inferencing services. I don't doubt it. Yeah.
Thank you. We have time for maybe 1, 2 quick questions.
I don't know if mine's going to be quick, but so thank you so much for the overview of kind of like the workflow of enabling the AI in the model. One of the things that I think is probably like every operator would agree is the biggest challenge is operators operate brownfield networks. There's a lot of existing infrastructure out there. There's a lot of existing configuration, topology, and know-how kind of built into that network. Can you explain how like the workflow looks like very much for a greenfield kind of approach, right? Of new code, new rollout, AI configuration and learning. How do you kind of alter that to fit on top of the existing network, the existing topology, so that you could actually start to kind of roll this out into production overall without it just being a greenfield, hey, we're working in a brand new band of spectrum or a brand new set of radios or 6G and we're ignoring the 5G layers. How do you view that happening, that evolution?
Yeah, very important point. I mean, once there was a high expectation, from the greenfield operators, but so far they are not so successful. So because if you really want to disrupt this status quo or the incumbent markets, you will need a disruptor. So which is a greenfield operator. So it is a little bit pity we don't see a meaningful greenfield operator as of today for some reasons. But then a brownfield operator need to figure out, okay, how to evolve, how to migrate from the legacy to this new shining, platform. This is not the first time. When there are new paradigm shift, like started with the software-defined radio. You remember Open Daylight. There was a high expectation, but it's not really a successful. I have to say, I have to admit that. And followed by big data. Also, operators spend a lot of money, and then the edge cloud. services, and so on, so on. Virtualization, cloudification, and now AI. So it's just the history repeats. Then you have to figure out, you learn all the lessons, right, so far. So now you have all the lessons learned. So based on it, you have to do this time differently. So my recommendation always, okay, you have to create a small greenfield platform inside the brownfield. So if you try to connect brownfield and the greenfield platform, it's not gonna work. You just waste your time and money to build this kind of stupid bridges between the brownfield and open and greenfield platform inside the company. So, but it's easier said than done. If you talk to your CXO, they will agree. Okay, let's try this time. Greenfield approach. Let's incubate the greenfield platform inside the brownfield. And again, if you go down to the operational level, and you face a lot of, challenges, not just technical, but organization, cultures, and even geographically. IT guys, they speak this language, NT guy, they speak this languages, and even within the NT, there's a technology community, they speak the different language, and operational guy, they speak different language, and procurement department, they speak their own languages. So there's so many silos within the operators, especially the tier 1 operators. It's too many silos. That's always extremely challenging, for brownfield. But anyway, there's no magic. The only successful approach, I strongly believe, is you have to incubate the greenfield platform within your brownfield, environment.
Thank you. Thank you. So thanks, Alex. Thanks for the questions. We're going to have panels in the afternoon.
I will be around, so if you have more questions, please catch me.
There will be more time for discussions also in the afternoon. We have a 10 minutes coffee break. We're going to be back with a presentation at 10:40.
Testing, test. We're going to be starting again. If everyone can just grab a seat. We're going to be starting the program again. The coffee break has ended. Thank you.
All right, we're getting ready to restart. If you want to take your seats. In the next part of this morning, we're going to have 4 presentations from representatives of different open source projects. And then we're going to have a talk from NTIA. All right, if you can make it back to your seats, I'm happy to announce the next speaker who is here with us today, Eric Luther from SRS, to talk about the Okudu projects.
Hi, welcome, and thank you for the opportunity to present here. You know, Open6G is pretty exciting. I remember when we were having these kinds of conversations around 5G and what would it be. And it's really exciting to see these standards come to fruition, to see, you know, kind of what made it, the things that didn't work out quite like we expected. And 6G is going to be that same kind of adventure. And those of you in this room will define what 6G is. And you'll have that opportunity to see your work, different aspects of it, make it into a standard. And so it's, this is really the groundwork for 6G and a lot of innovation to come. So my background, I was an Edis research guy early in my career. We were working with software-defined radios, and that was a new concept at the time, and making them affordable and accessible. And I actually got to touch the beginning of some of the work at OAI and some of the work at SRS. And a lot of those foundations now, 12 years later, are the foundations of Okudu and even 6G. So very honored to be a part of this industry. I get to work in SATCOM and NTN and many different areas. So we're going to talk a little bit more about Okudu, and we're going to talk about the vision and what it means to be the Linux of RAN, the origin story of where it came from, a little bit about the ecosystem, and most importantly, how you can use it to advance some of your contributions to some of the exciting new standards. So first, what is Okudu? Okudu, you have to draw a box around something, so we focus on the RAN. And what Okudu is OpenCUDU. And in order for you to use that, you really need a radio unit, kind of in this graphic on the side, that will actually communicate with the user equipment. And on the back end, you need a core network, which is where you store and authenticate your SIM cards, and you've obviously got the public internet. Now, the goal of this project started back around 2018 through some different collaboration and some different ideas around how open source and the softwareification of the 5G standard could benefit the community. And since that time, we've actually seen this proliferation of more than 5, maybe 10, I could probably count 10 off the top of my head, of parallel companies that have all developed their own 5G compliant RAN stack that aren't even the major network providers, that are all pouring hundreds of millions of dollars into the same software stack over and over and over again. And the thought is, if we can put those resources together, if we can pool them, we could spend, instead of $1 billion on 10 or 20 different RAN stacks, we could actually have a single RAN stack that is community-driven, that is open, enables collaboration, enables more participation from both industry and academia. And the unique thing here, though, that is also carrier grade. And that is kind of the differentiator of Akudu, is we're focused on deployment. We're focused on thousands of cells connected at a time, robustness. And again, it kind of comes back to carrier grade deployability, but then also building a project that is self-sustaining, that has an economic business model that will allow it to continue past the initial funding. That initial funding did come from the US Department of War. The founding father, if you will, of Akudu is Tom Rondeau. He sits in the Future G office. But he's been an open source proponent from the beginning, an avid user of Linux. He was, back when I was selling and working with the USRP at a platform at Edis Research, he was the head of the GNU Radio project. And during that time and over the last 10 to 15 years, there's this acknowledgement that Linux is now the foundation of the cloud. And the fact that everybody didn't continue making their own operating systems led to unrivaled productivity in the higher level applications. And we really see that same possibility for the radio access network. Now, what is Akudu and where did it come from? So for the last 12 years, SRS, Software Radio Systems, has been working on a product called SRS RAN that started out as a 4G RAN stack. And then in this 2018, 2019 timeframe, we started over from scratch, building a 5G O-RAN compliant RAN stack. And we weren't unique in that pursuit. What turned out to be unique is the focus on carrier grade, carrier deployable, and then there's some other features that I'll talk about in a minute that also added some additional value to the Akudu project. Akudu was actually coined and launched over the last year. That project, again, Open6G, is now replacing in the SRS RAN. And so what does that actually mean? We'll talk about that in just a second. But want to point out this block diagram. The blue box here in the center is what we call Akudu. It is the lower PHY, the higher PHY, or the DU, the low PHY, the high PHY, MAC and RLC, which make up the DU. And then you've got different aspects of the CU. Over here, you have a RIC. The RIC is not part of Akudu. That is something that would be bolted on. And then you have some other interfaces at the top right, which are how you connect up your core network or synchronize or connect to other CUs. And so, but this diagram and these green boxes and the definition of the logical interfaces are described this way because these are the different logical components that you can easily put apart, run on different cores, run on different compute platforms entirely. You can easily substitute, for example, the PHY at the FAPI interface and integrate something like Aerial if you want to do a PHY based on the NVIDIA platform. And these allow very logical and easier to separate components of the stack. Now, to talk a little bit more about what does this transition mean? So SRS RAN became Akudu. That was actually official yesterday, was the 1.0 release of Akudu. It's been on the repository for around a month or so now. And what this transition to Akudu means is The Linux Foundation is now managing this open source project. So it's no longer SRS. The software itself started out as kind of a find and replace of the word SRS ran for Akudu, but that, to say that was all it was would not properly represent the impact. The really big impact here, in addition to the Linux Foundation's leadership and their ability to draw in contribution and build a community, is also the license change. We're transitioned from AGPL, which was free for research and licensed for commercial use, to a fully open source, fully accessible for research and commercial use. The significance of this is it can be used and deployed, and IP can be built on it without necessarily the need to lose or disclose or contribute back the IP that you've developed. This has positives and negatives, but the biggest positive is now it can be used and deployed in carrier-grade deployments without those companies feeling like their IP is now at risk. So they can still build a business case around this open source software. So the stack itself is open, it's modifiable, it's layer 1, layer 2, layer 3. It's portable. This is quite unique. It's portable across Intel, AMD, and ARM out of the box. It also utilizes some of the accelerator capabilities in those parts through compiler flags. It's light enough weight that you could run it on a processor as small as a Raspberry Pi and establish a cell and connect to the phone in your pocket, and you can do that today with the software that's available. Or you can deploy it in a data center on Kubernetes in a true OCloud or Open RAN cloud for a commercial grade deployment. And it's scalable through all of those platforms for several reasons. And one was that when we originally developed SRS RAN, the goal was 0 dependencies. That means we're not dependent on something like FlexRAN, which predominantly runs on Intel-based platforms. And so we redesigned all of that software from scratch, and now all of that software and all of that source code is in the Linux Foundation as part of this Akudu project. So what is Akudu from a feature perspective? You can essentially think of it as release 17. It's pretty close to being release 18 compliant now. It supports both FR1 and FR2, 400 megahertz bandwidth, with different subcarrier spacing. Right now, it's 4 transmit and 4 receive. You'll see how that is going to evolve as our roadmap progresses, with a number of other features that you would need for a proper deployment. From a deployment options perspective, it is a proper OCloud compatible platform. It will deploy in Kubernetes. There is Helm support. You have the ability to connect a wide range of small cells, or build a small cell connecting RUs, or build larger cell architectures. And you can, again, deploy on multiple hardware. Where does multiple hardware targets become really exciting? Well, I might say, it's, the base station is a data center. Great. Go deploy in a small cell, put it in a neighborhood or in a factory. I might want to deploy on a satellite. Well, maybe I want to use a small ARM target in that setting. You have the ability to deploy on those different targets where you can move your solution around and deploy it where you need to. What does the ecosystem look like? Because we started with an existing open source project and have transitioned into Akudu, there is essentially an instant ecosystem effect where there are a number of radio units, core networks that have already been validated, different orchestration layers that have been connected, and these you can look through hundreds, if not, I would say thousands of papers, but thousands of papers and Plugfest documents from ORAN, where if you look for SRS RAN, you're essentially looking at the history of Akudu and that software stack and all the places it's been validated. So today, if you're trying to figure out if Akudu support this particular RU, you might be talking to a radio vendor and say, hey, is this supported? And they're like, we're not sure. And you say, SRS RAN, and immediately they say, oh yeah, of course. We did it at the last Plugfest, and it performed really well. So you'll need to know these SRS RAN references as you start to look for compatibility and things like that, but we're slowly working to transition marketing, documentation, and those things outside of our direct control to point to and reference Akudu properly. So with this ecosystem, there's a couple areas where you can contribute. One of those is directly to the Akudu project. As you contribute code, you'll work with the technical steering committee. Your code will go through code review. It will become part of test infrastructure. You can contribute directly to the project, and that is as of today. The other thing that you can do is develop IP or plugins or apps, whether it's X apps or D apps or things that leverage AI, and you can use Akudu as a path to market. Because if people are deploying Akudu and you have the ability to test against Akudu, you now have a channel where what you've developed in your lab as a student, maybe you've spun it out into a startup, now has IP that can be licensed to anyone that has adopted this platform, which is a very exciting path to allowing broader participation in what has been a pretty closed ecosystem up to this point without access to real fielded systems, or you are accessing a fielded system, but the data formats are weird or the way you debug it are completely differently. And so driving this consistency around the way data is managed, the way data is logged, the way you debug a system, all of that becomes critical in taking a piece of IP that you worked on in a lab, you put it in deployment, and now you can continue to interact with it the same way. So as part of the Akudu project, which is led by DeepSig, and you'll hear from DeepSig in a little bit, there is a 3-year roadmap. That 3-year roadmap expands the capability, the capacity, and the connectivity options for the Akudu stack. These are, in general, meant to raise the compatibility. You're never fully 3GPP compliant because there are so many requirements. Many of those features are never actually make it into a deployed system. And by a deployed system, I mean even at the most invested carrier level, those systems are not fully 3GPP compliant because of the number of additional capabilities that are defined into the spec that might not be needed for all use cases. So predominantly, carriers will focus on the ones that have commercial value, and there's an return on the R&D investment to add those both capabilities as well as use cases. So these are based on Addis MVP use cases that are considered important for deployments going forward. And this roadmap is certainly in work. It's going to continue to evolve, but this is what we're currently working on. The 1.0 release included everything you see under April 2026, and the next major drop of features will be in October, although I would expect these will start to roll out as they're complete. Just to point out a couple things, FR2, as I mentioned, is now part of the stack. Towards the end of the year, beamforming, NSA, and NTN features, which is all really interesting. NTN release 18 is coming in early 27 with things like RedCap, which is your reduced capability for IoT-like targets. And then you start to get into, in 2028, the NPI, NPN, which is essentially private networks and public networks interacting. And so you start to get some really interesting deployment features as we go forward. And certainly these might move around. They might be reprioritized based on the community and the ecosystem and those contributions. Now, these are the things that we've already defined that we're working on. You have the ability to build and contribute whatever is important to you, and that applies also to the other commercial participants that are participating in Akudu. So what does contribution look like? Contribution is the standard flow of an open source project, much like a Linux contribution or other open source projects. In our case, we are prioritizing contributions that do enhance and are both considered carrier grade quality as well as 3GPP compliance, so standard compliance, and expanding the overall capability of the stack itself. Scalable and carrier grade, making sure that the use cases and functionality are useful and as complete as possible. And we really see engaging the user community as a key aspect of this. And then on the QA side, because we keep repeating these words carrier grade, which is still a little bit of a gray area on exactly what that means, but we spend a lot of time testing, a lot of time. And one example of that is stress testing, where you take a server. We actually have some test modes where you can use external UEs or you can emulate UEs, and we can fully load the system and run it for long periods of time with large numbers of users. This is an example of nearly 10,000 UEs being emulated all at once in a stress test. And this is one example of many types of testing that we have conducted, and I'll speak more on that in just a minute. These types of tests typically run on a weekly basis. To give you an idea of every time code is checked in, we're constantly going through making sure that we didn't break other aspects. So when you look at this multi-layer test approach, all the test code is actually checked into Akudu. This is also fairly unique. So the first layer is cloud-based tests, unit-level tests for all of the algorithms, and that moves up into more integrated tests that can all be run against software testing software, right? Then when you move up to the next layer, we have what we call the Akudu infra, which is actual physical infrastructure. We're looking at IQ level, we're looking at testing against Viavi test systems, we're looking at testing against Keysight test systems and Rohde & Schwarz test systems, and using the industry standard test equipment to validate that this stack is both compliant with 3GPP, as well as stable, as well as producing the right results. And in some cases, we use like MATLAB to calculate what waveforms should look like, and we're validating against this known good set of use cases. That is also checked into a project. So what we're then working with through Akudu is groups like Valor Lab, or in the government side, NIWC, are taking this infra and the Akudu testing and they're repeating it, both to validate the stability of the code as well as the quality of the code, as well as its ability to stand up to the abuse that it will receive when it's actually put into production and deployed out into a real tower. So the goal here again is carrier grade infrastructure and a robust open source project that you can depend on, just like you have come to depend on Linux. And a platform that you can then start to build apps on, just like when you use Linux, you install apps on top of that so that you can do whatever it is you're trying to do, the web browser, the photo editing, and all of the other apps that might run on top of the operating system. One of the exciting use cases that I want to mention is Semper. They are actually deploying, working on integrating so that they can deploy Akudu. They have a partnership with T-Mobile, so they're working on the integration between the core that they've connected to Akudu as well as commercial infrastructure. And what this gives them ability to do is users can actually roam between Semper's network and a T-Mobile network. In addition to that, they're collecting data. They're able to start to build the data sets that might be used in the future to train models. They can roll out things like Isaac features. And if you all are developing models, you can partner with companies that are deploying Akudu and test out your IP in fielded systems. And so this is really the dream of having this continuity between my research and what's actually being deployed in the field. Now, I'm going to say that Akudu is really based on ORAN, and this is Akudu 5G, right? Not 6G, not AI. We have been through a lot in the ORAN and in the ORAN era, right? And I really believe that Akudu has been through a lot of that testing and hardening and excitement and not so exciting times that 5G and private networks and things have endured. But I think what we found is that the RAN is now going to be based on software. And now the goal is to take some of these other new exciting technologies and integrate onto this stable platform. And so really what I'm trying to say with this diagram is we're at the point now where we're starting to build a stable, scalable RAN that now can be innovated on top of. And it's ready to be deployed with a little bit of extra work in 5G applications today. There are already commercial deployments, and so we're building on a stable foundation. And then it's your job to take this stable foundation and innovate to the next level. NTN, AI RAN, ISAC, and all of the new exciting capabilities that are going to be added as we move into 6G. And many of these can be rolled out as software updates to already deployed systems, which is pretty exciting. So in conclusion, you want to get started, go to ukudu.org. You can visit the website, you can learn about the project, you can download the code, you can build it, you can hook up a USRP, you can connect to a phone in about an hour after you've compiled it for your machine. And immediately start making changes. The tutorials are awesome. They are hidden in the documentation a little bit, but I want you to know they're there. ORAN, CUDU splits, how to connect to a commercial COTS UE, so commercial off-the-shelf UE, how to do testing with MATLAB, how to connect a near real-time RIC or build your own XApps. So there are a number of tutorials that you can use to get started. And while Forbes isn't necessarily a technical resource that we would commonly reference, I think they made a really good point. We're in this Akudu moment right now, and the telecom industry benefits with an all-hands-on-deck approach to leveraging the upstream and downstream value of the open source community. And you all are the community. So look forward to your contributions. Thank you. Okay.
Next, we're going to have Raymond Knopp from Open Interface. Thanks again, Eric.
Thank you.
Okay. I don't see. Is it working here? Okay, so thank you very much. I'm very happy to be here today. It's also nice to follow up after Eric, who's a very old friend from, you'll see in a second. So I'm going to talk a bit about Open Air Interface and its approach, which is a bit different than what we just heard now from Akudu. And in particular, also, in some sense, the rebranding towards another project in Linux Foundation called Duranta, and how we are going to go forward in the 6G era. Can't really see the screen here, I'm sorry. Okay, so just a little bit about me. So I'm actually a professor and department head at a research center and engineering school in France called Eurocom. I'm also president of OAI. From a technical perspective, I'm actually a very long time SDR and RAN enthusiast. And I'm actually speaking today really with that hat rather than any other hat. I just want to flash back a little bit. I mean, we're going towards 6G, but I think it's always good to know where you came from when you're going to somewhere new. I'll let people guess who that character is there with the first generation USRP B210. But OAI in its current form really started its community-based SDR journey at the dawn of 5G. And I really want to stress that OAI from the beginning has been a community. Okay, what we just heard from Eric, he's inviting you to all become the community. This is what we've been trying to build since this time here. Its focus from the very beginning and today and going forward will be research. That is not going to change. originally it was an open source project, and in fact it was open source with a GPL v3 license, and it aimed for community contributions at the time. The community was small. The community was essentially an EU or a French even based research project community running on Eurocom's hardware platforms. So we used to build hardware platforms and we would showcase it with those platforms with OAI. That's what it was at the beginning. But with the introduction of USRPs in around 2013, Eric actually came to our lab and told us, why are you building all that hardware? Use this nice white device here, this USRP B210, and you're going to be able to really build a community with that. And we said, okay, we took him to heart. We were also very proud of our platforms at the time. But I kind of heard what Eric was saying. He had a National Instruments hat at the time. I also respected a lot the kind of equipment that National Instruments built at the time and today. It's one of our key partners still today. I said, okay, let's try this out. And lo and behold, he was absolutely right. Okay? And the first significant contribution, and this is also very interesting too, was the driver in OAI for the USRP B210. And that was written by a very, very important US company called Agilent, now Keysight, but in China. So people were using the USRP B210 in China with OAI, and that was actually one of the first contributions into the GPL code base. It was that driver written by Agilent in China. Afterwards, we quickly abandoned the hardware development for SDR and adopted the USRP as the basic platform. And the community actually was based on that principle there, okay? But what was interesting, who was the original community? It wasn't the Northeasterns or the Rutgers or the North Carolina State University. That wasn't the real community at the time. The community was Agilent in China, Alcatel-Lucent in France, Orange in France, and China Mobile. That was the OAI community in 2015. So that was actually very eye-opening for us because, we were a university, but that was the community. And in fact, that's also what now the Linux Foundation is looking for, in particular behind Okudu, to have a community like that. And that, for me, is the challenge at this point here. How it's going to go, I'm going to skip this. That was just, at the beginning, we actually made some original sins. Okay. The first one may be hard for you to read here. The license you can see as a GNU General Public License. This was a piece of code for a very, very patent-heavy piece of procedures in 3GPP. It was the 3GPP turbo encoder. So there was Orange in France had all of the patents related to the turbo encoding algorithm. This was contributed by someone whose name in the OAI community everybody knows. It's Laurent Thomas, a very well-hardened industry figure in the 3GPP industry. It doesn't look like a sin there, but it does in another file here, which I co-authored with Laurent Thomas, because he was from Alcatel-Lucent, and he contributed to the OAI code base with a GPL v3 license. His company wasn't very happy with that contribution. Obviously, they didn't have patents on the 3GPP turbo code, but he wasn't. But this all highlighted what the spirit of OAI was. We wanted contributions from people like Laurent Thomas from Alcatel-Lucent, but we couldn't have everybody contributing into OAI that way. That was really the original sin. So original sin number 2 is, okay, we changed the license now into something that's compatible with 3GPP. Well, you can see this file didn't change, and now his company was much happier that this had the new OAI public license, which was one that was compatible with 3GPP. That was a sin too, not with respect to the community that we had at the time, but one that we were trying to get. Okay, and this whole business was really very tough to sell, and it will be tough to sell today too. It will be tough to sell for Okudu also. Very, very difficult. It was a tough sell even to the 3GPP crowd at that time. That's why we switched the license. Okay, so that we could get people contributing into the code. But even that took time to mature. Ericsson only became a member of OAI very, very recently. Okay, and in fact, they were very, very displeased by the fact that a project like this existed at the time. They had wanted absolutely nothing to do with that at the time. Things change over time, but it takes a long time to have an impact in this particular industry. And at that point in time, OAI quickly became a tough sell for the free and open source software crowd. Okay? That was a very, very tough sell because of the license. We went from a GPL license to something that was extremely toxic for the Linux Foundation. And it actually also became a very tough sell for the non-3GPP industry. So the Intels of this world, because of a non-OSI-based license. Right, so all of these things were quite complex for us to manage. We wanted this community, but how are we actually going to go and do it? And this is actually very funny. In 2015, on a rainy day, Sunday in Brussels, Belgium, there was at FOSDEM, so this is the free open source software tech gathering that happens every year. On that Sunday, an entire day, two of us from this session were here in the room. Tim was in that session. You can see other people like Tom Rondeau, who was in that session, and Paul Sutton from SRS that was in that session too. This is the first day that the community stuff really started, whether it's OAI or SRS or Kudu. That's when it started, that fateful day in Brussels in 2015. It was a horrible day. It was a very, very stressful event. I remember talking that day to Paul Sutton and saying, look, you guys are starting this, we're starting this, why don't we do this together? That obviously didn't happen, okay, because we wouldn't be here today in this format if that had happened. And probably better that didn't happen, actually, probably better. So now if we fast forward to today, we have all of these open source RAN projects here that they all still exist to a certain extent. But as a community, so that's the community, all of those projects that started around that time in 2015, together we came a very, very long way to build what you can call open source RAN. Okay, without all of those projects together, we wouldn't have had the presentation today that Alex gave, the introductory plenary. We would not have had that presentation. I think we owe this movement now to all of that. And I think the three players that we have in here from the perspective now of usage and community, you have them, and that's also what Alex was saying this morning, or earlier today. So OAI is rebranded as Duranta, SRS is rebranded as Akudu, and there's NVIDIA now too that has put software into the mix. Okay. Duranta will be a research focus. You'll see a lot of UE in Duranta. Okay, 5G, 6G UE is there, and we will put much more effort in the UE. You'll also see 6G now. There'll be platforms this year already that will be doing 6G configurations in terms of bandwidth. And Okudu, as you just heard, will be carrier grade. Okay. That's, in a nutshell, that's the difference between these pieces. And aerial, we will see how aerial fits into the picture. I don't know. But both Duranta and Okudu use the same interfaces that are compatible with aerial. And today, OAI runs on top of aerial. That's something that everybody knows at this point. Another aspect I think interesting in this picture, and we heard this too in Alex's plenary talk, there are two other players in this game, the Claudes and the codexes of this world that are going to gobble all this stuff up. Huh? And they're going to churn out something new. Okay? What it's going to churn out, I don't know what it's going to churn out. But it definitely will. Our community today, our developers inside of OAI, are embracing these tools. That we cannot not do that at this point. But I don't know what it means. I don't know what it means in terms of licensing. I don't know what it means in terms of open source. I don't think Linux Foundation knows exactly what it means in terms of open source either at this point. So all of this is still to be determined. Very, very exciting times. But at the same time, we have to understand where this is all going, and I don't. So if now we look a little bit more technical, what's inside of OAI and Duranta going forward, In terms of the community, we've been working tirelessly over the last few years with integration with other communities. So very much with ORAN in the last, since its inception, we've been working with ORAN. We've been pushing our community to actually reuse as much as possible of the software that was generated in ORAN. We do that today. And I think you will see some of the pieces from the ORAN software community going into the same area that Duranta is in the Linux Foundation, maybe some of it even inside of Duranta. That's still to be determined. Similar as, comments with respect to Nefio and more recently Silva also. Both Okudu and OAR are deployable in Silva at this point. So, you know, all of these things are going to continue. I'd like to also say going forward, OAI and Duranta will work with Okudu. We are already today. We are testing interop the OAI UE with Okudu. That's something that works. One of our engineers attended the first community meeting of Okudu, right? So that we could synchronize on certain things. We will definitely do interoperability with the Okudu code base. And we, you know, for instance, in several European projects there have already been interoperability between SRS and OAI at the CUDU interface or the F1 interface. We'll also do similar things at the XN interface. And more importantly, many of the Okudu members today, the industry members, are also OAI members. So there will be naturally discussions that are happening here. But I think if we now look towards 6G, I think we also need to get OAI working with other communities, in particular the RISC-V ecosystem. That is fundamental for me, with everything related to innovative hardware acceleration on top of the basic CPU and GPU implementations. Also using OAI for testing innovation in hardware acceleration technology itself, and optimizing interfaces with these accelerators. That could be an area where we can I think where we can have a lot of impact. Definitely with the overlap with the IML communities and essentially the interplay between IML and the telco ecosystem. So everything that was talked about earlier today. And in particular, using OAI combined with other LFN components to generate data sets that could later be used to empower AIML-based automation. Okay, so this is all be things that we can definitely do. And I think looking more carefully also from a European perspective at the RAN and UE hardware vendors, companies like NXP. This is very particular to the other side of the Atlantic. But that's also a place where I can play a very significant role is linking the EU and the US ecosystems together, because we have a footprint on both sides of the Atlantic. In terms of the license, OAI license will stay. It's rebranded. It's being called the Collaborative Standards License. But for me, this is an important achievement. And 3GPP is not going away any day soon, at least not in the 6G era. We'll see what happens in 7G. And you know, for the people that are actually innovating in the 3GPP ecosystem, this is a safe way to do it from a legal perspective. Well, I agree with what Eric was saying in terms of injecting innovation. Even a university that generates intellectual property, they could not put that into Okudu. They would lose their possibility for monetizing that IPR. They could put it into Duranta. And so that is a key difference from a legal perspective. So the license will actually stay the same, although there is a generic version of it now that is in the Duranta project. And just very quickly, in terms of some technical 6G targets, there will be an increased effort on the soft UE. Okay, in the 5G era, we put a little bit more effort on the RAN side. In 6G era, I think we will concentrate a lot more on the UE. That is a missing piece in the open source RAN, if you like, and OAI or Duranta will fill that gap. I think there will also be the need for exploring and pushing Duranta into different EU and US testing sites. So I'd like to mention Slices RI. Damien is here too. You'll see him in one of the panels this afternoon. That's a big EU initiative for testing. Of course, here at Northeastern, at Rutgers, at UNH, we'll be there tomorrow. to talk about the testing infrastructure, and at the Valor Lab too. Right, so I think this is a very important thing. It was mentioned in all of the other talks too. Other aspects you will see very soon, FR3 type test beds. So when I say FR3, I mean 6 to 8 gigahertz, not the higher frequencies. You will see blueprints for a 6G ORU based on OAI that people can use up to 400 megahertz bandwidth. You'll see blueprints for other types of radio equipment that people can use in research projects. We are using a lot of hardware acceleration at this point. So anything that uses BBDev and DPDK for Intel Sapphire Rapids or Granite Rapids, AMD T2, native GPU offload. There is code now in the OAI code base. It's different than Aerial, but code there for doing offloading of RAN functions on NVIDIA GPU. Some of it will be compatible with AMD GPU also. Some of it already is, but it doesn't run quite as well as it does on NVIDIA, but it's still there. So everything related to LDPC can be offloaded. And you will also see some NPU and DSP targets, in particular for Qualcomm Silicon, AMD, AIE, and NXP Vespa. So OAI will work on all of those things. As I said before, RISC-V is coming. NTN is already in the code base for both the RAN and the UE. FR1, FR2 integrated access and backhaul is coming. Today, OAI already works in FR2 up to 200 megahertz bandwidth. NRDC is already functional as of today. I just got a message from our lab. And I think you'll also see a lot in the sidelink. There are a lot of, in particular in the United States, there are a lot of people interested in sidelink. And that is also something that's in OAI today. So maybe I'll just jump to conclusions. The rest is not super important here. So in terms of where we're going, OAI is definitely going forward in 6G via Duranta, and we will collaborate strongly with Okudu. Our governance is being completely revamped, and it will be aligned with the Duranta charter. And the global governments, it should be said that this is going to be a globally governed project. Okay? It's not EU-centric, it's not US-centric. Yeah, I think that's important too. And the governance will comprise both nonprofit and industry partners. So Duranta is the LFN footprint for OAI. Duranta will remain 3GPP oriented, that's for sure. So we will, the licensing does maintain the full compatibility with the IPR policies of 3GPP, and that will not change, which I think is necessary for collaborative prototyping. And again, OAI will work with Okudu. There's no doubt about that. Oh, thank you. Okay.
The breaks and again in the afternoon. Thank you so much again. Next, we're going to have Kuntal Chaudhary from India and also AI and TSC to present about Aerial. And compared to what Raymond was mentioning, there were SRS and OAI in 2015 as well. Meeting. Ariel was not there yet, but
Hello, everyone. I will touch upon Aerial, but that's not the theme of my presentation. I think that open software, open source development, the innovation that we are going to, that we are working on is actually bigger than just the Aerial and Okudu and OAI. It's actually a 5-layer open system. So I've been around in telecom for many, many years, like many of you. And despite all our efforts to have this plug and play with lots of standardization, it's still a dream. You cannot really plug and play freely with lots of things. It requires integration effort, testing, and then even after many years of investment and continued investment in 3GPP, we keep testing, and it's a difficult job to actually bolt in AI/ML applications into the real network. And when I talk about my views, It's about deployment and commercial viability of what we are working on. Doing research and doing all these innovations is great, but unless it's deployed in the field, it's not really fulfilling for anybody, any engineer. So from that angle, I feel that the open focus has to shift. Today's focus is we are purposely defocused. We are focusing on component interoperability, but not focusing on the value creation. That's a big problem in our industry. Even after all the tries of standardizing at 3GPP and ORAN and everywhere else, there's still vendor lock-in. Once you deploy, it's a proprietary system, very hard to actually integrate other things. And this also restricts innovation. So unless you are part of a handful of vendors, your ideas, innovation, doesn't really get to see the day of light. And oftentimes we leave the network with this performance gap. Although you can do better, but we don't do better because we are stuck with innovation didn't happen in that one area by one entity or handful of entities. And then we always settle for what can be done the best way based on what's there. The least common denominator is what we have been doing. And this, I think we touched upon it during Alex's presentation, this mindset that we keep doing business with the big brothers and the incumbents, and they will take care of us, and nobody gets fired by maintaining the status quo, has been the biggest challenge in our industry. So you can talk about open source all you like, or open interfaces, standardization all you like, but unless those things are addressed. But there is big problem because of all these issues in the current way we are in telecom, is that the investment coming into telecom is very, very small compared to any other sectors. So because our focus is on compatibility, not value creation, we are not really generating interest from the investment community to come in a big way. So what we see is that we see the world should be focusing on a different way of building telecom. And that's starting with open source code base, which is exactly what we heard today with Okudu and OAI, and of course Aerial as well. But then there are other layers that we haven't talked about so much. I think there was some touch upon it from Alex about the data lake. The data lake is the lifeline. It has to be open. And at Air Alliance, we're actually focusing on that in a big way. The open models, because right now, if you look at the AI models, there are two ways things are moving. So for telecom, we need to embrace open models. That's where we will see the value. Open scientists and open developers, these are the new trends. At NVIDIA, we're actually working on how we can do research at a much faster pace. And I think there were some ideas that we discussed this morning from Alex, but those are the areas. So 5 layers of openness that we should focus on. Of course, we should move beyond. Of course, I'm not saying that we should not standardize, but our focus should be, our openness thinking should be more on value creation, not interfaces. And the future is about the code-based openness, model openness, the data openness, and how we develop software. So the first layer is, of course, open source code base. And this is what the dream so far has been, that of course OEI started the whole process. I was the founder of AltioStar, and when you did that company in 2011, there was no dominant open source code. So LTE, for example, 4G, our choice was to go to TI or some other chipset supplier to start with some libraries. That was it. So if you want to build a commercial RAN system at that time, it was a very, very small code base that you can start with. Today, we have OAI, and we also have Okudu, and then Aerial. So it's really a big movement towards an open source code base that's truly commercial capable, commercial deployment capable. So I don't see that going forward, anybody who'd like to build a company in this space would have to start from scratch like we did when we did the AltioStar. But packet core, RAN, all this open source code exists. But what's missing is this whole developer research community to work on that code in a more open way. And this is what the vision we have with Okudu. NVIDIA joined Okudu Forum because we want to build this global ecosystem. We have been working with OAI for many years, but we'd like to work with Okudu and OAI combined together at the Aaron Alliance to build this community who works on this open source code base to take the industry in a new direction. The shift is from, of course, standardized interfaces from ORAN and 3GPP, but they're black boxes. They're just connecting black boxes. This pseudo plug and play is because their vendor-specific extensions exist in those interfaces. You really need to do a lot more interoperability. In the open source code base era, we want to see how we can do all this interoperability in an automated fashion in the open source code base itself. So that's where the shift we would like to see. Open data lake, this is the key. So telecom systems reside or actually sit on a lot of interesting data, from signal data to IQ sample level data, telemetry data, traffic patterns, geospatial data, KPIs, logs, traces, name it. But hardly any of this data is actually available to any developer. So the other thing is that to actually build many of the applications, you have to also have real-time data. The data that is real-time streamed to the database that you can access very quickly. For example, DApps. The DApps will not be possible unless you have the IQ sample level data or some real-time data from the lower layers. So this data lake that we are reimagining is something that we are working on, and this is what the community should build and make it available to everyone. Of course, the data set will not come from the network operators, real network, but we can set up many test beds with these open source codes, and also not just restrict ourselves to just the DUCU, but the entire network functions. So this is one of the key things that needs to happen from open data lake perspective. I already talked about all these things, but I think the key functions as you look at 6G, like ISAC, and of course there'll be many shared spectrum agility, for example. Those functionality cannot be developed unless you have real-time data set and access to the real-time stack in the code. So those things are important for us to work on for this open data lake layer. The third layer that I talked about is open models. There is choice of using frontier models, which are great. They are sort of consume data from various corners of the entire web, and they're very smart, but there are limitations. Big limitation is that you cannot really train them with proprietary data set from a given domain. If you do, and also many at times there is not understanding of the real hardware in those models. So besides the cost aspect of it, the frontier models are not really ideal in our experimentation so far for telecom. Smaller models that are more open can be more custom trained for telecom tasks is the way to go. And we have seen this discussion also, as you know, the way the AI industry is moving. It's all moving from giant models to the mixture of experts, MOEs. So the reasoning models that are coming to the market, like Kimi K2 and DeepSeek R1, they showed the path that you can actually build large, very intelligent models with open source blocks all connected together. And that's the path we are taking. So many of the tasks that we are actually working on, for example, optimizing CUDA or making Python to CUDA transition, these are all based on open source models. And from NVIDIA perspective, our Llama-based model that we call Nemotron is what we are focusing on. And we have been advocating and working with the community from the model perspective to see how we can close the gap between frontier models and open source models. So Nemotron, as you can see here, but also from others like Kimi2 and DeepSeek R1 are already very close to closing the gap with the frontier models. And more startups, more researchers are actually downloading and working on open source models. As you can see, the statistics from Hugging Face. So 80% of startups actually building on open source models. And NVIDIA, as a company, we strongly believe in open source. So our focus is to see how we can make this open source model ecosystem vibrant. So we are the largest contributor of open source models in the open source projects. As you can see there, and many of our libraries like Cosmos to Groot to AlphaMyo, BioNemo, and Nemotron, they're all based on open source. And all of them are open into the community for the community to take and build their solution. So the third layer is all about network automation, actually network autonomy from automation. So this is an area where I think the telcos and our industry can do a whole lot with AI/ML. So we are working on such things like autonomous network, which is intent-driven. So you just give an intent, say the energy saving has to be X, and based on that, the agents run and have this iterative process to build this this whole policy in the real network. So this is already being tried, and also these systems are getting tested by GSMA and many other partners. Nemotron is basically the foundation, which is the LTM, 30 billion parameters, and it is already pre-trained, which is the large telco model, pre-trained with 3GPP standards, synthetic logs, and fault reports. And these are already getting tested and also deployed by the operators. We are also publishing these blueprints of, say, energy-saving agent and network config agent. These are based on this agentic framework where you can actually have a target to say, save energy for this much without sacrificing QoS, or optimize this network config for this objective for this cell. And those blueprints are already getting defined. At AI/RAN Alliance, we are actually publishing these blueprints in the agentic task group. And this would be, even the code for these blueprints will be available for people to take and make your product and solutions. And of course, the data that we are looking at is for these open models. One of the big things is that if you train the open models, you are in full control of everything, including the weights, the type of data that you fed into it, whether the data is proprietary or not, and whether the data is GDPR compliant or not. All these things can be complied with once you start using open models. So this is what we are saying, is that for this autonomy layer, we should focus on open models. Now, fourth layer comes as, this is brand new because we haven't really released it in the industry yet, but this is coming, which is, we call it AI telco engineer. Oftentimes, it would take a long time to figure out the best algorithm for a given task. And then, of course, trying it out and coding it and then testing it and then actually deploying it will take months, if not less. So this telco AI engineer is the future of research, where we see that using this agentic framework as a new workflow, we define the problem, we define our intent, what we would like to do, and we have this orchestrator who orchestrates, creates this parallel LLM runs, which are each agentic LLMs, which are very highly intelligent LLMs, which actually has access to the, say, Siona files. It has access to the file system of your place where you actually running it. And it has access to GPUs and other hardware. It is CUDA accelerated. We are able to generate very highly capable, I'll actually show you some examples, capable algorithms with this in a matter of few hours. But these are exhaustive. As of now, these are run, as you can see there are some mentions of first generation, second generation. That means different runs of agents. So we run, say, first time we run 10 agents, second time we run, again, 10 agents, but we run different types. And each of the runs, we select. This immutable evaluation engine is the one that we create. So we say that our benchmarking parameters are not modifiable by these LLMs, which prevents metric gaming. That means they have to be honest. These agents have to produce something that is really deployable and honest. So based on that, the loop goes on for multiple generations. As of now, we have run it for, I'll show you some examples, tens of generations, so 10 runs. Each run is 20 LLMs. The example is using GPT 5.4 and GPT OSS, 10 billion, 120 billion parameters. We could implement a channel estimation algorithm, and that gets very close to LMMSE performance without knowing the channel parameters. So once you also let the models know the channel parameters or which channel that you're actually looking at, it gets almost there, even better. So this run happened for 10 runs of 20 agents together in 8 hours. And the two results that you see there are two different models, UMI and RMA. And that shows that the algorithm that actually comes out from this AI scientist is deployable across multiple scenarios. You can generalize the outcome. Second example is link adaptation. This was GPT 5.4, and we ran similar things. The idea was that how do you select the right MCS based on the CQ and blur target of 10%. And the first run that we did, we didn't run two of them. We didn't run GPT OSS yet, but we're already seeing improved spectral efficiency from these algorithms. And the fifth layer of openness that we see is going to happen and already happening, that many of you are already working on, is this whole developer. So yesterday's coding is sort of not going to happen anymore. We're already in the year where we are looking at harness engineering. So prompt engineering was last year, where you actually can develop with prompts, which is cursors of the world, but going forward will be multiple agents harnessed together for telecom development. And inside NVIDIA, our software development is actually on this level already. But we see the open source community is going to go in this direction shortly, are already there. But the role of the developer is now changing. So, instead of spending time doing manual coding, the developer will be actually doing the harness engineering, where you're looking at evaluations of the code, sandboxes, boundaries, logs and traces of the repeatability of the algorithms that you're actually implementing. And the input as you give into this whole model could be that it came from the AI scientists. It could be that some models, somebody already defined a paper. So this is the OpenClaw moment for the telecom industry. So one example of this is also not released, but this is at last GTC, this was discussed. So it's called CUDA Coder. So going from PyTorch to highly compliant CUDA kernels. So the CUDA agent here, this is a single agent, which is LLM, actually can generate very highly performant CUDA-C or cuDNN or CUDA templates, and also have the NCU, which is the insight to profile the algorithms for a target hardware. So the benchmarking is kernel bench, and with that, we are already seeing that this kind of CUDA optimized code is already meeting 98%, 0.5% of the problems that are being solved with this approach. So this has been a big challenge for us in telecom industry that people did not know how to code CUDA, and the AI/ML world is on PyTorch. So moving from that to highly compliant CUDA has been a big challenge. So this is our way of making the software development much more accelerated and much more commercial grade as you like to deploy it in the field. And then of course, the development environment with ID can be integrated in this CUDA coder as well. And the last point I have is that NVIDIA is all about CUDA-X. CUDA-X is basically a bunch of libraries that solves problems for various domains. So for telecom, I selected this 4 or 5 domains: math libraries, scientific computing, deep learning, data processing, which is a big one, and all the comms. So if you really are a researcher who would like to build applications, and as you know, this open source framework allows you to write these applications using XApps, DApps, RApps framework, you have all these libraries in front of you. And as I mentioned to you, this whole coding framework, you can generate very highly performant applications using these libraries that are already available to you. So the new way of innovating in the future is this open innovation framework based on the CUDA-X libraries. This is our vision that we would like to promote in the industry. Thank you.
Rani Haibi from the Linux Foundation Networking, who's going to present as a blueprint to navigate open source in the run.
Hi, everyone. I'm Rani Haibi from the Linux Foundation, where I'm the CTO of Networking and Edge. For those of you who are still don't know what the Linux Foundation is about, we are the nonprofit that hosts most of today's world-leading open source projects and communities. Things like, obviously started with the Linux kernel, but going through cloud infrastructure, the Kubernetes ecosystem, Cloud Native Computing Foundation, AI, machine learning, PyTorch, and similar projects, and obviously a large set of networking open source projects. So today I'm going to help you kind of navigate the confusing stack of different open source initiatives that are in the open networking and open RAN domain. I will start by fleshing out this diagram, but before I get in trouble with some of the projects mentioned here, I would like to say this is kind of a serving suggestion or a starting point, helping you decide where to start sourcing your components for your end-to-end network, whether you're doing research or building a commercial product. All the projects you see here are projects that are hosted by the Linux Foundation. This is the good news, which means they are governed under a neutral governance, so there's no one single company that can pull the rug, change the license. It's all provided with usually a very permissive license, and you can rest assured that this license will not change overnight. So this is a good starting point. I think, as I said, this is just one way of doing things, and this is based on what we currently see in the level of maturity of the different components that these projects provide and the level of activity that we see. This is where we recommend to start. But if you already are doing something with open source networking and open source RAN and using different components, that's okay too. Probably you find something you like there, and this is also something we encourage. Just use whatever you see fit. What I'm going to do in the next few minutes is I'm going to kind of double click on some of these components and tell you about this project in case you haven't heard of them at all or just want to know where they stand these days. And yeah, so this is what we will do. I will skip Okudu and Duranta, which were just presented before for obvious reasons, but for the rest of them, I'll try to get you up to speed about what these projects are. So starting with the RAN side, because there was also a core section there. So starting with the Oran software community, the Oran software community actually started as a sort of a joint venture between the Linux Foundation and the Oran Alliance a few years ago, with a mission statement of providing a reference implementation of all the components defined by the Oran architecture. And the community has been active over the last few years and developed and delivered many of the components that are necessary for building an Open RAN solution. What's happening these days is that for the sake of efficiency, this foundation that's been a standalone foundation under Linux Foundation is coming under the Linux Foundation networking, which is the largest sub-foundation in the Linux Foundation hosting networking project. This is a realization of all the synergies that exist there between the Linux Foundation networking project and the ORNSC community project, and also, as I said, an attempt to be efficient and stop confusing the industry with bifurcated initiatives. So the code is not going to go anywhere. It's just going to go under the Linux Foundation networking, and as you see, we are planning sort of a smooth transition where, first of all, we will move all the code and all the repos just to organizationally under Linux Foundation networking. Once that is done, we'll start conversations, project-wise conversations between project pairs of the ORNSC and the Linux Foundation networking to try to figure out synergies and efficiencies. This is a list of most of the sub-projects under the ORAN software community, what has been developed in the last few years, and also some suggested mapping to where the synergies exist with LF networking project. This doesn't mean that these are the only type of integrations or collaboration, but these are the more obvious areas where we expect to see these discussions going on about joining forces and maybe merging some of the code. The two components highlighted with these orange circles are probably where the ORNSC software is most advanced. So if you're looking for a non-real-time rig or SMO components, you should probably start looking at the products of the ORNSC community, which will soon transition to LF networking. The next project I want to talk about is ONAP. How many people in the room have heard about the ONAP project? Okay, good. So, so even if you haven't heard about it at all, or if you heard about it before, I think I might have some news for you today. The biggest maybe transformation or change that ONAP is going through is it started quite a few years ago as an end-to-end platform, a big monolithic project with many components, but it's kind of aimed at solving all the network management and orchestration needs of telcos, communication service providers. And that was a good thing on one hand because it was very comprehensive. On the other hand, what the ONAP community learned is that it's very intimidating and it's very setting the bar very high for adoption because not everyone needs this full set of components for management and orchestrations. Some organizations might already have a good solution for some of the components of the management and orchestration layer, but they do see value in some components of ONAP. So what the ONAP community wisely did about a year or so ago is to move into a more modularized approach where ONUP is just an umbrella for a set of semi-independent projects that have their own release cycle and have their own small community around them that are delivered separately but also can be consumed independently. So if you really like, for example, the inventory management that is provided by ONUP, you can now use just this component. And of course, ONUP provides many of the essential components that are required for managing and orchestrating 5G networks. But now these components are delivered in a kind of semi-standalone with their own CI/CD cycle, so they can innovate faster and be consumed separately. And the guiding principles of ONUP have not changed over the years. I think there's communities still very much focused around well-defined APIs, and now with more adoption of the more popular modern GitOps approach. And also another tenet of the community has always been to align with industry standards, ETSI-NFV, obviously, but many of the other TM Forum and others that are relevant in this domain. So if you're looking at a management solution that is compliant or aligned with industry standards, then ONUP is probably where you want to start looking. And as I mentioned, you have kind of a catalog of different components that you can mix and match with your own components. So this is basically the big change, moving from this platform end-to-end, all-inclusive architecture to a set of about 12 components these days, but it might change, that can be consumed, are self-supportive, self-consumable, and provide a clear and specific task. Speaking about ONUP, I also want to mention Nephew in this context. Nephew is another LF networking project that is more aligned with the Kubernetes way of doing things. It's an extension of the Kubernetes control layer and Kubernetes API for managing and orchestrating network functions. And this community is also providing some of the functionality needed for managing and orchestrating and deploying ORAN network functions that are mostly cloud native or designed to run on a Kubernetes environment, meaning they are more a CNF, a cloud native network function. So if your network function at hand is very cloud native and designed to run on Kubernetes, you might want to take a look at Nephew and see how it can help you deploy and manage your network function. Obviously, with the help of some community members, some from OAI, the Nephew community is building in functionality that is relevant for orchestrating specific ORAN workloads, especially with the O2 and IMS integration. Another open source initiative that kind of merged into the Linux Foundation recently is something that used to be called the ONF, the Open Networking Foundation. They were working on developing a project or initiative called Ether with an A, basically an SD-RAN implementation. And it included both a RAN side and a core side. And they also had very nice progress and mostly produced very high quality components of these two components, the near real-time rig and the UE SIM. Again, it doesn't mean that these are the only implementations. You heard about the UE coming from OAI, for example. This is another alternative, but if you just have to choose, I recommend you take a look at the UE SIM coming from Ether. It's very rich in features and functionality. Another initiative that also part of the Linux Foundation is LF Connectivity. LF Connectivity is another sub-foundation that is hosting RAN or networking related projects. Many of them originated with Meta or Meta connectivity and were donated to the open source community and brought to the Linux Foundation. So Open M-Plane is one of these projects that is focusing, as the name suggests, on the M-Plane, the management plane as defined by ORAN, and they have quite a mature solution for implementation of the Open M-Plane that was tested and is still being integrated with different radio units. So if you're looking for doing something in the M-Plane, take a look at Open M-Plane. Maverick is another project that is under LF connectivity and had the same history of being conceived within Meta connectivity. Maverick is a nice project that provides basically a digital twin environment for simulating a radio access network and building RIC applications. So if you're doing anything in that domain, take a look at Maverick and see if it can help you accelerate your development. So no open source or no end-to-end solution is complete with just the RAN component. You need to bookend it with some core network. And in the core network space, there is also a wide variety of available open source solutions. Could be confusing at times, I can admit, but diversity is good, and I will maybe say a few words about it at the end of my presentation. So the Magma project is one of yet another project that was started back in the Meta connectivity days and is now part of LF connectivity. Magma provides an open source implementation of a mobile packet core with a kind of unique approach that kind of redefines the internal boundaries of the components of the core network, but still preserve the 3GPP specified interfaces toward the outside. It's very popular among kind of alternative radio approach players, especially CBRS, and it also has an LTE 4G implementation in addition to 5G. The Free 5GC, I think, needs no introduction. I think it's one of the most popular open implementations of a 5G core. The good news is that about a year ago, the project, or a little bit over a year, this project also moved under the auspices of the Linux Foundation and is now a public domain or a neutrally governed project. It originated in the Research Institute in Taiwan, if I'm not mistaken, but it's still a very active project and is kind of considered the de facto standard for open source mobile packet core. SD Core is the other part of the Ether project that I mentioned, the Ether with an A, also originated under the ONF, but is still maintained and still growing, also is very feature rich and still has a decent community around it that is contributing and adding features to it. And maybe one additional project from the LF connectivity that doesn't really fit exactly in this 3GPP ORAN architecture is Terragraph. So Terragraph is kind of an alternative to the 3GPP way of connectivity. It provides 60 gigahertz wireless connectivity and kind of a mesh architecture. And originally it was designed to connect remote areas, rural areas, where the 3GPP standards are maybe not efficient, and it proposed an alternative approach. So if you're looking for innovation and mesh architectures for wireless in the last mile, take a look at Terragraph. And this is, I think, the most important slide in my presentation. First of all, I think if you didn't get the message so far, there's a lot of open source out there. Go out, try it. It's very kind of easy. It's basically free to use. So don't be afraid to try things. And I think with the proliferation of coding tools and code generation tools like Claude Code, it's becoming even easier to consume open source technology. You don't even have to read the documentation, go through the tutorials. I think that we are quickly adapting to an era where you just ask your coding assistant to use some project and it just does this. By the way, we have hot off the press, we have one of our community members in Okudu last week created a Claude skill that works with Okudu and lets you deploy and monitor Okudu, so you don't even have to read the documentation as Eric suggested. You can just use this skill, speak in natural language to Claude Code, and it will do all the work for you. So I think that's a kind of the way that we will consume open source projects moving forward. So let's all get used to it and be more flexible with the way we use open source technology. By the way, the flip side of it is that, and I'm saying this to our hosted open source projects needs to be more consumable by these coding agents. So it's not enough that you have great documentation on the wiki and great video tutorials. You need to create an MCP server and maybe a Claude skill or Gemini gem so that coding agents can consume the project. So I think this is something we're also adjusting to these days. And of course, use these projects to innovate in any way you can think of. I mean, sometimes people ask me, can this open source project do that? Can that open source project do this? My answer is maybe, you decide. I mean, people need to realize that open source projects are consumed differently from commercial products. It's for you to experiment with, it's for you to change. So be creative, that's my message. And of course, when you make these innovative changes, don't forget to contribute them back to the community. There's a temptation to create your fork, but please, please don't do that. It never ends well. So please spend time and a little bit of effort to contribute back to the community. And as you do so, let's try to avoid more fragmentation. I hope I didn't confuse you too much, but I think you noticed there's already a wide range of open source implementations for open networking. So please pick and choose one of the existing ones and don't create yet another initiative. That's my final message. Thank you for listening.
Thank you. Thank you so much, and looking forward also to the panel that you're going to be moderating this afternoon on community engagement and actually how we can bring the community together around this project. Thanks again. So the last talk for this morning does not come from an open source project, but comes from the government side. I'm very happy to have here Lauriston Hardin from NTIA, who's going to discuss about the NTIA's AI Run solution, Notice of Funding Opportunity.
Okay, I know that I'm between you and lunch, so I'm going to move as quickly as I can through this process. As most of you probably know, about a month ago, before MWC, our Assistant Secretary of Commerce and Director of NTIA, Ariel Roth, announced that we would have an AI RAND NOFO, and that the amount of funds available is on the order of $50 million. Now, I'm going to disappoint you right now and tell you I'm not going to tell you the details about that because it's still in process. So what I'm going to try to talk about today is the policy that's driving this, and you can glean from that different ideas of how we're going in the process. So let's see, did that work? All right. How does this? I push the green button, is that correct? And nothing happens. Okay, there we go. Okay, good. Wow, that looks a little strange. So, obviously, the U.S. government has created some policies around what we think about AI RAN and what we think about 6G. And so you'll see this in both the the AI action plan. There's also an AI executive order. It's got a longer title than that, but you can look it up. And there's also a 6G executive order, which I believe was entitled Winning the 6G Race. So I recommend the reading to you because they're going to give you the foundation of how the U.S. government is looking at AI and our position there in the market, and also 6G, which are both of the subjects we're discussing today. Understand that NTIA is part of the Department of Commerce. So part of our goal is to promote U.S. companies and U.S. interests in the process, but we understand this to be a global market in the process. So what we want to talk about today is what is when we said AI ran notice funding opportunity, it's really more about an AI native architecture and the associations to that architecture. So we'll try to talk about that in a few minutes. I am an engineer, so I do like to talk detail more than policy. But let's get through the policy concept first. So if you look at it, we look at the marketplace. So where does the U.S. have strengths? And obviously we have strengths in AI. We have strengths in software. We have strengths in compute equipment development. So we look at those and say, well, where does that fit into the architecture? Well, if we look at some of the pillars that are in the AI action plan, obviously we want to accelerate the integration of AI capabilities into the networks. And that's not just mobile telecom. If we want to look forward, you can look at, and I think the industry would generally agree that, say, 10 years from now, we're probably going to see a much more converged network than we have today. Whatever that convergence looks to be, I'm not going to say it all converged into mobile, it all converged to fixed, just it's going to converge. What we would like to see is the U.S. companies to be able to have a more significant role in what we would call that network fabric in the process. And also, hopefully, one of the things that we think about from the innovation from a standpoint is can we accelerate that activity? Obviously, we would like to see the U.S. companies be a foundational piece of that process, and I think right now, within AI, they are. So, and obviously it gives us an opportunity to work with our allies and with our partners to see a more pervasive environment with the AI stack that we're looking for. We'll talk about what that means in a minute. So, when we talk about, I started working on this AI native RAN notice of funding opportunity a while back, and the first thing was to say, what is AI native? And we got 100 people in this room, so if I asked, I'd probably get 105 opinions about what AI native is. So let's just talk about a couple of them first. Certainly, you can go to IBM, and they say it refers to something, essentially a product that is designed for the ground up with AI as a core component. Okay, that's an interesting thought. Then, of course, you can go to ITU, which I will encapsulate this to say ITU basically thinks every network element should be able to sustain an AI workload. So those are very interesting thoughts, but what does that lead us to as far as what does this network look like? So we really look at three key components in this process. First, you've got a common secure, and we'll talk about secure, compute environment. So you can handle any workload. I don't care if it's an AI workload, a telecom workload, an IT workload, workloads that we don't even know about yet. That's the underlying substrate, if we want to talk about it, that a network has to have to be what we would call an AI native, or in this case, we're really talking about a network that can support all those workloads. Now, that environment would also allow the network data exposure that you need. We've heard talks today about the data lake problem. The data lake problem's been here. I will say most probably in our notice of funding opportunity, we aren't going to solve the data lake problem because that's a long-term problem that requires a lot of interaction. But the idea here is you've got to think about it in two ways, and Alex and I had a talk about this last night. It was very interesting to say. First off, you've got the data you need to train your model, to validate your model, and to run your model. But then think about the other side is you also have to have hooks back into the network for your model to actually do something. So when you think about how you're structuring a network, you've got to think about those capabilities. When you're thinking about what is your AI model, what does it need? What data does it need? Remember that some of that data is proprietary, is confidential, and is owned by somebody else. So when you think through that process, you're going to have to think about how do you build that concept into your business plan of saying, how do I own the data, or how can I get to the data in the process? And finally, and one of the most important things for the U.S. government in moving to 6G, we'll say, or I actually like to say next generation network because I'm kind of tired of the Gs, but it's that it's got to have cybersecurity by design. And this isn't, the interesting here is you can look at it a bunch of different ways. From a data standpoint, data at rest, data in transit, or data in use. That's a lot of places to worry about security. Then you have to start moving back to model security. And then you have to move back to training data security. It doesn't take that much bad data to corrupt a model. And then you've got to look and say, all right, now I have multiple models. And I'll step back for a minute to talk about the environment, because I think we've had some interesting talks today, but we haven't differentiated very cleanly between a foundational model and other models. If you look, especially at a telecom network structure, you're all the way out at the edge. You may even be in the UE on the other side of the interface, all the way back to the core and to a data center somewhere. There's going to be different models in every part of that network. And they're going to operate on different time frames, and they're going to operate needing a certain amount of data. And you can also look at them in a structured standpoint that you've got a small model. This model will take a little bit of data, and it'll output a few tokens that go to a model in the middle somewhere that takes that in, does some more inference, and sends tokens over to a foundational model and moves back. Those sort of structures are going to be necessary in the environment in which, telecom environment, which Alex made very clear, it's a real-time environment. And it's a real-time environment that you can't break, because if you break it, first thing that happens is you get fired. But beyond that, it's just not good to do that. And the other thing, while I'm talking about that network side for a minute, is one of the areas about testing that you're going to have to know is then the reason MNOs spend so much time is you've got to test every corner case. You can't test 95%, 98%. You've got to know every corner case has been tested, because those are the ones that break your network in the process. So going back to cybersecurity, all of the elements are now important, especially as we move models. And then even to the aspect of what is my orchestration of all those models? How secure is that? What's the access to that? These are fundamentally important to how we move forward with AI in a U.S. and hopefully allied countries as far as an AI RAN environment would be. Now, many of you, some of you here I know were in for we had a listening session last Monday, yes, or Monday a week ago, with industry to talk about what is this whole AI RAN idea, because we obviously need that input. Let's just give you a quick summary of the companies that registered for that event and came to it. Here's a quick run of the questions that we asked. We asked simple stuff at first. What's AI doing in wireless telecom networks? What are the changes that are being driven by that as we're moving to this new next generation stack? What architectural changes do we need? How do we advance this through U.S. AI leadership? And then the question for everybody, and the question that's brought up several times today, is how do you monetize this? And so I'm going to throw an idea out just for people to think about a minute, because we talked, and I know there was a question, I think Lincoln brought up the question about brownfield versus greenfield. I want you to think about something a bit differently in the process. And now this is Lauriston Harden speaking. I'm not speaking on behalf of the U.S. government, and this is not a piece of the U.S. government at the moment. I'm just going to talk about one way of looking at next generation networks or 6G. MNOs have not been able to monetize 5G for any number of reasons. There's plenty of questions going all around while that's happened. So the OEMs, here we talk about the Ericssons, Nokias, Samsungs of the world, have gotten a fairly clear message from MNOs that we don't want new hardware. We've already paid for this hardware. You want to give me new software, that's great. Now, the only time that changes is if there's new spectrum. Because if there's new spectrum, and let's assume it's in a band that we didn't think about before, everybody's got to hang new radios. Okay? That's the process that goes on. Now, let's take a moment and say, if somebody hands me new spectrum, what am I going to do with that new spectrum? Am I going to do the same thing that I presently do? Most probably, that doesn't necessarily make business sense. What I want to do is a new use case, a new business case, something that new spectrum and hopefully this AI native environment creates that wasn't created before. So when you look at it that way, you can say that 6G is actually an overlay technology. And everybody hates the way I say that because they think that's just, there's no hardware change. There's not. But you're putting in new hardware for a new service set, not for the present service set. So when you think through this in the process of what does an AI native architecture, a secure AI native architecture, give you the opportunity to do, it gives you the opportunity to do a whole new service set. You've heard discussions today about the new traffic. OEMs will tell you new traffic is always driven by new devices. I think, Alex, you mentioned new devices in the process. And that's where you've got to look for new use cases. And are those devices, this device here? Maybe, but I think there are other things. I think there are healthcare wearables. I think there's personal robots. There's a lot of different things that drive new devices, new uses in the process. So when you start thinking about use case, you think about 6G, think about AI and the network, think about it from those use case standpoints, and don't necessarily be bound by the present service set. Present service set will continue to exist and can be moved over at some point into another environment if that makes sense. So what do we hear from some of the things we heard? Of course, we know that AI can improve the network performance. And there's certainly a lot to be said about trying to lower the OpEx. And MNOs want to lower their operating costs, period. And they want to do that in a bunch of different ways, whether it is just saving power or maybe eliminating some cell sites. There's a lot of different ways they want to lower their operating costs. So this, and increase their performance. The other thing you may not think through before is that if we take the US market, for example, there are no new subscribers, guys. Everybody's got at least one phone. So if I'm an MNO, how do I get a new subscriber? I steal them from somebody else. How do I do that? By either having a new service or having services better than the other guy. So that's, once again, goes back to the issue of you can't have failures in your network because all of a sudden you lose subscribers because they go somewhere that didn't have a failure in the network. You know, the fundamental thing, though, I was talking a minute ago, they got to be tied to business needs. In other words, there's got to be a fundamental reason why, I will use AT&T example, that AT&T CEO will go to his board and say, I want to spend X number of billions of dollars for this. There better be a good case as to why I'm doing it. Either I'm saving a whole lot of money or I'm making new money or both in the process. The issue that I'm bringing up today, and that's part of the way we see, and hopefully will be part of what we see in our NOFO, is trust. And it's not, and security. And security is one thing, but trust, it's an interesting question. How do you trust AI models? How do you know how to do that? Well, that's going to be on the issue of how they're designed, how open they are to inspection, how well the data is curated that it's trained them, and then how has it, what are the guardrails, as I think Alex brought up the concept of guardrails in the process. That's a very interesting one. What are the guardrails about how they operate, how they're trained, where the data comes, makes a big difference in that. One of the things that we've also noticed, and why we're considering what we're going to do with this next notice of funding opportunity, is that innovation has overtaken the standards timeframes. Before now, especially, I've been around since pre-1G. So anyway, that those standard times of 10 years with 5 years in between where you get the advanced side of it have been overtaken by AI in this process, exactly, and by the compute capabilities we now have in the process. So we have to think about that, and how can this fit into and help lead the standards bodies going forward in that process. We've already talked about data sharing and access. It's a big deal. I think the answer is probably figuring out the correct commercial model in the process of how that data can be shared by its owners, by example, MNOs that have it. How do they monetize that data? It's important to them in the process. And obviously, USG would like to align AI standards and AI initiatives so that there is something that can be bundled, if you want to look at it that way, and brought to other countries in the process. Okudu has gotten a lot of press today, and it's moved very quickly. It's a very interesting concept to think about in the process. And I will also say, U.S. government still likes Open RAN. Don't get me wrong, we've got $550 million invested through the first 2 NOFOs of the Innovation Fund in Open RAN that has seen great results. The other thing I'd like to bring up there just to let you know is there were 2 specific research areas in each NOFO. The first one dealt mostly with 5G advanced, but the second one in all cases was a 6G or AI event. Like DeepSeek has several of the awards in that AI area. So the NOFO and what we've done in Open RAN isn't just for 5G. It's also been moving towards developing activities for 6G. And there's other networks. There's other networks, whether it's, and here, when I talk about convergence of networks, it's all the networks. How do they converge? Where do they converge? Who orchestrates that all in the process? I mean, can a 5G or 6G core with non-3GPP inputs control a broader range there? It's an interesting question to go on, but that's something that was raised in the process of we've got to address orchestration. And I think that gets me to the end. You can find more stuff on the websites, and also the entire listening session, if you'd like to listen for the whole time, was available. And at this point, I divine any questions, but remember though, if you ask me a specific question about the NOFO, I'm going to say you'll have to wait and see.
All right, thank you so much. Thank you very much, Lauriston. Any quick questions? Lunch is ready, but we can take a couple of quick questions.
So kind of question that I was going to ask before. So we pointed out here that the speed of the standards is quite slow, and then now we're developing stuff more than that. And Alex pointed out that you have your greenfield and your brownfield sites, and you don't just have a brownfield site, you have a brownfield organization and structure of that organization. So are we going to restructure how standards works and is developed, rather than a pool of multiple companies developing stuff which you try really hard to make sure you're congruent with, when maybe there's some built-in errors, uncertainties, misunderstandings?
Okay, well, we also, I'm also part of the IORS project at ITS, which is International Open RAN Symposium Project. And we had a virtual session last week that, in fact, I was in, Alex was in, and Dan Henry and Shariq Ashoff from ITS. And Dan Henry, who is with the OPAD, or Office of Policy Analysis and Development at NTIA, and is responsible for standards within NTIA. He had a comment to that I'll just repeat so I don't get in trouble. That, you know, when things evolve, sometimes death can occur. You know, it just has to. I mean, there's creation, there's destruction. So in the process here, as we're evolving into a new environment, there will be evolution within the standards organizations. We, as the U.S. government, that's an industry activity. That's not a U.S. government activity. But, and hopefully they can evolve together and create a stronger approach to standards. The other question that I just raised is what is your expectation out of standards? If you're a vendor, you have one expectation. If you're a user, you have another expectation. And so, and as we move in this environment, you're going to see other standards starting in place. No longer 3GPP under an alliance. It's also TM Forum. It's also IETF. There are other areas where standards will now become more important, especially as we move into, say, network automation, where we need TM Forum level 4 and 5 sort of activity. So, Howard, the answer to your question is, I think they'll change, but as far as the U.S. government, we support the standards organizations, and the industry will move forward with those changes as necessary. Was that good and political? Yeah, thank you.
Thank you. Thanks, Lauriston.
Thank you.
Another round of applause. So lunch is ready at the back of the room, and we're gonna restart at 1:30 with the next panel. Hi, everyone. Good afternoon. I hope you had a good lunch and some opportunity for networking. We are going to restart in a couple of minutes, so if you can head back into the room, we're going to restart with the first panel of the day. And please come back, bring any lunch that you want, and also bring your strong opinions so that we can have some good discussions. All right, let's get back to it. This afternoon we have a program with we are going to have 2 panels. On the first panel will be on software development and like implication of that when it comes to run software, and in general the end-to-end 5G ecosystems. Second panel will be on data and the relationship between data and open source that has also been mentioned this morning. So then we're going to have a break. The presentation of the hackathon results, at least the hackathon output, 2 more panels, and then we're going to announce who won the hackathon and enjoy some drinks and appetizers. So with this, I'm happy to announce the panelists on stage. Florian Kaltenberger from Open Air Interface. Eric Luther from SRS, or Okudu. Timo Shi from DeepSeek. And with a red sweater, Andrew Toth from Red Hat. All right, maybe if you can give like a 1-minute intro about yourself and what you've been doing, maybe except we know Eric at this point, but Florian, Tim, and Andrew.
All right, thank you. Yeah, thank you, Michele. Thanks for the invitation to this panel. I'm honored to be on the same panel with such distinguished experts. My name is Florian Kaltenberger. I'm a professor at Eurocom, so same place as Raymond, so I'm one of Raymond's colleagues. So I've been working with Open Interface ever since I joined Eurocom about 20 years ago. So not as long as it has existed, so I joined a bit later. Actually, it was Raymond who hired me. But I've been working a lot with that, starting with 4G and 5G. Mostly on the lower layers, physical layers. So my expertise is more in multiple antennas, MIMO, physical layer stuff. I also spent 2 years here at Northeastern University, from 23 to 25. That was a great experience to work with the guys here on AI RAN. It was at the start of AI RAN. I worked a bit on the X5G platform. So yeah, still with Open Interface. So that's my that's my expertise.
Thank you, Eric.
And Eric Luther, SRS.
Tim.
Hey, so thank you for having me here. Definitely excited for this panel. So I'm Tim O'Shea from DeepSig, and we got going. I guess I spent a lot of time before DeepSig working on GNU radio and software radio and modulators and sensing tools for lots of different types of air interfaces. And then when we got DeepSig started, we were just really excited about how transformative deep learning had been in computer vision and natural language, and kind of we're all in that this is going to also transform wireless communications and the air interface. And so that's kind of what we've been trying to do ever since. And, started to look at, especially in the physical layer, how can we bring some of these ideas into LTE and 5G and maybe 6G. And so that really got us into the Open RAN world of, we can work with vendors that are building stacks there and have an impact. And now that Okudu is going and OAI is also out here, we're really excited to see these fully open stacks become more mature and more available and closer to market, because it means we can take all these crazy AI ML ideas across the whole stack and hopefully bring them into reality. And so, I think super excited now with the momentum in this whole area. And with AI RAN, even in standards, but now also in all these pre-standards activities like Okudu and AI RAN Alliance that are trying to move much faster. And so very excited to help telecom move, into the speed of software instead of just standardization.
Yeah.
Thanks.
That's definitely a good change, and being able to show how things work before you bring them to the standard is beneficial. Andrew?
Yeah, so Andrew Toth. I am actually a NU alum as well, 04, so glad to be back. I am a engineering manager. I run a crew at Red Hat that does telco emerging community engineering work. So we are working in all of the communities that you saw today and more, partnering with the vendors and the operators to better the state of open source RAN and telco software.
All right. So I had a list of questions prepared, and I think more or less we're going to get to them. But considering what we've all seen this morning and all the discussions about AI and software development, let me start by asking, do you use AI tools in your software development cycle, or does your team uses them? And if yes, what and why? If no, why and when are you going to start using them?
All right, let me try to start. Excellent question, and I think this is all changing as we speak. So we had exactly the same kind of discussion on the corridors these days. And as far as I know, at Open Interface, until now we haven't really used those tools much. I mean, some of the developers have, but I think we're going to use them more and more. I think we recently got a subscription to Claude, so that we can really ramp up this activity. Because as we've seen also in the talks from this morning, that's the future. That's going to make us all more productive and will make our code better and better quality, hopefully.
Yeah, I think the short answer is yes. We've been using AI in our software development, but what we found is that different engineers have different workflows. They have different tool preferences. They have different levels of context they need for what they're trying to do. And so just in the last few weeks, there's been a lot of discussion about, hey, can we get this 3GPP document into markup so that it can actually be read? What do we do about the diagrams? So there's places where AI is helping right now, and there's AI, and a lot of the high-level discussion is it will generate code really fast. And so if you're going to code for an hour, it used to be code for 45 minutes, debug for 15, and now it's, in some cases, generate code in 5 minutes and debug for 55. So there's, but there's also other experiences that are much more efficient for testing and other roles. So I think we'll unpack a lot of these topics a lot further in this discussion.
Yeah, I mean, we're absolutely leveraging it as much as we can. I think the entire software field is changing so insanely fast right now that you have to figure out these workflows and embrace it. And, you know, it's to the point where these traditional companies that build a full RAN stack might have 10,000 or 20,000 people. And with, you know, the AI multiplier, you can do this now with, maybe 1,000th of the people or something, like 100th of the people. So it's a tool we have to figure out how to leverage. So I think we all at DeepSig suffer from this psychosis where you can't sleep at night unless all of your agents are burning all of the tokens you possibly have. I think that's an important thing to focus on every day.
Yeah, and for us, you may have seen recent press that has gone out there about, statements that have been made within Red Hat about us changing our whole lifestyle to more of a agentic AI-based development cycle, and wanting to help bring that to the communities. So for the teams that I run, we are definitely using it within the communities to actually help with things like MR reviews and MR rebases, things like that as a first step. Like, how do we get fixes in faster based on reviews? So we've been using Claude and Cursor and things like that to help with that. Other steps is when we get into a project, we use it to go and just scrape everything that's on the project website and give us that synopsis about what is this project about, what is the architecture about. It gives us that quick deep dive into how do we get involved quickly with these things. And that's pretty much the first step into that kind of transformation of work processes that we're going through.
And as maybe people who steward or kind of represent open source projects in different ways and capacities, any concern with having contributions that come in that are AI generated, and any thoughts about managing that? I know it's a new question, but
yeah, I don't know. I don't have a good answer to the question, and I think it's a clear question that's on many people's minds today. I don't think that as a community we have figured out yet how to treat those contributions. I mean, right now, to my understanding, it's still the person behind it still takes the full responsibility. But that might change in the future. But how, I don't know. That's maybe something also that the Linux Foundation can provide guidance on in the future.
Yeah, so I also have the opportunity to moonlight as an adjunct at another college in the area. So the one thing that I tell my students, right, is AI will give you an answer. It's your responsibility to know if it's the right answer, right? And that goes the same for the community, right? We can generate all of these agent chains and everything that we want, but in the end, it's still the human eyes that need to go in there and make sure that the answer is correct. So as long as we keep the human in the chain until, again, it gets back to that trust factor, AI is non-deterministic, really. So you can use it and trust it to an extent, but you have to stay in the loop when it comes down to contributions and things like that.
Yeah, I would add, I think Alex had a nice slide earlier with the different agents serving different roles in this process. And I think like using AI also for the validation and the vetting of pull requests and tests and automating and moving faster, like you need all of these sides to accelerate, because we can't manage it if just contributions accelerate that way.
Yeah. And like you're all, maybe not all of you, but most of you are developing also signal processing software, right? That has some specifics, needs to have some like constraints, requirements, and so on. And it's very different from a web UI for an HTML website, and there's probably less of a training corpus in these LLMs related to this. Any concerns that you have in kind of trying to use LLMs for more like real-time or like specific accelerated software?
Yeah, I think that when you're looking at digital signal processing and you're looking at, I've got a particular target that I'm trying to run my code on, I need a particular resolution of the data, meaning can I truncate bits or whatnot. There's a lot of processing that has I put in a number and I get a really robust answer out. And I can evaluate that against a MATLAB simulation or something like that. A lot of the standards work that we're doing is state machine based, and it requires a handshake in order to understand whether something is functioning correctly. And so the way you design, the way you would prompt, the way you test is completely different in a handshake system versus I'm trying to optimize an LDPC decoder or for a particular target. And so in many ways, we're using an LLM as a general large language model when these applications are very, very different.
And by the way, if the audience has any questions at any time, just feel free to use any of the mics that are around the room. Okay. You want to add something?
Yeah, no, I would echo that. I mean, I think it just makes the automated testing that much more critical, right? Having performance and sensitivity testing and all sorts of different KPIs for physical layer functions as well as latency, and all of those have to be vetted in a loop so that you can use these tools to optimize.
So basically giving them a harness in which they can play.
But I mean, it's actually really incredible how well a totally general model like an Opus 4.6 can handle all of these domains with sufficient context. So yeah, it's incredible.
Good. And
yeah, I just like to turn the discussion a little bit, because I'm also professor at EURECOM, so I teach I teach students, and I do teach it's called communication laboratory, so it's for first year master students, and we do simple things like simple OFDM transmitter and receiver. And so I ask the students to do that with software-defined radios. And of course, in recent years, they have been using AI to generate their code, their Python code. And I have to say the results were quite weak. Okay, so and I think there were and the students. The problem is that the students, at that age in their career, they were not able to really see the problems with the code. So they were getting code, they were testing it, they were getting some results, and they put this in their reports. And only then I told them that was not correct what they did. So these agents, these LLMs, they take away, they help us with our coding work. But they don't take away our thinking. So I think it's important to add to the discussion also the fact that we still need to train students to be able to critically think and understand the basic concepts of wireless communication, of signal processing, so that they can actually analyze and determine themselves if what the LLM produced is actually useful or not.
And actually on this, as I was mentioning this morning, and we're going to have a presentation later, we've been running this hackathon in these last few days, and I did ask a question the other day on the Slack that we've been using, like to react with a llama if you're using LLMs to code, or to react with a red dot if you're not. And we got 22 llamas and 3 red dots. So that kind of gives you a sense. And I can say that whatever was developed or generated is probably better quality than what you had in mind.
Well, we'll see from the results from the hackathon.
We'll see, yes, but that's I've seen the results, so that's what I'm saying. This, and so it kind of speaks to the point that we're making, right? Different level of maturities are needed to approach these tools and understand what they do and what they let you do potentially. All right, so maybe just changing back into the main topic for this panel, which was AI run and software for AI run, right? I think the connection to the signal processing point that we made is good to the next question I want to ask, which is, so we, especially when it comes to AI in the run, we have some open source solutions. One has been developed from scratch for a GPU. So let's ignore that for a second. We have other solutions that were primarily CPU based, and now they have to deal with this emergence of AI in the run. And so what are the most significant architectural changes that you need in the software project to support AI run, and how do you think how disruptive they will be? And for example, will you accept an AI model as part of a pull request to your software?
Should I go first? Yeah. All right. So in terms of architecture, let me try to maybe jump on this point first. And I think it's very important that when we write the software for the RAN and other parts of the network, to have this in mind that we might want to swap some of the algorithms for an AI model. And I think so from an architecture point of view, it's important from the start to design the software that you can do that. So write some codes but I mean in general that's anyway good practice anyway for writing code. You put it in libraries and you make the APIs general enough that you can swap some parts for other algorithms, an AI model or whatever. So FAPI interface is a very good example, and it allows exactly to replace the layer 1 with a maybe more optimized layer 1 that runs on a different platform like a GPU. But you can also do this with today. You can already do it with LDPC. With the channel coding, you can. They find interfaces to replace that. But I think we need more of those. And there are some experimental versions of Open Interface that do that. For example, the Siona Research Kit, they provide patches such that you can replace certain functionalities like the channel estimation or the demapper, also with AI models. And I think that's very important. And I think that's part of good coding practice. Should be part of good coding practice today.
Yeah, I'll concur with that. The push for the past few years has really been, cloud native, right, and microservices and all of that. So the initial architecture of your product that you're putting out there, if you're adhering to those new, base ways of architecting, it shouldn't affect you all that much. You should be able to just use the APIs that you have, plug in your different models and your different approaches. But if you're monolithic and you're still doing a base monolithic approach, then you'll have problems. You will definitely need to re-engineer things to start bringing in the AI inferences and things like that along the way.
Yeah, I'm going to take a different approach and just say documentation. When you start looking at things like standards, your context windows are limited. You have a token count and a level of memory that you're able to deal with. So you really need to be bringing intent along with the code that you're developing, so that intent is near the code that you're going to be modifying or updating or changing, so that at least the most obvious issues are going to be avoided because the context is being captured during that modification.
So you mean like inline documentation that carries forward with the code, or like more like documentation for pull request or for contribution?
I don't know exactly how it's all going to be done yet. Certainly inline documentation has served a purpose so far, but oftentimes even just referencing this particular piece of code is implementing a certain part of a standard, so that there are ways to reintegrate context and modularize whatever I'm trying to manipulate.
Yeah, I think we've seen like an increasing number of ways these can intersect, right? Like we had the 3GPP interfaces, and then we had the ORAN interfaces, and we have these things like E2SMs that can handle certain use cases, and now there's discussion of DApps and maybe SMs that go for different DApps. So we've been increasingly having new ways to integrate that slice kind of more different places into the RAN. And I think the limit now is just that the whole thing is open, so you can kind of slice in anywhere. And a lot of these things like DApps are really nice for some things, but if you're fusing into the receive pipeline, you need like 30 microsecond deadlines. So I don't know. I don't think anyone has the right answer yet for what is the correct abstraction. But like this whole agentic coding also is starting to make it that maybe interfaces don't need to be as locked down as they did before. So yeah, I think we're still searching for what is the exact right abstraction to enable this whole integration cleanly.
In which directions do you think we should search? Like,
I think so. The approach we've been taking, at least with Okudu and AI RAN, is to start looking at what are a dozen of the, I think, most critical AI RAN use cases, and then look at them from a performance first and efficiency first perspective to think about how can you integrate these. What does this need to look like? First, can we do it, all on a GPU where you're fusing AI and L1 all together, but then also cross-platform, like how would you do this on an Intel or ARM or different architecture? Trying to get a comprehensive look at the needs and the requirements and how to get there.
I think then the other challenge when it comes, besides from a software point of view, right, the other challenge of supporting AI for RAN or AI in the RAN is the infrastructure. So where do you get to deploy AI? How do you deploy it? How do you manage it beyond just integration in software, right? Any thoughts on this part? Maybe Andrew, do you want to?
What was the main point of that question?
Main point of the question is, how do you think, we just discussed how to manage AI from a software point of view and integration with the stack. When it comes to like an MLOps life cycle where you deploy actually this AI algorithm on different platforms, compute and so on, how do you think what do you think are the best practices to manage all of this?
Well, one of the things is, MLOps is new, right? And we've had OSS, BSS for forever. So when it comes down to the mainline functions, the real-time functions, things like that, it possibly would be the best practice to leave those alone at the beginning. Make sure that's going on, and then add on the MLOps on top of it. Like we're going through the GitOps transition. MLOps is just kind of that next step of this, right? So being able to update your systems, revision your systems, deploy your systems through a known good way, adding agents on top of that to start running those systems, right? Baby steps at a time. Make sure that your initial systems are running well. Add the ML into it, and once that is vetted, and again, this is the whole trust thing, right? You got to understand your trust factors here. Then you can start integrating it in more, right? And replacing some of those GitOps with the MLOps. I still don't think you would ever get rid of your GitOps because you'd always want to know what that agent was doing over time, so you can go and have that audit of it. But that's where things are starting to go, though. Is we're looking into that across all of the communities. There's all pieces of every project now looking at how you operate these things with AI. So it's again, green field for a lot of this. But yeah, it's a segmented thought process right now of making sure that you have your system working and then tacking on ML to it. But yeah, as you go through, it's iterative, and you keep working with the tools. And as we know, the tools are moving fast, right? We don't even know what tool to use at this point, right? Because they're changing so often. So it's really just iterating, making sure that you're building that trust and see where things go.
See, we have a question.
Yeah, so thinking about what you said, Tim, of loosening up the specification of interfaces or maybe not having them as tightly defined. The question is actually, so right now, all of our interfaces between components and stuff like that, external to us, an individual project, are coming from like standards organizations and hitting on that. If we start backing away from that and say, okay, we're going to loosen up constraints so that the AIs can work more efficiently, we do that for round one, and we come up with something. But then what's our view? Where do we see this going for like rounds 3, 4, and 5, right? So now we don't have a standard. The models aren't trained on the standards anymore. And you want to build something new. And then what does that mean for future interoperability, future compatibility of things? And how do you drive that?
Yeah, I think that's okay. I mean, I see it as a layered system, right? You have your 3GPP layer, your Open RAN layer, and then maybe you have things like these AI RAN Alliance blueprints that layer on top of that, or just software reference implementations in these open source repositories. They're all kind of different levels of maturity and rigidity as far as a standard. But I mean, we can look at desktop Linux, right? You have a million different interfaces in a desktop Linux environment that aren't established through official SDOs. They're kind of through technical convergence in software, and that works totally fine. So I don't know exactly which parts of the RAN are going to be best suited for which layers of that stack. I think we need to explore that and figure it out. But I think there's many pieces that could be a lot faster moving and less rigid.
And maybe this also connects to one of the questions that I had noted down, right? And something discussing these days also with other people, there's a lot of technical debt maybe in these projects that are coming forward, right? Related to interfaces, related to even like organization of the software. Where do you see the project that you represent going in terms of reorganization or like making it more agile to accept this kind of contribution and work well with these AI development tools?
Very good question. I don't have a good a good answer to that one. Maybe
I don't think any of us have a good answer to that one. But one thing, one of the interesting things I was just reading was Microsoft pitting AIs against each other to fact check themselves and things like that in this development realm, and that might be one of those things that comes out of this, where that ends up being one of the processes to enable some of this.
Howard, can you go to a microphone maybe? Oh, okay. And then, so maybe Vijay first, and then Howard.
Yeah. So I have a couple of open-ended questions. Actually, I want you to think a little bit and share your insights on this. So, what role do you see Open RAN playing in the area of AI RAN? Right. I was talking to Kuntal the other day, and he was like, "I don't care about Open RAN. All I care about is sell GPUs to telco people." Right. I'm just making it up.
Saying no.
So I really want to understand, right? Are we seeing Open RAN and AI RAN converging, as Open AI RAN, the term we have been using at least in some places? Or do we see that we are actually diverging in two different ways, like Windows and Linux did, or Mac and Linux did at some point? So that's my first question. The second question is, what is open source AI RAN? What is it? Because except GPUs, I don't really see anything that AI RAN brings, which we don't already have, in terms of Okudu or in terms of Open RAN.
So maybe one thought on this second part, right? AI RAN goes beyond AI for RAN, which is improving the radio access network using AI. That's a topic that somehow has been around for a while, and now is part of this AI for RAN development, and where the scope is really moving forward to showing that it's possible, showing that it works in practice on real stacks. And that's, I think, the connection to open source. But beyond the i4RAN, there's infrastructure consideration, there's use cases consideration, which are things that I think needs to be taken into account when thinking about AI RAN and open source.
And there's no such thing as a software community in the AI RAN Alliance. So in Open RAN, you have this Open RAN software community. But in the AI RAN Alliance, they don't have this. So they're quite agnostic to the actual software.
So the panel name, software for AI RAN, what is that software?
Any software that you can use to build the stack that you want to use.
So isn't
Exactly.
that cellular network or Open RAN?
Well, and that's the thing, right? It's an alliance to bring everyone together into a single spot. Now, one of the biggest things that we've fought for decades, right, as we go into these open source communities, is you have multiple communities doing the same thing here, there, and everywhere, right? So this is the effort to bring everyone into one group around the same topic and do the experimentation, do the thought, leadership, do the development, the co-development on blueprints and things like that to bring to market, right? So it's really that collaborative point that is trying to be built within that community. So it's blueprints and POCs and whatever you want to bring to it to cover the different AI or on use cases with.
Yeah, and I don't think AI RAN diverges from Open RAN, right? Like AI RAN is largely here today because Open RAN paved the way for it, and there's a million interfaces with the front haul and the E2 and XApps and RApps and all these tools that AI RAN can now make use of and move very quickly because of. So again, I think AI RAN is like a layer on top of Open RAN now that's exploring what else we can do more quickly, and maybe not through as rigid a decision-making progress.
Yeah, and if you look at ORAN as the rules and the accepted, the agreed upon requirements, right? That just feeds into the AI building your systems as well. So that's the connection there.
Yeah, and I think I go back to Lurson's discussion earlier that in a lot of ways this is not AI for the sake of AI. We've got use cases that we're trying to solve. We're trying to very carefully pick the areas where AI is going to help us improve a KPI, and we're going to deploy it in a way. It's not free, right? You might have to run on a different processor. You might have a power impact. You might have access or not access to data that's going to impact your ability to actually deploy that thing. And so I think that this idea that the whole RAN is going to be completely rewritten as an AI thing, we forget the fact that signal processing works really well, and we're not always trying to replace really well-working signal processing, and other parts of the RAN are just almost purely state machine. And those might have supervision, but it doesn't necessarily make sense to completely replace those either. So I think we have to be really intentional about what are the use cases, what are the KPIs we're trying to improve, and then focus on those things. And just like when you run, to your point on Linux earlier, you're trying to run on an ARM processor or an Intel processor, at that processor layer, those interfaces are very well defined through some reason. And this layer of abstraction that is the operating system runs great on these multiple processors. In the same way, these different AI algorithms and things will likely run on the RAN as its operating system, and then just be augmented to utilize whatever the KPI needs are.
Howard?
Yeah, I guess from a little way back on the discussion then, when you were talking about context windows and you were talking about loosening interfaces, that seems to be suggesting that maybe you're potentially refactoring parts of the standard to make things more AI efficient or AI whatever. And then I guess you've also now said, start from where you are as well and leave some of that interface defined between separations. But it kind of intrigued me, that suggestion that your AI could then dig in and say, well, there's correlations between these bits. We can change the scope of that, or maybe the interface definition changes or something.
Maybe the state machines that are defined today evolve independently of the standard, or like evolve at least on both sides in UE and run in a certain way.
It's more a comment. It's more a comment than a question. I mean, do you see the AI refactoring the standard at some point?
I like to think of it more of as a pre-standards activity, right? Because I want to go try a new use case. Like, I'm going to build up my own E2SM or my own E3SM and put it in a bunch of systems and go try it out and vet it. And I'm not going to worry about the standards body. But then that means when I come and want to standardize it, I have that much more data and KPI and data coming in to standardize things. So, I mean, I think right now it's pre-standards, but it's ultimately up to vendors to decide, like, what are they comfortable integrating and supporting, how much of it has to be a formal standard and how much doesn't.
Okay.
And I think if the end goal is $1 billion $1 chips like we have deployed in the world today that are the UE, some type of defined interface is going to have to be defined. And if you use AI behind that in the base station, you have a lot less penalty for making changes or optimizing or changing up the hardware. But that being super efficient in an IoT device or a mobile device really requires a very strict and tightly defined set of requirements.
Thank you. So,
yeah, I mean, sorry,
okay, we have time for one last question from Tracy.
So when we talk about Open RAN, that means a lot of different things, right? This has been a problem forever. So, if Open RAN refers to the ORAN Alliance, people start to say, oh, that's an open source community. Obviously, it's not. It's an industry alliance. And then people say, oh, well, ORAN works hand in glove with 3GPP, so they're both, standards bodies. No, the ORAN Alliance is an industry alliance, and they already have, and I'm not going to say they're specified, I think they're under-specified, but they already have use case specifications. And quite a few of these use cases scream for the software that you're alluding to in a roundabout way that kind of makes sense and will make more sense as we go along. So what would you think if the ORAN Alliance came to you and said, oh, how about you support MNO, Mobile Network Operator Prioritized Use Case X, and sprinkle the AI native, fairy dust, because, there's a learning curve for industry, right? And Eric, you and I talked about this when we encountered each other at one of those events in Washington, D.C. Would you support that? And if you would, and this is the royal you, if there is such a thing, how would you go about it? Like if we came to you and said, oh, the next ORAN Alliance face-to-face meeting, Seattle, Washington, early June, go look at the use case task group, use cases. They're underspecified. Which one could you demonstrate? How would you go about it? And are you game for it?
Yeah, and this actually connects to the question that I wanted to ask to close the panel. So like maybe a quick 30-second from any of you mentioning which use case you would like to see developed, either within the ORAN community or outside the ORAN community, in the space of AI and RAN in the next 6 to 12 months.
And beyond.
Let's start from something short term.
So for us in my group and what we've been looking at, one of the things that we would love to see and love to engage more with and push is dynamic resource allocation, right? Orchestration stuff. That's our bread and butter, right? So that's what we'd like to see, and we can start with one thing to orchestrate, one thing to manage. But that's really that transition point, right? From going where we are today to actually starting to use AI to manage these systems.
Tim?
Yeah, I think from my perspective, I'm most excited about the things we can do in the physical layer that we couldn't touch before. So I think initially that's transparent things, whether we can drive spectral efficiency to be state-of-the-art for the entire industry using neural receivers, neural beamformers, neural schedulers, all of those things we can build out very quickly, and it's very transparent to any of the external interfaces, really. But then also prototyping like 6G. So what can an AI native air interface that's a two-sided model really look like? I think those are some of the most interesting aspects. But there's many.
Eric?
Yeah, I think the thing I'm most excited about is Isaac. I think it's super cool. I didn't mean to steal it. But in the short time frame that you just mentioned, I think the thing that would be most helpful is to define some of these data and data collection interfaces that can then be used to train the AI models. I don't think we do a very good job of even collecting and anonymizing data right now to create what's been called the data lake.
So you don't think we can do Isaac in 6 months?
I think we're already doing Isaac in some ways.
But we've got agents.
We don't want to do in 6 months a one-off. We want a use case that will, as other speakers have said, move the needle, that evolves, 6 month across 6 month chunks.
So yeah, thanks Eric for bringing up Isaac. I was hoping I would say it first. But yes, I think that's a use case, and that's a use case that I've been working on in my research as well. And indeed, we need data. We need data sets first of all, I think AI can do a lot of good things in the field of Isaac. Detection of intruders in airspace or in a room, counting people in a room, based on channel measurements, based on SRS channel measurements. So that's something we're working on at Eurocom, for example. So that's a good use case, but we need data sets for that, and yeah, I think software, because this is a software for AI run panel. I think the software that we have today is great for that already. We just need people to go out there and collect these measurements and make them available.
What great connection for the next panel. So the next panel is going to be on data and data sets, and how open source relates to that.
I didn't do this intentionally.
If I could plug on that, I mean, that's one of the things on this Okudu effort that DeepSig is very involved in now, is trying to build out these reference designs for key use cases like ISAC, which definitely involves enabling the data collection so that people can easily gather SRS reference data, easily gather channel impulse responses to try to be able to quickly get these data sets for their environment and test things out. I think we need tools to make it much easier to do that in these stacks so people can move faster.
So let's see what the people that have thought about the data panel will come up in the next panel. Everybody, let's thank our panelists. Thank you so much for participating. So the next panel will be moderated by Pedram Johari, and I'll let him introduce people on stage. I see some notebook alarm slides.
Thanks, Michele. I hope that everybody has been enjoying the fantastic plan and program and the workshop that Michele and the team has been putting together. So this next panel for about 45 minutes is going to be about data, data, data. That's probably the first time that I have been participating in a workshop that data comes in the name of the panel 3 times. I couldn't resist, but opening my notebook LM just 30 minutes ago, I'm putting together some slides for this panel. I promise it's going to take only 5 minutes, and then I will invite my panelists. So this was the first one that it generated. I literally just used the program agenda that's online and a paragraph on data and Open RAN. Fueling the system with data and getting better data as you do it. This in general was really fantastic and interesting. It even has the Alex's building of AI RAN. I don't know if it was listening with my microphone open on my laptop or not, but ended up saying that you need lots and lots of data, as we all know, for AI. And then you have to refine it and getting it to some meaningful data that can be actually used and being useful to generate meaningful tools for us. This was in particular is one of my favorite ones, capture and creation. So you have your testbeds or actual deployed networks that's essentially generating those data in real world and synthesizing them using AI, combining them in a factory, and then fueling again your AI agents. This other one is fantastic. I love this one a lot. Again, it's starting from extracting the data, putting it to a refinery, cleaning it out, and then you have your benchmarking system. That's essentially your digital twin and standardizing. And then that's a cloning machine, if you wonder what that is, that last one. So you have some reproducible results. And it even put together a list of the panelists that we have here. Again, it got it from that website. But then I figured this is a little bit boring, so I asked it, can you do a little bit of cartoon and make it a little bit more exciting? And these are the new results. Again, Notebook LM, that agent which is unhappy with uncurated and not healthy data. And then that refinery slide that I like the other version better, but it ended up being some random rocks and then something that looks like eggs or refined rocks. And then chocolate, I couldn't really connect these to each other, but anyway, that last one is essentially that cloning machine that's creating reproducible results. Connection of industry, academia, and government, that's what we have in the panel, some prompts. You guys sitting here, and me, the moderator, that's me, and our panelists. So I'm going to invite Ting-Jun Chen from Duke University. Please come up on the stage. Then Vijay Shah from North Carolina State University. I hope that you like your, graphical versions. Richard Rill from NIST. Come on up. And Howard Thomas from Viavi. Thank you. So getting to some serious pictures now. Thank you so much for accepting our invitation for this panel. Maybe we can start with 2 to 3 minutes introducing yourselves, and as you do so, probably trying to guide us through what do you think is the most critical challenge in data collection, curation, and use in AI RAN and in general. We can start from Ting-Jun from here, and we can move forward. I can show you a slides if that's going to be
can help up the slide.
Go.
Good. Hopefully people can hear me. So my name is Ting-Jun Chen. I'm assistant professor at Duke. I've been at Duke for about 5 years. And then on this slide, I show a set of, I would say, open source tools and frameworks that we've been building over the past 5 years that aims at basically frameworks that people can very quickly use to generate, for example, high-fidelity 3D scenes, which can be then imported into Sionna and AODT to run ray tracing simulations on the left. Basically, these crowdsources geospatial data, building maps, ladder point cloud, which can then be transformed into, let's say, Sionna and AODT-compatible scenes. And we've been taking measurements primarily in the CBRS band. We've been open sourcing some of these measurement data, which can then be used to validate, let's say, large machine learning models, which are trained using synthetic data collected by our tools. And then we've been actually working on a lot of benchmarking suite to actually benchmark the power efficiency and latency trade-offs when you actually run different signal processing workloads on commercial grade server CPUs, GPUs, and also ASICs. We're actually releasing tools that can actually benchmark, for example, different layer 1 processing units on Intel FlexRAM's platform, on NVIDIA's Aerial, this is the full L1 pipeline, as well as, for example, ASIC from Intel, which runs the LDPC decoding workload. On top right, you can actually see we're actually also building RF-SOC-based programmable radios with a whole HDL coder-based pipeline, so people can very quickly build up these multi-channel, high bandwidth per channel type of programmable radios, which can then be used to collect wideband spectrum data, as well as establishing communication links with different front ends. We have FR1, FR2, as well as above 100 gigahertz. And then we have been also working on adding new features into today's base station, mostly evaluated using SRS-RAN, as well as open air interface software. For example, in this particular case, if you were to detect, let's say, CBRS radar, which are hidden underneath user traffic, you can actually treat uplink user traffic as interference to the CBRS radar, and then make the base stations to be able to cancel the uplink transmission and then reveal the underlying radar signals for spectrum sensing and coexistence type of applications. And then on the bottom right, you can actually see a list of open source projects which we developed, including the tool that builds the digital twin frameworks, the large set of data set we collected and generated for spectrum sensing, for radio coverage map estimation problems, as well as a set of benchmarking tools which people can run to actually evaluate, let's say, energy efficiency, latency trade-offs when you are developing a next generation software-defined radio platforms. And then one last item here, actually, there's going to be a paper coming out tomorrow. We actually implemented for the first time a real-time OTFS receiver, and then we showed that you actually need GPU for real-time processing on these OTFS platforms, which we believe was actually the first one that actually shows a very unique use case compared to OFDM, that GPU actually shows benefits when processing a new advanced waveform for 6G and beyond. And then if you want to get more details, feel free to scan that QR code and actually see all the open source tools, frameworks, data sets, benchmarks that we've been building and sharing with the community for the past 5 years. I think I'll stop here.
Wonderful. Thanks a lot, Ting-Jun. This is fantastic, and I really have a couple of questions and details that we'll get into that when we start the conversation. Vijay, if you want to go next with a brief introduction and some of the capabilities that you guys have.
Yeah. Well, hello, everyone. That was a great overview. So here I'll very briefly cover a few things that we are doing in our group. As you can see, we are building multiple tools that addresses the fragmented data problem and building AI models. So the first one on the bottom left, that's Neuralsmith. So what it does, it basically automates building production-ready AI models from your raw RF KPI data to inference model. It's free. If you want to download and try it out with your data set, it's right there. On the top right, you see there we have built this ORAN site, which is a domain-specific ORAN LLM. Now we have actually extended with 3GPP, so it supports 3GPP semantics, it supports ORAN semantics, and it also supports SRS-RAN codebase or Okudu codebase now. And the bottom left, that's what Jinsung actually covered. So it's AI 5G test, and actually the student who built this is here in this room, Abhyudan. So he actually built this nice tool, and that's a little demo there, which automates the whole testing process from getting a test case all the way to validating and debugging if something goes wrong, to generating the call flows and whatnot. And he recently actually extended that work with RANGuard, who actually goes and look at the 3GPP specs, ORAN specs, and finds out whether there are enough test cases today that covers all the specs within 3GPP. If not, he generates new test cases automatically. So I'll stop there, and I'll take additional questions later. Thank you.
Thank you very much, Vijay. With that, maybe next, Richard, if you want to walk us through what you guys have been working at NIST, including the Open RAN testbed solutions that you have.
That's right. Yes, so Richard Will, I'm currently leading the Wireless Networks division at NIST. NIST is a sister agency to NTIA. We're also under the
Department of Commerce, and our mission is to advance, new technologies by improving standards, and we are developing proof of concepts to promote innovation, especially for U.S. industry. So we do research in a lot of areas. We are active in various standards, including 3GPP and the Iran Alliance. On the slide here, I just highlighted a couple of projects that we're working on. So on the top one is the what we call our Open6G testbed, Oran testbed. Basically started, like a lot of us here, we wanted to look at, we've been using open source, and we started putting some of those platforms together, and then it was sometimes harder than we expected. And then we figured, we would contribute back to the community. So this tool, this automation tool, is basically a bunch of scripts that helped, we're hoping, new people, new researchers to accelerate the deployment of those open source. I actually started at 2 different projects. Part of our division, we were interested more on the RAN access of things, but then another division at NIST was more interested on the core research, and then they had studied different cores and figured out how to deploy multiple cores. We had done the same for RAN, and eventually we just put those together, so you could actually run the script, select which platform that you want to pick, and it will build that in various ways, whether it's a fully virtual or actually on hardware. And we're using that to do some experiments, collect the data, and then study proof of concept of new features. The bottom one is the something we've been leading for several years, the Next-G Channel Model Alliance. Very relevant to data, because that's basically a repository of data. And I think that's to the first question about where are the gaps maybe for this adoption of AI, is the lack of curated data that has ground truth information, right? So I think that's something that is missing. In some domain, it's easier to be able to check the ground truth, like visions and stuff. A human could look at it and say, yeah, that's right, not right. RF measurements, it's a little bit trickier, right? If you to see that whatever channel measurements that you have is actually accurate is very challenging. So getting ground truth information, collect that information so you can actually relate is, I think, something that's missing. And we're working on that by we've been developing and using a channel sounder that actually combines both cameras and LiDAR along with the RF to help get that ground truth and actually automate the labeling of the data to get that information. Because we used to, many years ago, you had to have the expert to say, oh yeah, I think this cluster is right because of the geometry of the room and whatnot. And now by using this additional data and using Fusion, creating digital twins, we're able to automate that, recreate the environment, and really associate and automate the labeling of that data. So I think that's
wonderful. Yes, this last point on digital twins to recreating the environment, I think, is becoming more and more relevant and important with the notions of the government focusing on ISAC, for example, sensing and communication. I mean, back in the decades ago, we were more interested on learning the channel, but now we are getting into a stage that we are not only learning the channel, but also learning the changes in that environment and the channel through the data that we are collecting. I've been following the Next-G Channel Model Alliance. It's turning into a really valuable data set up there that I think could be quite useful for a bunch of researchers. And again, I think the coalition of industry, government, and academia is key and important, making sure that we have a data set that everybody understands and everybody can use it to this best use. With that, we're going to move on to Howard from Viavi, and I think yours is going to be also around the digital twin synthesized data and validation.
Yes, indeed. So, I mean, is that? Yes, it is. Pretty much the same thing, really, trying to get ground truth data so you can actually know how users are moving, know what the radio environment is, know what trajectory is, how people will gather up together. So gathering some of that information, so you've got RAN kind of ground truth and mobility patterns, This is, I guess, putting into the digital twin kind of ecosystem. So you have RAN, you have transport within the system, you have core, and you have applications. So to actually get some of your system data, how well your system is performing, you need all of those elements kind of working together. So to get that from an actual live network is you have all the problems mentioned before of like confidentiality and personal data and things like that. But you can build systems which can model that, can kind of emulate that, and then it's a matter of how you can get data and calibrate those kind of systems. So what we would really like, so internally within Viab, I haven't got all the products on here, didn't really want to make a product proposal, but internally within Viab, we have systems which take the data and basically track trajectories and signal strengths and system behavior, but we can't put that into the system. We can't, that's not shareable. But what I would really like is if that kind of data could be kind of, if you could detect the features from it and say, use AI to sort of make it so you could suppress all the personal information of the data, you can make something which can build on that data, and then you can make a more realistic kind of real live kind of digital twin of that data for generic kind of cities. Yeah. So.
Great. Yeah, wonderful.
Okay.
Thanks, Howard. This is a good overview picture of different components of the network and how the data can be collected, curated, and then used, and then fed back to the network in a sense. With that, maybe we can move to Tingjun and your expertise on. And I can bring back your slide if that's helpful, but I would rather, have an interactive conversation at this point of time. So, you have expertise on working on the Cosmos platform and also some of the new platforms that you're generating, including your Geo2 map system, I think, simulator. That's pretty recent, and I think you have released it again as an open source that people can use. What are the key points and practices that you are taking into consideration to make sure that the data that you are generating is first of all accessible? That's going to be the open source component of it. Valuable and at the same time will be something that can be used back to the networks, back to the point that Howard was making.
Right. Yeah, if you can maybe go to the next slide, so I can point to that chart. Right. So actually, my student Yiming there, he's actually the one who develops everything. On the left, right? So basically, we're looking for a pure open source solution for crowdsourcing geospatial information available from the public internet. So we use, building footprints from OpenStreetMap. We use a LiDAR point cloud provided by several USGS projects, which basically they fly aircraft and then scan different parts of the US to make sure that 95% of US land is actually covered by this USGS LiDAR point cloud. And then also, we look at frameworks that can actually turn these geospatial data into a scene, which can then be consumed by, let's say, Siona or AODT for generating all these propagation models, right? For example, if you were to go with all these Blender-based solution, then there's another layer of overhead between the raw geospatial data and the scene that can be used by these downstream frameworks. That's why we had a pure Python-based version, completely open source. People can directly take the data, go through a fully Python-based pipeline, and then turn those geospatial data into meaningful scene models. And then the other feature we introduced here is basically you can already tune the fidelity level of the scene that you generated. For example, you can choose to represent the terrain using spatial resolutions of 1 meter versus 5 meter versus 10 meter. You can choose to calibrate the building height from OpenStreetMap using the LiDAR point cloud as the ground truth data. So we already provide several tuning knobs in this tool in a way that people can generate scenes with different spatial resolution and with different spatial fidelity. And then when you turn these scenes into, let's say, Siona to run all these radio propagation modeling, they'll get to see the difference between the level of scene fidelity and then the downstream ray tracing and EM computational tasks. And then the question that we're looking at, for example, now is how accurate of a 3D word model representation is actually needed for you to get meaningful and higher accuracy results for your downstream tasks, including signal propagation modeling, right? So if you were to represent the scene in a very high resolution manner, let's say, a number of points per pixel per let's say, meter by meter dimension, then you may run into using a lot of compute power to actually even generate the scene, and then the downstream ray tracing task becomes even more computationally expensive. So how do you actually choose the right fidelity and representation and the spatial resolution of the scene? That's one key aspect that we're considering when we build the tool. And then if you actually go to the website, you can actually now do this. We have already trained machine learning models from using, let's say, more than 5,000 areas across the US with different scene fidelity levels in a way that people can understand the relationship between the scene fidelity and the accuracy of your downstream task, whether that's going to be signal coverage prediction versus interference mapping and so on. These are something that we consider when we build these type of tools. And then also we have all these large-scale measurements right from our campus. We work with other people to get a measurement from other areas, including measurements we collected off the Cosmos testbed deployed in New Jersey and in Manhattan. And then all these measurement data can be used to look at ways that machine learning models can help improve your network performance. For example, if you can build a model that is trained on a lot of synthetic data, but then when you actually run or infer the model on a specific site, you may only want to take very few observations. Let's say 100 measurements sparsely sampled from the new site, and you can actually leverage a lot of prior knowledge learned from these larger models in a way that you can even save your site scouting or labeling efforts when you're trying to adapt those models into real-world scenarios.
Wonderful. I think that resonated a lot with Howard's comments, and I think you are.
Yes,
go ahead.
Are you able with your LiDAR also to get some idea of subscriber distribution or potential subscriber distribution? So you could, if you've got some ISAT, JSAT type thing, you could sort of, count people or something like that. Because that would be interesting as well. And certainly what we found when we were doing subscriber-centric optimization, if you ran that, you could get some extra benefit that was not available for pure stochastic planning, because some people were always in certain locations, on average.
Yeah, exactly. I think that's the one reason that we try to build this tool in a scalable way. So you can basically input, let's say, coordinates of the area you select, and then the tool will basically generate the scene and representation for you in basically one line of code. In such a way, you don't have to deal with the site-specific variants when you are using other tools such as Blender to actually incorporate all this geospatial information. So we've been looking at the forward problem a lot, which is going from the scene knowledge to the downstream tasks of, let's say, estimating coverage. But then I think the reverse problem, which is how do you actually get, let's say, understandings of the scene itself, the scene geometry, the moving dynamics, the objects, from the underlying measurement that you can actually observe from the real world. I think the reverse problem, the inverse problem there is also very interesting, which cannot be dealt with unless you have access to a tool that gives you, let's say, 100,000 areas in the US with different levels of representations and fidelities of the physical world.
Okay. Wonderful. Maybe moving on to again, or back to the open source concept of it, right? Because let's try to also get to the higher level and see. Maybe Vijay, you can walk us through some of the systems that you have, including the Orange site or the Neural Smith and the data that you are generating. What are the most valuable and most urgent data that you think is needed for the AI run today? And how does the open source community can help generating more of those, or sharing them, or using some of those open source data sets and contributing back to your platforms?
Yeah, I think that's a very important question. I'll probably answer that through some real examples. So we have been working with this operator. I cannot take the name because of NDAs and whatnot. So they gave us this data for 3 months for 200 cells in Dallas, Texas. And they said, we have 200 cells, we have 18 KPIs, and if I try to build a model for each and every KPI for forecasting purposes and whatnot, that's not scalable, right? That's 18 into 200, that's more than 3,000 models. And by the way, our world is very dynamic. So you have to keep training, keep retraining the concept drift, the data drift, and those things happen, right? So like, can you fix this problem? I'm like, yeah, in today's age of AI, if ChatGPT can learn the whole world, the whole internet, why can we not learn 18 KPIs for 200 cells, right? So we did some work, and actually we were a little upset that a single simple foundational model worked across all the KPIs, across all the cells, right? And we were like, oh no, we cannot submit to Infocom this, you know? So we submitted to Globecom. So we call it telco agent, right? It just works. And the reason it works is because the data that we were working with, it comes from one vendor, one operator, very structured, the same metadata, the same, the schema they have, and it just works, right? But at the same time, I gave this problem to my group here. A couple of students are still here. We're like, so we actually went to SRS RAN workshop a couple of years ago, and we wanted to demonstrate this interference classification XAP demo, real time, over there. And we had like 99% accuracy, best paper award at Milcom, best demo paper award at Milcom. And we went there, it did not work. I'm like, what? Just one UE, one basis test, and it doesn't work? What happened? It seemed like we had to retrain it for the new scenario just because we moved our test bed from my lab to this Virginia Tech Center in Arlington at the time. It's still there. I'm like, this is not good, right? If we cannot make a model with a binary classification work with a single basis station, how can we ever adopt such model in real world, right? So I challenged my group that can you make one ICXF work across 100 of open data set that's out there? And it seems like we cannot. And the reason, again, is all those data sets have very different metadata, very different schema. And for example, let's say look at a single SINR value, let's say 98 dB or whatever, right? That might mean a very different scenario in New York downtown versus Raleigh, right? How do you know that? So we have to somehow come up with a 3GPP specification for data. That's, I think, is the biggest problem. And I think Okudu and open source could help us do that. So we need amnesty of wireless. Thank you.
So do you think the problem was that just the metadata was deficient? You needed to have more environmental structural data associated with it, so that delay spreads or the clustering of rays or?
So I think it's two. So one is the metadata, right? We need to know enough about the data, right? What environment it was operating on, what was the hardware configuration, what was the different layer data point, right? We need that. I mean, I think if we know that, I still believe, again, going back to ChatGPT, if ChatGPT can give reasonable answer, it still hallucinate, but gives reasonable answer to everything and anything in the internet, whether you ask a medical query, whether you ask to build a slide like this, like Notebook LM and whatnot, why can we not have one model that can work for any wireless scenario? And wireless scenario can be very easily characterized by a handful of things, right? If you think about our model-based solution in wireless world, they work, right? Most of the time they work. It's not optimal, but it works. And the reason is because we model those parameters very properly, right? So all we need to do that is capture that, right? Whether it's multipath, whether it's number of building in the area, whether it's the transmit antenna. In a way, we need the configuration file of our simulators or digital twins.
I guess it's a good experiment, isn't it? You showed that you needed something extra for that. And I guess you didn't quite know what. Mm-hmm. So it's finding that. So I guess within the AI RAN, we have an ambition to make some of these open data sets, and maybe to come with the same thing is like, here's an open data set, and what are the problems with it? What's it lacking? What can't it do? So you can build that understanding.
Yeah.
And I think Howard and I both are interested to hear about the name of that operator, maybe after this panel. And in exchange, Vijay and I were in a different panel last week, and he was complaining that we have a lot of GPUs here.
Oh, yes. Tommaso,
so in
please host Oran site. Please host an Oran site at your GPU. We are really poor. We don't have GPUs, unless Kuntal, if you can loan some to us.
They're looking for GPU.
So,
Kuntal said there were many types. It must be just for you.
Yes.
Kuntal said there were many, many types of GPUs. There must be one just for you.
Yeah?
Thank you in advance.
And again, in exchange, you should release the information of that operator.
No, I'll go to jail. I have signed an NDA with them.
Wonderful. Thanks, Vijay. Moving to the government side, Richard, you guys have been contributing with Open RAN testbeds and also data collection and publicizing them so that the community can use. What do you think is the role of the government in establishing a standard way of collecting data, methodologies, and standardizing the way that that's stored and that's used and that's contributed back to the community? What are your thoughts on that?
I mean, that's kind of what the key role of NIST, right, is defining those standards for collecting measurements, right? It's all about measuring. How do we measure things? There's definitely a lot of activities around AI at NIST. We actually had an AI day just last month, and there were over 100 posters. Everybody's all over AI. And a lot of it's like, how do you measure AI? How do you trust AI? How do you, all those things. So for us, providing these data sets, these golden data sets, could be something of interest. Vijay kind of stole my punchline for the MNIST, which is kind of like a standard reference for digital for handwriting recognition, character recognition for handwriting. There's another one that is for the facial recognition, that basically all technologies who are doing facial recognition could use to benchmark their solution, right? Because one of the keys, like everybody's going to come up with their solutions for AI and show, yeah, we get X improvement in energy efficiency or spectral efficiency and stuff, but based on what? Whatever data they collected and then they show. There is no benchmarking data set that people could use. You want to show me your result? Okay, go look. Use this data set. And so I think that's a place that at least NIST we could try to target. And I echo with what Vijay was saying about standards, metadata. Make sure there is a common language to document those data sets, right? So you need to. I thought there was some work on IEEE that there was some initiative at some point to also to kind of standardize data sets. I can't remember which one it was, but so I think that is needed. The government could work on that. The government could also help in establishing. Sometimes we are asked to do to be an evaluator for some other projects. So there's for example, there's some DARPA project, and then they have performers, and then they ask NIST, okay, you're neutral, do an evaluation of those performers. So that's something that government could do, or that NIST could do. And I think NTIA with all their testing and the OTICs and all stuff, that's how they kind of also promote it, right? Trying to get that ecosystem to improve testing.
Of course, yeah, and that's definitely needed, and I think valuable for the entire community. Now, moving on to the industry side, and Howard. So, we talked a lot about the data that people will get access through operators, and they don't tell us who they are, which is quite valuable. And you also have your digital twins, which can synthesize the data. And then there are going to be the users in the ORAN space. Let's call it again back to the vendors and operators who are going to use that data. What's your vision and what are your thoughts in terms of making that, validating that in a meaningful way, and making sure that we are producing high fidelity, good quality data sets, and then something that can be used by the community?
So I guess where we are at the moment with we have AI RSG as a tool which you generate thousands of base sites, tens of thousands of users moving around. You have a topology for that of base station pointing angles and antenna powers and various other sort of handover parameters and stuff like that. So you're getting some of the complexity. You have a mobility model, how mobiles move, how they're dropped. Whether that has the requisite complexity to really represent or sufficiently well represent reality, it's what we have, what can be used, what can be shared. So that's been used to drive a number of hackathons and things like that. And one of the main things we're seeing now is a lot of engagement from that for building telco models, training telco models, and investigating that side of things. So yeah, I mean, that's where we see that going. So you have, I guess you can structure the problem slightly as well. So when you're doing that network scale, system level scale things, you're having to make some assumptions, you're having to do link to system modeling and represent the maybe you get down to antenna pointing directions, but you're not doing the exact structure of the channel impulse response from a ray tracing thing, probably because you don't have the cycles to do it. And so then we have other tools which would work where you're emulating tens of thousands of mobiles and pushing that into smaller number of cells. And then that's, historically that's been used for validating base station software and doing overload testing and finding things where those radios break. That's then repurposed for training AI. And some of the interesting I saw there was through the AI Round Alliance and some of the discussions we're having there with some of the research that Nokia was doing on training radio receivers, where looking at the 3GPP models and the assumptions made there made the arrival of rays and delays and angles was too simple. So it didn't generalize. So then there's work there. Now you're asking a different question of that data, and it's to some extent it's research then to find out how robust those models are going to be.
Yeah. I see a similar theme between all of you guys talking about synthesized data and measured data. Ting-Jun was giving us a few examples of iterating and calibrating what they are generating with the true data. Similarly, Vijay, with the experience that they had with different operators, seeing different behaviors, because that's a key and important factor. Richard, again, was walking us through, again, that the importance of having accurate CIR models and channel sounders that actually represents the data, all the way to being as accurate to even trying to understand the environment, not only the channel. And Howard, you're also emphasizing on the fact that the AI is as good as the data that you're feeding it with, yes. Pretty much. So we have a few minutes left. I'm going to open this up to questions from the audience if there is any. Please raise your hands. We can run the microphones to you if there are any questions. Okay. Please, go ahead.
I got one for you. So on data, we know that the hardest part is getting the data. But once you have the data, what's the next hardest thing to overcome with the data sets that you get?
So to me, I don't think we need more data. I think what we need is useful data, right? So I think whatever we have, we need a way to make it useful by structuring it around metadata, around schema, around, Richard brought up a really good point about benchmarking, right? No, sorry, you did, right? I think that's really, really important, right? The reason, the other community, the vision community, for example, the MNIST or IRIS, I believe, right? Those are the data set everybody tries out, right? Irrespective of what models they build, right? Similarly, in the LLM world, right? The ChatGPTs and others, they keep superimposing each other or saying we have the best model because they saw it for the math or MMLU, the massive multitask, or the human eval data, right? And that's what we're trying to do with GSMA, right? They recently released this Open Telco AI initiative or LLM initiative where they have the 7 benchmark data set, right? We actually contributed 2 of them. And we are going to contribute a few more, like tele-embed bench and the Okudu bench, or the software engineering bench, very soon. So I think we need those community-adopted data set or benchmark, and it should be usable. There should be APIs so that it's not really a file that you download and try out. Rather, it's an API access that you basically access and try out. And there must be some kind of versioning so that if something changes, people know that something similar to what happens with a code. Right? You keep maintaining that code base, or 3GPP spec. We keep maintaining the release numbers, right? So that at least we know that it works here for this version, right? So I think that's what we need. We don't really need more data. Yeah.
So yeah, I guess I agree. We need more good data. And the other thing, I suppose, that comes with a digital twin or something like that is where you have the data, you run your algorithm, whatever process it's going to be, and then you find out what the delta is, and you find out what that performance improvement, so you can kind of benchmark your algorithmic approach. And it's knowing what that data is, finding the features in that data.
Right. Yeah, I think for me, assume that we have enough good data. The thing that I actually care the most about is how much energy do you need to use in order to either generate good synthetic data or to actually consume and understand what good data actually includes, right? For example, if you were to generate digital twins, you can do this in many different ways, which would consume, 5% of your GPU utilization all the way up to 100%, right? So there's a limit on to which that you can actually give yourself an energy budget and then look for the best digital twin or the most useful feature you can extract from the data by either running a machine learning model inference on these data sets or try to actually use the data to infer something else in the system. So I feel like a lot of people have been working on getting more data, but once you have the data, the next big thing all these AI companies are caring about is actually how much energy do you need to budget when you're actually continuously generating more new data or continuously consume the data and then extract meaningful information. That's actually one place where GPU comes into place. A lot of people are saying that GPU is not good in terms of their energy efficiency. That's because the way we're not using GPU to their maximum capability, right? So actually, we've been studying many cases here where we show GPU actually has the right energy efficiency gain if you know what models to be deployed, how to deploy them, and also how to use GPUs for the right purposes, right? If you can actually understand the energy efficiency with respect to different workload, the workload here could be layer 1 processing, it could be scheduling, it could be machine learning model inference. If you can actually profile the energy latency trade-off when running different workload on different systems, then you will have the capability to decide on which workload to run on which platform at the right time. Right? So that's why we're actually working on building a lot of these energy efficiency profiling tools to understand if you were to run DSP, machine learning, let's say digital twin generation on CPU versus GPU versus FPGA, how to actually understand what is the best platform, the right implementation of that algorithm on this platform, and then the right algorithm that you want to use to solve the problem. So for me, it's actually more about an energy efficiency problem after all, if you have enough good data. Yeah.
Thanks. Please go ahead.
Yeah, maybe along those lines about the good data is also data that's representative, that includes the corner cases, right? Because you're going to build a model, and if you have you create a model that covers 95% of your situation, but then the 5% corner cases, we discussed this morning about reliability, right? Your network needs to be operational. What happens if you hit those the rare cases? You want your network to stay, on. So I think figuring out how do you capture those corner cases is tricky to get that data.
Wonderful. I feel like that was a really good question, and that helped us also wrap this session. Howard, if you have any final thoughts on data?
I guess just one thing is I think you need a kind of hybrid approach. You need to go out, you need to actually measure the ground truth data, what's the actual radio channel doing. That's really expensive. You need to know how the users are moving, where they're moving, and that's kind of a bit private, confidential. So that's a kind of challenge. And then you need to be able to synthesize that data in a way that's efficient and useful and timely. And then you need to have people trust it. so the operator is going to buy it, or you need to re-engineer the operator, some greenfield operator who can trust this, or it's so making in product with it is then another challenge.
That's right. That's right. Thank you so much again for joining me and joining us for this panel. I think, as Vijay and others mentioned, we have enough data, but we never have enough time to talk about how we can make this data more useful and better and curated so that it can be used in a meaningful way. Thank you so much for sharing your thoughts. Please join me in thanking one more time our brilliant panelists here.
I'm not that cute.
Can we get a copy of this?
Of course.
Thank you.
Yep.
I forgot my ruler because NIST has the official 1 meter ruler. So.
And Harvard has one of those, maybe 1-800 ONE.
Yeah, it looks like that.
Yeah.
All right.
Thank you so much.
Thanks, everyone. We're going to have a 15 minutes break until 3:30, and we're going to present the results of the output of the hackathon at 3:30. I'll fix it. All right. Hey everyone. We're gonna restart just in a minute, and I think with a session that is very interesting because we're gonna have the participants of the hackathon explaining what they did during this week. All right. If the 6 speakers for the 6 teams can come here on the side and just line up in order of group. So in this next session, I'll introduce the hackathon experience and kind of give an overview of what has been done, and then we're going to get to the last 2 panels for the day. So this is, I think, if you guys can come back to the front and the seats, I think it gives good justice to what has been done by the students over the week. But basically, we had 37 participants from 37 different universities and R&D centers, most of them based in the US, thanks to support from NSF, and the others from Europe and South America. We also had 10 tutors and 6 instructors from Northeastern and Open Air Interface. And in the mornings, we did some training, and in the afternoon, the students could run the hackathon. And I'll describe a little bit what was the infrastructure that we used to support the students and the hackathon. But overall, we basically leveraged the private 5G test-based and infrastructure that is available here at Northeastern. It spans different campuses, our Boston and Burlington campus, both connected through a VPN, comes with a set of basically a networking infrastructure to support fronthaul, backhaul components of the network, timing to support the fronthaul and the PTP synchronization. We have a decent set of servers, some of them with GPUs, some not, and that we use to deploy open source, run, core, and so on. We have radio units or on commercial radio units besides USRPs. For this exercise, we work with Foxconn radio units so that each of the 6 teams had the same radio unit, but we've been working with a variety of partners to kind of test and bring radio units up to fruition, UEs, and then we have some testing tools, right? So we use this infrastructure as sort of the whiteboard, but on top of this, we leveraged a framework called Autorun that we developed as part of our one of our NTIA Innovation Fund Awards that allowed us to support the hackathon by supporting a multi-tenancy. We had like 6 different groups operating and using the radio access network infrastructure at the same time. So we deployed 6 CUNDUs based on open air interface with 6 Open6G core networks in parallel on this infrastructure, as well with some automation for the UEs. So Autorun basically allows us to do this with a very high level of automation by describing the infrastructure through a stateful approach. So automation that as a declarative approach and takes configuration files into compute to configure the compute and the rest of the system. A programmable network connects this to a set of radios that I was showing earlier. And on top of this, again, we use pipelines and automation to manage the different tenants and to deploy multiple CUDUs, multiple core network rigs, and so on at the same time. So this is kind of the framework and the setup that has been used for the hackathon, where the CUNDU was based on open air interface. So this was deployed on the 6th floor of the XP building that you can see from the windows over there. We had the 6 RUs and 12 UEs, so 2 UEs for each group. The UEs were implemented using the Sierra wireless UEs. This is the radios and then some of the compute. And in terms of software, as I was mentioning, we used open air interface for the run stack, modified with an extension of the scheduler that we have developed as part of this All-Star framework. So All-Star in general is a framework where we can use LLMs to generate scheduling, actual functional scheduling code for the run. In this case, and then to deploy it as an extension of open air interface. In this case, we focus primarily on using this extension. So basically, rather than having a monolithic scheduler, the scheduler is kind of disaggregated into different pieces, up to the point where we have a component that calls a Lua part of the software, a Lua-based DApp, and the routine that implements the scheduler is implemented in this component. So basically, this is for the hackathon, we asked the participants to develop some code that resides within this Lua component. So as I was mentioning, we leveraged a lot the automation and infrastructure that was available in the lab. But still, we had 36 people working on this, and so this required a lot of effort and participation from the tutors and training team. So a huge thanks to all the folks who helped out to bring up the infrastructure and to, in the first place, design Autorun All-Star, but during this week really to support the exercises as early as 6 a.m. in the morning or late at 10 p.m. at night. So huge round of applause. And basically the challenge for the hackathon was to design a scheduler for the 2 UEs. So not too many UEs to pick from, but one was URLC, the other MBB. For URLC, we asked to support latency below. So URLC in quotes, because the latency that we asked to support is below 50 milliseconds end-to-end round trip time. And EMBB, we asked to support the target data rate of 80 Mbps. And then basically the criteria that we're going to use to decide are performance, do they meet the SLAs, the approach, as well as the quality of the presentation. So we had, as I was mentioning, 6 teams. This is the complete list of the participants for today. And now we're going to go 3 minutes. Each team will have a chance to present what they did and the results that they got during this week. We're going to start with Team 1.
Cool. I guess I'm going to start. Hi, everyone. I'm Jen from Team 1. So very glad to be here to introduce our design of the deadline-aware PF scheduler for 5D ORAN. The core idea of our approach is to design a 3-term weighted PF score. So the score consists of 3 different components. The first component is priority weight, and the second component is the urgency weight, and we also consider the proportional fairness. And the score will be the product of all these 3 different components. So for the QoS priority, we mainly focus on do a lot of experiments and pick the empirical value. And since there are only 2 UEs, this method turned out to be very great, or like great enough. But it's not. We are not sure whether it will be scalable or not. For the deadline urgency, we defined it as PDB divided by PDV minus HL delay. So this term will grow as packet approaches its deadline. And for the third term, proportional fair, we defined it as CQI plus 1 divided by the path throughput. So that the system will favor good channel condition and starving UEs. So the right-hand side CDF plot and the bar plot shows our result. And you can see that the latency result of our CDF plot or our system is much better than the latency of the baseline. And we achieve approximately half of the RTT value of the compared to the baseline. And in terms of the throughputs, the EMBB throughput is ensured, and we realize the original objective. We also realized the result of 100% packets received under the 50 milliseconds. So we also noticed a lot of bugs and problems when we actually implement the system. So one of the problems is the GNOB crashed from time to time. Yeah, sure. Part of the reason is that the actual UE is deployed along the whole floor, and there may be a lot of external signals that will interfere with the signal. So that we spend a lot of time to do the debugging, and it turns out that a lot of the results that we get are actually not useful. Sometimes we may experience a lot of the 0 values and strange outliers. So in the end, we try to run our scheduler based on a lot of different designs, but we may not be able to complete all the experiments. Yeah, and we also experienced bugs related to the minimum MCS settings, and we noticed that these parameters are hard to tune, and sometimes there may also be a lot of outliers. So huge shout out to the tutors for helping us throughout the process. Yeah, I think that's all of my presentation. Thanks.
Hello, everyone. My name is Harris Ransom. I'm a first-year PhD student at Columbia, and I'll be presenting for Group 2. So, as mentioned previously, we were challenged to design a scheduler that could reach the minimum latency requirements while sustaining acceptable throughput. In our design, what we did was we prioritized HARCs, so the hybrid automatic requests, in order to ensure that the packets were received correctly, and then we designed our scheduler influenced by the paper listed below to balance the buffer length, which we use to estimate the latency, while we're allocating leftover resource blocks to the throughput traffic. In our scheduler example, you can see in the equation, we use the estimated buffer lengths from the downlink metrics in order to essentially estimate the delay for the we use the buffer lengths to estimate the delay for the resources that we need to allocate for the URLC client. We also include an exponential penalty factor. The penalty factor is used to essentially prioritize the URLC for the the exponential penalty factor is used to the penalty factor is used to prioritize the URLC over the EMBB. For our experimental results, you can see that compared to the baseline, compared to the baseline in blue, we minimize the overall latency violations, reducing the P99 percentile. We did have some latency violations, but ultimately we reduced the overall latency while maintaining comparable throughput. As you can see in the graph on the right, we had comparable throughput to the baseline. We didn't end up reaching the 80 megabits per second, but we maintained comparable throughput given the variations in the channel. But we still maintained acceptable latency, having minimal violations over the 50 millisecond threshold. We also experimented with some other techniques using a dynamic multi-objective scheduler, which used a combination of the buffer estimation and the priority fair scheduling. And ultimately, we learned a lot from the hackathon and the infrastructure, and we learned a lot, and we're excited to continue using these concepts in our research and our experiments. Thank you.
Hey everybody, I'm Dominic. I'm from UCLA, and I'm presenting on behalf of Group 3. So for our approach, we wanted to look at the baseline proportional fair scheduler and then kind of modify it in two ways to prioritize low latency for the URLC UE and high throughput for the EMBB. And so the way we did that was first by just weighting the two users differently. So just kind of multiplying our coefficient by 100 for the EMBB compared to only multiplying by 1 for the URLC. And so this is kind of based on the intuition that most of the time the EMBB traffic should be prioritized to maintain a high data rate. But then kind of in addition, we wanted to optimize based on for the latency for the URLC user, and the metric that we looked at for that was the head of line delay, which is the age of the oldest data. And so we then applied like an additional weight based on that, which scales exponentially with that head of line delay. And the intuition being that, when things are kind of expiring, they really need to be sent to meet these latency requirements. That should have like exponentially higher priority. So that was kind of our approach. And so then we went and did some experiments to try to look at it. And we did see kind of small but reasonable improvement compared to the baseline in terms of the latency, and then very comparable throughput for the EMBB user. And so I guess we would have liked to do more, but we definitely had some interesting technical difficulties with this where we weren't able to, the channels were not quite as good as we expected, so we only had like 5 megabits per second, or I guess 10 megabits per second total across the two users. But it was still like a pretty kind of valuable process to get experience with the real hardware. And we also then did think a little bit more about what we want to do. A few things would be to optimize for actually we just kind of chose these weights kind of experimentally, but to actually do a more rigorous parameter sweep across a certain type of traffic, or to perhaps make a system that would adapt to different traffic conditions and kind of changing these various weights and thresholds based on that. Thank you.
Hey, hello. So this is Yiming from Duke University. I'm here to represent our teams, Team 4. So, so the title will be DAPS. So basically, we're trying to define a delayed aware priority scheduler. So by doing that, we first monitor the baseline that provided by this test bed. So basically, the baseline we noticed there is some issues that they basically didn't considering the height of line delayed, and also the so basically each slot is assigned to a single UEs, and also there's a kind of gradient allocations. So here is our solutions, right? So basically what we are trying to do is that we just design the algorithm by trying to first prioritize the URLC's UEs requirement, but we also keep, let's say, a 25% the minimum of the resource block to the EMMBs to make sure the EMMBs still get the throughput, right? So we also define this something we call this URLC deadline awareness boost, right? So basically we define how many, we're trying to see how many byte or how many data are left to send out for the URLC. So we define this weight trying to prioritize if that's a critical, let's say we define the critical threshold to be 35 milliseconds. So if there's exceed this threshold, we're trying to more aggressively to prioritize the URLC's packet. And after all this, and here we show this figure is the baseline, the measurement we sought. So each column should be a slot we're trying to scheduling, right? So the blue color will be the UE for the EMMB purpose, and the orange color will be the UE for the URLC. So basically, after we modified, we're basically trying to assign the resource block, both for the two UEs. And also, here's our result. These two plots are our result, and the red line is actually the deadlines, right? So basically, we're trying to make sure the throughput to be over the 80 megabits and megabits, sorry, and the latency is below the 50 milliseconds, and that basically is everything what we had here. And I want to especially thanks to my teammate, especially the Ambiendo and also how there are actually people working super late last night trying to put out the latest resort to put everything here. And again, also we're trying to thank you to organize this amazing hackathons, and that basically is all for Team 4. Thanks.
Hello, everyone. Let me start with briefly taking you through our decision process and how it got evolved throughout the experiments. We typically started with explicitly mentioning references about the 5 QI definitions, assignments for each of the UEs. And then we, after doing several experiments and making observations, we evolved towards an implicit prioritization where we wanted not to have hard-coded if-else logics in our scheduling algorithm. We also wanted to keep things simple and democratize and delegate the task between all of our members, given the valuable opportunity for everyone to experiment each of their algorithms and what they wanted to try out. So one of the stability fix that we introduced is to introduce a cap for the latency. And we believe it gave a clean interpretation for us to understand what impact it had in order to produce the weights that the scheduler did. And then we also made modifications to the default UE controllers just to let the UEs keep the PDU sessions active for a prolonged period of time, because it was also important for us to make the measurements under a realistic condition where both of the UEs are dragging data simultaneously. So while that was going on, we believed taking the measurement at the UE would be the most closest and the accurate way of representation of the UE's experience, and we kept the throughput information that we had available at the scheduler just to make scheduling decisions and rather not take it as a performance metric. And based on the observations, we introduced 2 fallback options. One is to find or tune this default MCS that was defined, and we found 9 worked best for us. And then when high blur happened, we introduced a manual, we reduced the MCS by 2 steps manually. And in addition, we also explored individually, everyone wanted to try out different aspects of the scheduling rather than everyone focusing on the performance, the coefficient of the schedulers. But beyond what we could fully validate, we also looked at PRB allocations to avoid this sawtooth behavior that you see in our results, to make things smoother. And also we were experimenting on adaptive mechanisms to switch between the tables, MCS tables, and come up with a way it's adaptive when the layers changed. So we believe they could have produced more interesting results if we had more time to run these tests fully. Thank you.
Hello everyone. This is George Yavas from University of Patras, Greece, and I present in part of Team 6. So as you already know, our goal was to create a scheduler better than the default given scheduler that would reach the KPIs of latency at URLC of 50 milliseconds and an SLA target of throughput for EMBB of 80 megabits per second. For that reason, we created a 3-step scheduler. The first step was the HARC retransmission. The first step was the HARC retransmissions, which remain unchanged from the default given scheduler. And then we moved on to the URLC scheduler. So we put a strict priority to the URLC frequencies. I'm sorry. We put a strict priority to the URLC packets. We did that because they need to go first and they have strict latency delays. And in order to achieve that, to achieve better throughputs and better reliability, we chose to follow a frequency selective best channel fit instead of just the smaller first available resource block. But this would starve the EMBB, and for that reason, we allowed for the URLC to take only 15% of the whole resource block on each round. However, if the head-of-line delay was too much and it went out of the target KPI, the URLC would puncture the time slot of the EMBB and take its place in order to keep our KPIs reachable. Moving on, the EMBB new data would be transmitted normally, and in a proportional fail algorithm using a largest block allocation. To keep the proportional fail algorithm, we created the coefficient of the current throughput over the historical throughput and times the slots that were punctured. And this led to oscillations in our throughput, so we followed an outer loop link adaptation technique, which led to more oscillations to our throughput. That's why we took some safeguards. As you can see in our results, our URLC latency, it's much better than the 50 millisecond. It's 100% achieved. while the SLA target for the EMBBs is almost reached, over 90%, and on the same time, the latency of the EMBB is better than the baseline latency. Our best results can be seen on the table on down right. Our average throughput for EMBB was 103 Mbps, much larger than the 80 megabytes per second, and our loss was around 2%. To achieve all this, we created the custom script in order to have realistic conditions and simultaneous throughputs. So when the PDU session of 1 UE was achieved, it would wait for the second PDU session to start so that we have simultaneous testing. I think that's all. Thank you very much.
Thank you all. And just to reiterate, right, this is something that they worked on for 3 afternoons during the week on a setup and using software that some of them had never seen before. So I think, and using real devices on a real system. So I think that with all the imperfection and difficulties, I think it's remarkable that we actually got to this point where each group had like results, something to present, an approach that is like reasonable or at least reasoned upon. So really a hand of applause to all the hackathon participants. And so we're going to know the winner at 5:30. Okay. Again, thanks everyone. With this, we're going to go to our third panel, which is on the on a topic that many of us care about, which is about we develop the software, we have the data, how do we test it, how do we know it works, and how do we basically profile it and evaluate. I can put the slide up, or if you want to bring it up, the slide for panel 3. But let me welcome our panelists. We think we're missing a chair, actually. So this is going to be a crowded panel. We're going to have Lincoln Lavoie from UNH-IOL. We're going to have Robert Schmidt from the Open Air Interface Alliance, Kirk Webb from Powder University of Utah, Peter Pacheco from MITRE, and Damien Sauce from INRIA and Slices. Please. All right. So maybe as we did for the other panel, if you can like quickly introduce yourself and your role and how does your role relate to does it work and testing and development for open source and run?
Sure. So thank you. My name is Lincoln Lavoie. I am one of the leaders of the interoperability lab at the University of New Hampshire. So testing's pretty ingrained into our blood for the last 38 years or so, working with the networking and telecommunications industry. With respect to the ORAN Alliance and ORAN and 5G, we are an OTIC, much like Northeastern here. We work directly with a number of the vendor communities as well as hosting the PlugFest type events for that. And then near and dear to my heart, we've been working with the industry to develop the ORAN reference testbed architecture, which is a set of Ansible playbooks that really gets used to stand up and push out deployments and scenarios across many of the different open source projects that are out there, because we really are looking at how we do the integration testing across these projects as the critical point of influence in the lab. So that's where we're really looking at it.
Thank you. Robert?
Yes, so hello, my name is Robert Schmidt. I work for the Open Interface Software Alliance, where my role is RAN team lead and also CI RAN testing lead in a sense. But maybe from a more open source perspective, you could see me as the maintainer of the Open Interface 5G repository. So basically the repository that has RAN and UE code together, also both 4G and 5G. So maybe with respect to what I'm doing. So I'm reviewing obviously a lot of code. I'm also contributing myself and fixing bugs, overviewing that things go as smooth as possible, that open interface keeps working for people as well as possible, and making it better, of course. And that's it.
Kirk?
We appreciate that.
Great. I'm Kirk Webb with the University of Utah and the Powder platform. For Powder, I'm the associate director, so and also the lead for logistics and deployment, which is very far from what we're talking about today. But with the one of the hats I play there is also as leading our OTIC effort. So we've worked with a bunch of different vendors and PlugFest, often with Lincoln, leading the charge for our group of North American labs. And for our part at Powder, we have recipes for automating the setup of end-to-end 5G systems with SRS and with open air interface, using both COTS RUs and software-defined radios. So profiles to snap your finger and have something up and running that you can then modify is the idea. And as part of our OTIC testing, we have a system called TODA, Test Automation, Test Orchestration, Test Automation. And that is a suite of test tools that we've developed to run over various end-to-end scenarios where we've worked with the SRS folks on testing things like handover. So.
Hi, I'm Peter Pacheco from MITRE Corporation. I'm part of a team that operates a test lab at MITRE. That lab's been in existence for several years. We started with using a lot of what folks call carrier-grade Tier 1 equipment. Once we realized that wasn't sustainable over a long period of time due to cost, we've moved over towards using open source as a way of doing testing, but also as a way of doing experimentation as well.
Damien?
Yeah, so as you know, we have built testbed for the last 25 years as well. And to say, let's stop about doing testbeds, what's the best is to make a new testbed, right? So in Europe, about 5 years ago, a bit more, but let's say like this, they said, okay, they provided funding to create a new large research infrastructure. The idea is to say, instead of making testbeds which are really specialized, the idea is to say it's instruments really targeting the researchers. And it's not only for 5G, but whatever, but it was for, in general, computer science and the digital science. And among others, in this, we had targeting the community for 5G and 6G. So my job here is to try to make something that is useful. And for the community, we decided it's not only for people that are like most of people here in the room, really specialized, but also for people that just want to use 5G. So we have to be able to reach people that just want to deploy, for example, a drone over 5G. So they don't care about 5G, they just care about drones, for example. Or people that would like to deploy XApps. So if you look many papers, what they do is actually, they don't really make real XApps. What they do is just simulate something with their own idea of what could be an XApp and a system that supports an XApp. So you see things that are completely unrealistic. But also we want to be able to target people doing like changing the scheduler like we have seen from the hackathon. And to do that, we say, okay, how we can do that? So that's the experience I have, trying to make things work for everyone, and it's not that easy. All the time, of course, it has to be reproducible. So every time you come, it works.
Yeah, so talking about like not that easy, right? So we just discussed in the previous panel that the AI run and the software for the run touches everything that goes from the physical layer, DSP, to machine states at the higher layers, to orchestration, accelerator, virtualization, and so on. And then we want to add AI on top of it. So how do you actually design CI/CDs or tests that are effective for profiling the overall system complexity? how do you tame this complexity in tests that are meaningful?
So I think the first step, and you kind of started with it, or you saw some of your teams from the hackathon even starting with it, you have to understand what you're trying to tune, right? Like, so you've got to take a holistic approach of, all right, I understand a baseline, and I understand what my KPIs are, and then I'm going to look at a measurement against that. And like, I think you're going to have to see that approach replicate no matter what you're tuning, right? And we see that same approach even in a commodity type project like DPDK, where you see every patch being tested for regression against performance and stuff like that in their CI scope. So you're going to have to apply that same methodology, to what your AI is trying to produce in the RAN.
So you're saying basically being comprehensive and target all the use cases that AI could cover.
No, you can't boil the ocean at the same time. You're going to need to know what your use case is and what the KPIs are associated with that, but you're going to need to be able to compare it against something, right? So like, what was my base state, and then what was my new state, and then what was the new state after that, and trend that.
Gotcha. Kirk.
I'll just say that, particularly working with stacks from vendors, these things are very, very bolted to specific versions of even firmware in like a transceiver. And so, changing something like that can cause a failure. And so, how to start then working through this matrix of tests, is on top of that. It's like, okay, well, first you have to establish this baseline with the setup itself, and then fold that into the test. I mean, nothing can just kind of get dropped in and just run and work. Without some tuning, without some modifications.
Yeah, I just kind of take a little bit of a different approach. Your question implies that, when you're doing AI, it's like basically accessing the whole RAN from, where you connect to the core all the way out to the radio. I haven't really seen that yet in our lab. It's a little bit more focused. So the view that we take is, AI really comes down to, the data that particular algorithm needs. And we just first test to make sure that the data is available for the algorithm. And then it just becomes a matter of, let's evaluate the algorithm and its performance. And we've checked the box everywhere else, so just because we added AI, that shouldn't break anything else.
Did you actually get to test like real-world equipment that has some AI?
I'm sorry.
Did you actually get to test like real-world equipment that has some AI in the loop?
Yeah. Again, we made sure that that whatever the AI algorithm was that was running, that the data was available to it. And then, and sometimes we recorded data, right? Because the person who was developing kind of needed to do it in their own place. But once that happened, they came in, and it all just came down to making sure that they had access to the right data.
Yeah, gotcha. And maybe another aspect of the question, right, beyond like testing the AI is like testing the orchestration, the virtualization, or testing the DSP at the physical layer. These are two very different things, right? Do you take care of both in the same environment? Do you have dedicated tests and environments for the different parts? How do you approach this in general? Robert?
Maybe. Yeah, I mean, maybe what was kind of said by the others, but what I was thinking is that, of course, in the end, just layering AI on top should not make the system more complex, because if you make it more complex, especially for developers, it gets more difficult to understand what is actually happening. So, I mean, what was already mentioned, there should be a useful baseline to which you compare, but probably more than that, not only when it comes for like what you mentioned, like DSP or maybe higher layers. You don't want to have only this one baseline, but you still need to have like specific tests that tests only the aspects and so on. And of course, once you have established that, then you can apply AI on various fronts to improve the system, and then build on top of that and improve the system.
Yeah, measure the improvement.
Yeah. You need to know the baseline, basically.
Yeah.
Kirk.
I'll just say that it's quite a lot of work to develop tests. I'm sure that, the vendors here that develop this stuff know this well, and they have big teams. And it'd be interesting to compare notes with, their development cycles. But the tooling that we're developing with Toda, it takes a long time for us to, and that tooling touches everything from the orchestration down to the actual, nuts and bolts of the protocol. And we move very slowly with adding tests as a result. So this is probably an area where AI could help us out, right? Let's pull in more, some kind of duplicate some of the tests we have and modify them, and to add some of the tests that we are lacking in there. So, a thought there. But I mean, I'm a little bit of an AI Luddite, but don't throw any tomatoes. I know, maybe in the wrong building for that. But I came here to, to get my heart softened a bit, to embrace this a bit more. And I see the value, and like Raymond said earlier, you can't not use this stuff at this point.
So your heart is getting softened. Yeah. We've been doing like some experiments on like generating unit tests based on ORAN specs and frontal code, and it takes some time to build the correct pipeline, but when you get some interesting results. And writing unit tests is something that I don't think anybody likes to do.
If you know how to make your dev team do it, let me know.
By the way, like as before, we have some microphones scattered around the audience. So if you have any question, just feel free to jump on the microphone. But I wanted to touch on something that Damien and both Kirk mentioned in different ways, which is some of you are operating testbeds. I guess actually all of you are operating testbeds with different level of like openness to the public or different level of like capabilities. So this generally means that you need to balance different kind of demands, because you may want to have like some developers that want very granular access and change many things. You want researchers that just want a packaged component, right? So how do you, and then you have maybe people that come in with commercial equipment that just need some tests. So how do you balance all of these kind of needs, and how do you do this with like open source in mind? So at the end, trying to help open source communities develop their software.
Yeah, I can try to start, because it was really interesting when we started to implement the tools for the people to be used. So it's a completely open infrastructure, anybody can connect to it. We thought that everybody was really happy with reproducibility. Oh, that's great. So we developed everything so that it's reproducible, meaning that you have to start from zero every time, like we do in CI/CDs, right? We try it and you try to make sure everything. But it happens that researchers are not really about reproducibility. So initially we thought, yeah, that's pretty weird, because those people, they should be reproducible, but they were already complaining that no, the system is not flexible enough. I want to have my system always running so that I can do things in it. And what happened is that actually, to be able to deploy a full environment where you have the radio, where you have all the servers that run correctly, the core and the RAN, very few people can really do that. Except here in the room, we are biased. We think it's easy because you have made that for the last few years. But in practice, it's not that way.
We could ask the participant to the hackathon how easy it was to deal with all the system, right? And
yeah, and so what happens is also they don't have the infrastructure at home, so they don't have the radios or these kind of things. So they need to learn, to practice, and to do that, they need the infrastructure. And the problem, if you say every time you have to be script correctly and put your Ansible and so on and so forth, then they don't do anything. So what they want is to be able, I have my machine, and then it comes back, it's there, and I can do stuff in it. I forgot what I did, but eventually it works. So that was really a surprise to have this, but at the end it's normal. And so the priority is difficult. So the pragmatic one was we have people that really do things on the infrastructure, so we try to follow them because you have a lot of, when it's an open platform, you have a lot of people coming and willing, you know, they have their wish list. So that's the way that we prioritized. And a second thing that we did is to figure out that actually maybe we should make some kind of meta model or representation of the model because you know, if you have OAI or if you have SRS RAN or these kind of things, the configuration are pretty different. So what we did is to simplify this instead of having, you know, like making really complex stuff. We say let's abstract the configuration files and use compilers to go from one to another. And that's how we kind of prioritized because then people, they can reduce a little bit the learning curve. And instead, because they know, they're supposed to know 5G, so they know the parameters they want. But usually they don't really know. And we observe that a lot of bugs that we have from people is just they misconfigure things. So this is how we made the priority.
I just want, oh, sorry. Go ahead. I wanted to follow up on this to say that and this comes to your question, you know, of people coming in with different interests to your test bed, like a researcher who wants to study end-to-end behavior. They don't care about the nuts and bolts of 5G and how it gets set up. They just want to run their application. And so, you know, you've got, and they often don't know the ins and outs of 5G. Like, that we found that we can't make that assumption with a lot of the folks that come in and want to do stuff. So for them, we need a stable setup that they can just pop up and it works. And we, you know, there's got to be some way to help them plug in what they're doing. And often that requires some hand-holding from us, some of that expert domain knowledge to show them what to do. I don't know where, you know, is there a way AI can help steer them to the right place, you know, in the code, you know, to plug in? I don't, you know, maybe, right? But.
I mean, to me, I think it's the critical thing that's being discussed here is kind of it's the environment orchestration and the test orchestration piece. The way we've taken the view of doing it is we have the flavors and the Ansible playbooks that put stuff in place that the community can use, but we've turned that directly back to the community, right? And so instead of burying it inside a tool or burying it inside of how is this thing working, you can actually dig under the hood and you can see, okay, here's the recipe that can put, you know, the Akudo deployment onto the infrastructure, or here's the recipe that can put the Duranta deployment onto the infrastructure and do the configuration. And by the way, here's how the infrastructure was tuned. Here's how the real-time kernels were set up. Here's how the time synchronization in the S-plane was established. And you make that available so that the community can actually kind of self-support themselves and learn.
Yeah, kudos to you for mentioning that. I want to just throw out this example. This really happened. We were testing in RU in our lab. We're using the test specifications from the ORAN Alliance, and we interpreted those test specifications a certain way. So we went and conducted the test. We got a different result than what the vendor had done when they conducted the test. So we said, all right, let's use test equipment that says they have the test tools, test options that are in compliance with the ORAN Alliance. So we ran those, and they got a different set of results. So we weren't sure, like, and it came down to how we ended up configuring the test in order to execute it. So I think that is key, and it maybe has a little bit to do with reproducibility, and I think this is going to become more evident as people start to try and test AI, is it's not just the source code or the AI algorithm. There's so many other things you got to provide now with it, right? That to help people be able to do that consistent testing, no matter where they are and what platform they're doing it or who is doing the test.
Maybe only the one thing that I wanted to say, because there was already this question about usability and so on. So, I mean, for open interface and as a maintainer, I'm aware that open interface as a tool is not always very easy to use. It already starts with the fact that in the configuration file it exposes 3 GBP structures. So we make effort of reducing the complexity, but of course that has limits because we cannot just redo the entire configuration file because then everything else would break for everybody. So that's not that good. apart from that, I mean, giving more writing documentation. I mean, we have like these Docker Compose files and Helm charts that we provide to the community so that they can use this and then see what we run and how they can more easily redeploy things. So, yeah, if there's more feedback in that regard of what could be done, I would be happy to hear that.
So, invite for everybody to provide feedback to Robert. Damien, and then we have a question.
But then the question first, so.
I don't know if I'm, yeah, here I am. So far, what I hear, you're treating AI as a single instance in the network. When I hear about your testing, you say, okay, then I add AI, then I test again. But the reality is there are multiple instances running in the network all the time, or they will be in the future, whether, you know, whether they're different agents or whatever. So my question to you is, how are you going to test it, especially when we're not sure if the two different or multiple different instances have conflict in the process, that one wants something changed and another one wants the same thing changed but in a different way. So how do you see approaching that sort of testing?
I think you're referring that to me. Yeah. So we haven't encountered that yet. So let me just say, if I were to face that today, how would we go about it? And it plays towards the CI/CD approach, which you break it down. We ensure that, you know, whatever the two AI instances, let's keep it simple, two, right? Whatever they need for data, we make sure that that's available. Test each one independently, right? Check those boxes, and then go ahead and then do tests where you've got the two of them running, where you're looking to see, you know, identify any of those conflicts or any of those issues due to the fact that the two are running. It can't be, you know, just throw it all in there and let's do testing. You got to start small, right, and sort of build your way up to, you know, eventually, which is, you know, 1, 2, or several instances running, and then you're testing those, you know, those scenarios.
Well, then as you add more, you get to the power of whatever you add is the number of tests you've got to run, right?
Yeah, but at that point, the GPUs break down. They won't be able to handle it.
Them's fighting words, but to me, the critical piece there becomes what's your test stimulus and your coverage on that, right? And so as soon as you know, it's one thing I'm looking at like the AI outcome and I'm measuring my KPIs across the test and there. As soon as you start saying, okay, now I'm looking to look for conflict resolution, well, I need to make sure that my test stimulus potentially is going to push the system to a point where it might have a conflict resolution. And so, like, depending on what your AI is doing, whether it's optimizing, you know, as we saw, latency and bandwidth at the same time, or two different, you know, sets of latency for two different applications, you've got to make sure you're trying to drive the system into that in your test coverage. So I guess the end result just becomes the answer of very carefully for determining those.
So I would say, you know, this sounds like a recipe for disaster, honestly, with these AI agents, you know, being able to touch any piece of this and be able to collide. So if more than one AI agent is able to influence a part of the system at the same time, you know, where is the predictability in the system? Yeah. And so it's like now you need some kind of guardrails, you need some kind of definition of how these things interoperate, or else it will be chaos and you won't get testable reproducibility in your testing.
I think it's also a matter of where do you need reproducibility or predictability versus where do you need resiliency. They're not always the same thing. Sometimes as long as the system works with a certain set of KPIs, which may be the guardrails you have in mind, you may not necessarily be interested in predictability. In other use cases, you may want to have a very predictable behavior, right? So maybe this can be something new to explore in terms of testing in this domain.
Yeah, I mean, to me, I think you got to look at CI/CD as like a very layered approach, right? Like if I'm working with Akudo, that comes with some levels of CI/CD itself. Same with Duranto and OAI, right? And that runs in its lab. The next level up to that, though, is you have to do it across the deployment. And it was like, as we've seen, you know, you've got the core, you've got the RAN, you've got a RIC, you've got maybe some SMO, you might have an infra cloud underneath it. Now you've got a really big piece of CI, right? Because any of those pieces tune and change, you need to have a reevaluation of the entire system. And then we're talking about layering the AI changes on top of that even to where maybe it's doing a tuning or something like that. And so you're not gonna be able to do this in a single go. And you're not gonna be able to do this without like a comprehensive plan and like a text orchestration piece. And then the last piece I would bring it back around to, just because we're here talking about open source today, this is something the community has to do, guys. Like, we have to get engaged across project and cross-project integration for these pieces and actually provide that feedback. We will not have a hope and a prayer of like keeping the entire end-to-end RAN stack, end-to-end network stack alive and well integrated unless we are all collaborating cross projects. Full stop.
Totally agree. Howard?
Yeah, I was just wondering, in this kind of hand-holding and making a runnable setup, have you investigated using kind of AI, LLM type things so a non-expert can set up the system just by kind of asking?
So I can try to answer that. So we started to look at this for an experimental point of view. Okay, so just people that want to deploy the environment. So initially, we tried to go really into the details, and then the LLM was not really learning easily, let's say it like this, because if you have a little mistake, then it's not working at all. So given that, as I said before, we have abstracted the configuration and the system with some kind of a meta model. Meta model is just a cool name to say a pydantic model, right? It's just to look cool. And so when we provided this meta model, so it's well defined, so you just basically provide all the pydantic stuff that you have, then the system was able to run pretty well what was possible to do from this point of view. So it's limited, it's very specific to a particular case, but then from the chatbot, people are able to say, I would like to configure this, and this, and then it provides the information. So when we just took, let's say, we took the code of OAI and all of this, we tried to make something, we did not manage to do something, but we abstracted, we say, okay, people, we are only targeting a small subset of what is doable, so deploying a 5G environment, that's it. Then with this, it was able to learn. But it also means that you have to write a very weird documentation, because the way we normally write documentation is not good enough for the LLM to learn. So we really have to consider that is the most dummy person that will read it, such that the LLM can learn it correctly.
I agreed. I mean, documentation is a big part of what we, and education is a big part of what the platform we feel like we have to provide for people. How does an LLM help with that? I mean, it's something we've thought about, but that's all at this point, right? Is how would we fold an LLM into, or an AI agent into using our platform? What would that look like, exactly, and how would it drive things? Beyond just kind of musing about it, it's not, nobody in our group has pursued that, to my knowledge at least. But it could be fertile ground.
Yeah, I think in general, also connecting to the keynote from Alex this morning, right? There's this harness that maybe needs to go beyond the testing, the interface-based testing that we do today that checks certain compliance to an interface, because you have maybe non-determinism, you have some autonomy, and so maybe test needs to evolve together with the rest of the system. Any other question from the audience? Just keeping it open. I have one other question that I want to ask, which is going back to the open source side. At some point, someone mentioned I'm using this open source software to then test the review unit. So the general question is, how do the open source software projects that we discussed today that are part of this end-to-end 5G ecosystem help you with testing other components, either commercial or also open source? Kirk.
Well, I mean, we wouldn't be able to do a lot of the testing that we do without them, frankly. So, kudos to these guys for producing these great stacks for us to lean on, to build on. These are the giants that we stand on with our testing, and provide all of the mechanisms just about for us to expand that and do other types of research.
Yeah, I mean, exactly the same. Like the open source stacks kind of form the foundation of a lot of the infrastructure, right? And then they provide kind of all the individual Lego blocks that you can then start mixing a commercial implementation into it, whether it's a commercial DU or a commercial RU on that, and then mirroring that up with the open source components that you need to kind of fill in the rest of the gaps and the pieces. And so where I think it gets really interesting from the open source community piece is when you start then mixing and matching those blocks back. And then what we need to do as kind of the next step is then how do we feed that back to the developer community directly in the open source? I'm sure in like open air interface where you guys running the CI/CD testing, that feeds right back into your GitLab and you get to actually see the results and stuff like that for the individual patch that will be coming in. Now when we start talking like cross project or cross area, how do we do that and get two projects looking at a result so that they can see that integration test?
Or even agree on the test to run.
I mean, maybe the one thing that I can say, I mean, in our CI, of course, we interface with some other software, and we are starting to do more. I mean, also Raymond had it in his presentation at the end that we are starting to test, for example, the OAI UE against Okudo and so on. But what we did so far in that sense, it was also limited. I mean, we of course we have the test reports for OAI itself and so on. And if we found a problem in some other software, then we reported that. But typically, I mean, it remained at that because, of course, the main focus of our CI is to test OAI itself. So it wouldn't make too much sense to bring in a lot of other information if somebody works on the scheduler or something like that, and then they want to actually see the results of OAI, and that would maybe be distracting to then see other projects. But yeah, I mean, I understand that it would be useful for you to have maybe see more of information of these systems working together and maybe get a summary of how this actually works.
Yeah, or maybe there needs to be like third parties that run these systems end to end and kind of report back upstream what's wrong. Peter.
Yeah, I'm going to follow you off stage, right, to avoid the tomatoes here. So I've been in telecom for 20-something years, and I've seen how open source has evolved, and it certainly has a lot more feature sets today than what it ever has had in the past. And that says a lot, given that there's been a lot of complexity that's been added to telecom networks. When you think of like 5G compared to 2G. But I still think that there's gaps and there's work that needs to get done. So when you talk about using open source for testing, I guess it's important to understand, like, what is the testing for, right? Because I haven't been to all the operators' test labs, but I've seen some, and I don't see them using the open source tools. And ultimately, anything you develop is, if it's going to go into a production network, it's got to go sit in there and be tested with that. So I think open source gets you to a certain point. I mean, it is the best tool to use when you're experimenting, looking for different ways, different techniques, different algorithms to use to support, functions in the RAN network. Think of like the whole hackathon thing that you did. But I think at some point you move away from that. I mean, I'd love to see the open source, be something that the operators say, yeah, this is really good. I'll take this to evaluate solutions, but it's not quite there. So I would say it depends on what is it you're testing for.
Gotcha. So maybe just one last question to close, and I think then we can continue the upstreaming and the cross project in the next panel, which is actually about community. So it's a very open-ended question, okay? So say you have a magic wand. What is the piece of software or the piece of testing infrastructure that you would like to provide to the community that doesn't exist today?
mean, for open interface, I think if it would just always say what was the exact problem right now, that would already be good. Yes, in general, I mean, I'm also not skeptic, I would say, regarding AI, but I still also have problems seeing how, for example, multiple agents, if they work together in some CI pipeline, how they can really improve something on in a running system. So maybe some more concrete examples of how and what this should entail exactly and how this would be useful, that would be good for me. So.
I would say like the cross-project testing results collection point, and then the community question is then how to get each project that is engaged paying attention to that result, right? And so making sure that they're seeing how things are working, they're thinking about that plan, and they're helping kind of move the goal of like, we want the complete tech stack, the complete RAN stack, the complete core, all working together to actually deliver on the kind of promise of the full implementation end to end.
It's a good starting point for Rani, who's going to moderate the next panel.
Setting it up for you.
Peter?
Forgive me, I may be a little ignorant here in saying this, but if it were me, I'd like to see some open source tools to complement what's already out there that leans towards network management, right? So I can take all the different open source tools that were shown earlier today, and I think the Linux Foundation did that, that kind of ties that together, and then I have insight into what is happening across all those tools. Because
From a deployment operational point of view, or like from
because like I think besides making money, I think operators really care about their network not failing, right? If something goes wrong, they want to know about it. So, and I feel like there are times when I want to know, like, hey, I just made this change. I think this is an improvement. It works really well. And let's say, as an example, I did a new scheduler for the DU, right? I know it works really well. But what happens when something fails? Like, how do I test that my scheduler is providing the right data back to the network management system, saying, hey, users are not getting connections for this reason here. We don't have any of that, and I think that if you did, you'd increase perhaps the likelihood, not increase, but facilitate the likelihood of solutions migrating into an operator's network.
Gotcha.
Yes, for me, I think it would be really nice to have a tool to say if you're right or not in the results that you have, because people try something, but the specifications are so huge and barely readable, let's say, that what we see is people, they try something, they obtain results, the results might be complete, they believe they are good because they improve by 1% compared to the state of the art, but actually they use a scenario that was completely not correct, let's say, just that they don't know. So how to know that when you try to solve a problem, you actually already use the specs correctly? Because sometimes we see results that, yeah, they are good, but you just change this particular stuff. You don't have to change the algorithm, just change this configuration, and it works.
Good. All right. Let's thank the panelists. I think definitely some interesting directions to kind of think through and potentially develop either new system or new tests or new ways to do tests. Thanks again. With this, we're going to move to the last panel before our social component, and I'll hand it over to Rani for introducing the panelists.
Okay, so I'd like to invite the panelists, please. Please sit in the order where your picture is shown. So this will be the last panel for today. Thanks for staying late with us. Hopefully we'll make it a bit entertaining so you won't fall asleep. And we're the last thing separating you from the drinks. We realize that. So So everybody is seated. Okay. You don't recognize yourself in the photo. I dug it from the from the Internet archive.
Okay.
I couldn't find anything more.
I couldn't even recognize my organization.
Oh.
It's supposed to be, all one word.
Sorry.
That's fine.
You live and learn.
You're excused.
Okay, so this panel will be about how to grow the open source community. What are we already doing that's good, and what can we do better? We'll start by, like all the other panels, a brief introduction of the panelists. Please maybe consider the late hour and briefly each introduce yourself so we can get to business.
Hi, I'm Mari Silby, and I really apologize for keeping you from the drinks and the reception. I'm the Chief Program Officer for the National Spectrum Consortium, also the Program Director for the Project Office for the Platforms for Advanced Wireless Research Program, which runs a number of wireless testbeds. Lots to talk about. Have been very involved in several aspects of getting this open source software out into actual fielded prototype type deployments. So looking forward to the discussion.
Hi, good afternoon. Manu Gosain here from Northeastern University. I'll just stay in this swim lane for today. I wear a few different hats that I'm not going to bore you with, but primarily from an open source community perspective, have a vantage point of multiple different consortia and alliances, everybody you've heard from today. So able to bridge some of what's happening in academia with what's happening with industry and government, and I'll bring those perspectives today.
I'm Tracy Van Brockel with WinLab Rutgers University for almost a year now, and previously for, well, several decades with AT&T CTO Labs. I've worked on, lots of open source projects going way back. I'm very happy to be here.
Irfan Gauri from Open Interface, and I also wear the hat of chair, the only surviving chair of the open, how is it called? OSFG, the Open Source Focus Group. Yeah, we have soon another one apparently. So yeah, I wear two hats, so I'll give, a little bit of my experience of how cross-community collaboration has panned out in this area.
Thank you. So it's no secret that many of the successful open source initiatives and ecosystems benefit from large companies who use the software in production and therefore are committed to contributing and growing the technology base. We have not seen that yet happen in open source and RAN. So my question to the panelists is, what would help change the perception of open source from what I think Peter from MITRE just said, that it's almost there but not yet and lacking some things, and what would make it something that operators would consider putting in production? So maybe Tracy, since you have a previous hat of AT&T,
oh yeah,
what's your opinion?
And also I was with AT&T, I was the original operator co-chair of the Open Source Focus Group. And I think a couple of problems here. One is, of course, that there's so much money involved. You've got, 5 vendors who are still dominating, let's call them suppliers, who are dominating the market. We all know who they are. Ericsson, Huawei, Nokia, Samsung, ZTE. They dominate the market because their products are generally quite good, if not excellent. And most of the operators, as we've heard repeatedly, are allergic to an outage. So it's a lot easier, faster, cheaper to go one or maybe 2 vendor in a mobile wireless commercial macro network than open source multi-vendor. There's this concept of one throat to choke. So if you're a single vendor network and something breaks, you've got a throat to choke. I also think that we've made a mistake. And of course, I was with the ORAN Alliance from the get-go, and we needed to be more use case focused and use case driven. If we can demonstrate to mobile network operators that there's a use case, they prioritize. And of course, they have use case specification within the ORAN Alliance. Several of those have now been ported to 6G Alliance and within ADIS. Let's pick one or two and let's implement them soup to nuts with open source, because finally we have a complete stack, thanks to Duranta and Okudu. So let's show them it's doable.
Okay, so demonstrating by example, that's good. Any other ideas from the panelists?
So yeah, maybe I can say something. I was talking to some of the folks at one of the organizations that has recently been set up in France. It's called a 5G Industrial Alliance. And in that space, obviously this is private 5G. It's not really the big operator, tier one type of area. But even there, the big companies like the Electricity Company of France or ArcelorMittal and all these organizations, they would rather go with Ericsson as the vendor. And even though that's probably an area where open source or the companies that are leveraging open source to build solutions are actually probably good enough to produce a network component equipment, but they still don't get chosen there. So I think there is inertia of that kind also, because there is belief that all of this doesn't work well enough right now, I guess. So it probably requires time and proof also that other vendors or open source based solutions can work.
Can I pick up on a couple things there? One, I'm glad you mentioned the sort of more enterprise network opportunity and private network opportunity, because the reality is nobody's going to deploy any of this stuff in a nationwide network at this point. That's not realistic. But you could prove some of this out, and yes, you do need to prove it out in order for the operators to ever care about doing it at a broader scale. But the other thing in terms of proving it out, and I have not heard anybody say this yet today, but I may have missed it because I have been a little bit in and out. But to prove it, you have to be able to show it, and the only people right now who can really show it are incumbent operators, because they're the ones that also own the commercial spectrum that also works with the equipment that has to be used to show the open source software. So I do think we have an opportunity. CBRS has now had a long enough range that there is equipment that is out there that can be used with CBRS. There has been, some integration work, some work done to show how this can be used in a, sort of deployable setting. This is an opportunity. I mean, I feel like there's a window that's potentially closing, but this is an opportunity to take advantage of all the pieces that have now come together, from the spectrum side to the software side to the hardware side, and actually show some proof.
Any other comments? So
one more quick comment, building upon what you're saying, Mary, is let's also not lose sight of all the progress that we've made with Ericsson since we started the ORAN journey. The reality is that Ericsson has been a major contributor within the ORAN Alliance, as well as within the ORAN software community, Linux Foundation, now Linux Foundation Networking. Most recently, another Linux Foundation networking project, Camara. The APIs that were formalized by GSMA are now—
a member of Okudu.
And also, well, we'll see how they behave in Okudu. But, I've worked with Ericsson for a long time. They're good because, they adapt. They're not dinosaurs. That being said, I totally agree with what Mary's saying. Let's look at enterprise. And this goes back to the Cisco effect. Back when Cisco had a stranglehold on the internet revolution, you didn't want to compete against Cisco. If you were Juniper, you wanted to do something off to the side, low risk. And eventually, Juniper became one of the M&O preferred vendors, not just Cisco. So let's be a little humble and do something enterprise, niche. I don't know about CBRS because that's, we'll talk about that later. But not go after, the coast-to-coast, LTE 5G Next G network, macro commercial. That's locked up right now.
When Manu has spoken, can I say something crazy here?
That's what
so,
we're here for.
we were talking about the absence or removal of everything that is regulation, right? We are even talking about killing 3GPP. Well, not in those words, but, so.
Is it recorded?
The fact of the matter is that in certain things, regulation actually makes sense. So we recently learned from somebody that there is a recent law, European law, I suppose, which requires network providers or equipment providers to make sure that they will be able to serve with the same equipment or with evolutions of it over 10 years. And they believe that basing their solutions on open source would be a good idea in that regard, because then they have more control over those 10 years rather than depending upon one vendor or another that may go out of business and all those kinds of things, right? So in that space, regulation probably is a good thing.
Okay, so some good ideas, starting with CBRS and changing regulation, all kinds of approaches. But moving to the next topic, I think when it comes to contributing to open source, we all are familiar with the excuses of why people don't do it. Especially for myself, working for an open source organization, I've heard, I think, every excuse on earth, starting with my legal department does not allow me, I'm not incentivized, I'm too tired, I don't know how to do it, it's too intimidating, whatnot. Just by show of hands, how many people in this room have contributed something to an open source project? That's a good question. Oh, okay. So we're in a friendly crowd. But I think you're not a representation of the average crowd, and I think there's still room for improvement. Even in this room, I think maybe 50% have not contributed yet. So what in your mind would be a way to both incentivize and remove some of the barriers, mostly around intellectual property, that will encourage more contribution and maybe more contribution from academic institutions? I don't know, Manu, since you're wearing a academic hat, you want to go first?
Sure. I mean, that's an easy enough answer, right? Like if you look at what's rewarded in is H indexes, publisher perish, grants. Somewhere in that list of laundry list of, and I'm just talking even from a student, a postdoc, a research faculty, forget about a tenured faculty. There isn't necessarily anything in there that incentivizes that contribution. You basically are on a also very different time cycle. So you're essentially in a manner of putting a demonstration together, getting an exemplar, getting those results, moving on to the next shiny object. So things like, and I think the Oran Alliance was smart enough talking about certification, badging. Those are things that probably have or add some level of signification or signifiers that are actually seen as incentives for academics to essentially participate in, and that's also respected by the peer community. We've also had a challenge. It's moved a little bit. I think a lot of people in this room have contributed to that, is to provide avenues at conferences and workshops to bring that work to bear. When we worked on the Power program, essentially we worked with ACM IEEE to have dedicated workshops where essentially results that were produced on these test platforms were cited, were published, and basically that now has taken a form of its own over the time. But that journey obviously was not easy. So that's the easy answer, right? Like those are the immediate incentives aren't necessarily seen. So how do we sort of move that? But I think the community now sees, given the maturity of the ecosystem that we've seen, 3 afternoons and being able to have such deep level of expertise and results being shown, and hopefully this work continues forward, I think that on-ramp has become much smoother in terms of understanding and learning how these open source ecosystems operate. The timescales are shorter. Now with the advent of AI, I think we'll get into that a little bit, but I think people in this room, from students to junior faculty, et cetera, understand that alignment with open source, and especially in the geopolitical context and the US ecosystem, is actually seen as a positive thing. So there'll be a role of government. We'll get into that part, but that's sort of a long-winded way of what we can do.
Can I add one thing on the...
Speaking about role of government, I'm interested in hearing what Mari has.
Oh, actually, no, I was going to add something on the academic.
And then if you can say something about the role of government, as wearing the hat of someone from a sort of agency. Okay,
anyway, no, that's all right. I'll have to think about that one. But just one quick thing on the academic front that I wanted to add on there. I happened to be in a meeting, an all-day meeting, a couple of weeks ago that was a collection of a number of different universities trying to put together a program where they would collaborate together. They brought in deans from each of the universities to demonstrate the commitment of the administrations at each university to the potential projects that they were talking about. And I will just say that the deans were very, very clear up front that they were willing to change the incentive structure to say, hey, if you are contributing to this multidisciplinary type of activity, which includes things like open source contribution, that will go towards promotion and tenure. Like we are open to starting to change some of this. I'm sure it's not easy. I'm sure it doesn't happen overnight, but that was a promising sign.
And if I may, I love the National Science Foundation. I was part of a project with Convergence Accelerator Track G that had AT&T, Ericsson, Fujitsu, Rutgers WinLab, University of California, Riverside, NYU Wireless, Columbia University, and somehow along the way, we managed to do a couple of and also High Street Technologies. I love working with them. We managed along the way to get High Street Technologies made some significant contributions to ORAN software community, SMO, they call it OAM because SMO has changed its meaning, and simulations. AT&T, myself, got to file 2 patents, otherwise I would have been in trouble. 2 patents that are made more friendly because of the ORAN-FRAN declaration. The universities published several papers, presented at Milcom, and that included both the faculty and the students. So, I think if you bring together a, university, industry, US government group, and have these flexible policies, everybody can meet their bogey, as it were, and keep their job or get tenure.
I actually do have something I can add on the government side, which is that I think it's about 3 years ago now, 2.5, 3 years ago now, I was in a session, we were talking about Open RAN. It was a big, big group of folks, a lot of government folks, a lot of industry and academic folks, all there talking about what Open RAN could do and why the government and the Department of Defense should care about it. And I can tell you, and this was only 2.5 years ago, right? You said the words open source and they looked at you like you had 3 heads. I mean, it was literally not even part of the discussion. They were, Open RAN was one thing, but that was like so far removed from talking about open source. It was still like, that's not relevant here. So that's a long way to come, and I to give credit where credit is due, I'm sure everybody knows about the Future G office out of OUSD R&E and Tom Rondeau and the massive push he has made. And unless you have some of that push and some of that funding and capital up front to give people a reason to start coalescing around some of this stuff, it can't stay there. They want it to ultimately, move into the industry commercial sector, but you need to have that catalyst, and in this case, they've given it at least an initial push.
Yeah, so I want to follow up on your experience from Okudu. I know it's a bit too early, but do you think that model of government funding performers to bring stuff to the open source is something that we'll see more of, or is the jury still out and waiting for the results of Okudu?
Honestly, I think the jury is out, but I think that you have a lot of the right people in the right places, and people are working really, really hard to try to make things integrate. And I don't just mean technologically speaking, I mean culture speaking, I mean organizationally speaking. It's just a lot of things to try to pull together. And I'm encouraged by, how things have moved so far and reasonably how quickly things have moved. And there's a lot more to come over the next few months. So yes, the jury's out, but I see us pushing that Overton window at the very least. Maybe we'll achieve their nirvana, but at the very least, we'll push things in the right direction.
I think, Irfan, you wanted to say something, or not anymore?
Oh, no, I just wanted to say money helps a lot. Before Okudu, of course, NTIA pumped in, with the Public Wireless Supply Chain Innovation Fund, huge amount of money, made a huge difference. Not quite sufficient, but these things take time. National Science Foundation has been a champion and generous supporter of open source. And then, of course, a long time ago, we had DARPA, Open Programmable Secure 5G. And what we're doing now within Linux Foundation Networking is absolutely building upon that. I think, Rani, you would agree.
Sure.
So I'd like to come back to your original question, which was the hurdles or excuses because of legal, reasons that people would give. And in that regard, I think it's also important, and this is, since I come from Open Air Interface, it's really the obvious that I'm stating from our perspective, that this industry is also different. All open source is not the same. Other industries that I don't know nothing about have probably other norms. But in 3GPP, which until the time we haven't killed it, it's still around. So, over there are some things that work in a certain way. You have the system essential patents, right? So, and also, even contributions in Okudu, I think going forward with some of the companies that are generating intellectual property, they will be asking these kinds of questions, whether, their code can go in without compromising the intellectual property. There are obviously mechanisms that were built, thanks also to some of the work that was done by Open Air Interface, to create this license, which is called the Collaborative Standard Software License, that actually takes into account those patent rights. You spoke about FRAND, Tracy, so those FRAND patent rights. So, that aspect is also important. I think if the licenses were the right ones for those who are incumbents in the industry, then, it would also increase contributions. But that's a position that you have always known. That is the Open Interface position.
Yeah, I think we have kind of 4 criteria for success for open source projects, and clear license and permissible license is one of them. So it's one of the pillars for any successful open source community.
Yeah. We just express our opinion, right? And obviously things go where they should go.
Yeah, so moving on to the next question, I think we'd all agree that there is a certain level of fragmentation in open source RAN networking. I think in my presentation this morning, I tried to show how we are trying to consolidate some of the efforts and bring together, and the recent move of bringing the OAI code base into the Linux Foundation is one pillar of that. But what do you think are other steps we can take as an industry to avoid future fragmentations, I would say, or if you see ways to even consolidate some of the existing efforts? I mean, I think the worst thing we can do is create yet another initiative for 6G AI. That would be the worst outcome. And I think nobody has nefarious intents to do things, but things just happen. So even throughout the day, I heard a few people say, oh, we have an open source thing, but basically they just set their public flag in GitHub to public, and now they have They claim to have another open source project, but it's not an open source initiative because there is no ecosystem around it. So how do we make sure that the next person who has cool technology does not just set the repo to public, but brings it to one of the existing initiatives, and what we can do there?
I'll just take a quick crack at it. I think we saw some pictures, yours and then Mikhail earlier on had this notion of a blueprint. I think that's at least from the vantage point of a user, and we're talking about growing the community. If you are somebody who's trying to enter this space, it's pretty intimidating to understand where things start. So I think if you have some notional blueprint, again, it doesn't have to be perfect, but at least if you know, here are some of my options, and I think we're at a place now, both in the ORAN Alliance and 3GPP, that open interfaces are pretty much going to be the norm. Network APIs are an easy level of, something that's easily being defined. And as a developer, a practitioner, those are things that people understand. So the notion of how do you have a blueprint, how are these disparate pieces connecting, leveraging these open interfaces, what's an open architectural approach, and then I think Tim was the one who mentioned this layer cakes, right? So different layers of infrastructure, radio access network, core, AI is seen as another layer. So you layer cake the complexity, but at least you have a baseline that you can start off from. And then I'll shout out to neutral testing centers, whether it be OTIX, whether it be NSF-funded efforts as kind of the entry points where some level of baseline or a community-accepted baseline starts. So essentially doing something in a silo, being a grad student who's been tasked with by the advisor to go start to look at these things, trying to pull these things together rather than doing that, start with some kind of a blueprint that has some level of head nods that have happened. Not asking for death by committee, not asking for consensus, complete consensus, but at least that here is an architectural start. Once you do that, then at least you start to kind of bring people who aren't necessarily living and breathing this day and day, but you essentially have application developers, and I want to tie this back to the use case story, where you can actually start with something without really understanding the guts of the system. But leveraging APIs, leveraging libraries, you essentially have the ability to kickstart things.
Any other comments?
And another thing that those of us who've been doing this for a while have been on the avoid fragmentation campaign for a while. So let's say you look at the first SDN controller framework, Open Daylight. Mm-hmm. Instead of reinventing it in ONAP, we said, oh, we're going to have an ONAP project called SDNC, and guess what? You peeled back the label, it's Open Daylight. And then we said, oh, and we're going to have this Open Daylight SDN controller with carafe features that are specific for wireless, starting with fixed, point-to-point, and then fixed, point-to-multipoint, and then mobile. And that was SDN-R. And then Ericsson reinvented it as non-real-time RIC. So it looks fragmented. We need to clean it up. It's time for a spring cleaning. And Irfan, you can explain what we're trying to do in the open source focus group by bringing the ORAN software community where it belongs without fragmenting.
Yeah, absolutely, and Rani is part of that effort. The idea is to, under the initiative of the open source focus group of the ORAN Alliance, to bring the ORAN software community into Linux Foundation networking. And, that's one good effort. I think, that will bring some of the components that would stand next to Duranta or Okudu, in that space, bringing the complementary pieces that ORAN software community has built over the course of time, instead of it sitting, somewhere outside and operating as an independent
rehoming the functionality
right.
back in the Linux Foundation networking projects it came from.
Yeah, but one thing that should be said here is there's something about human nature here, right? I mean, when organizations get built, they like to have everything of their own. In the case of ORAN, when ORAN was being born, Open Air Interface, which has pre-existed all of this, we went over there and we wanted to shake hands with the ORAN Alliance for Open Air Interface to be the home of the ORAN software community. Or the code base, but that did not happen because there was a question of not invented here or not ours or something like that. So we have to fight that tendency as well, and it would be even Linux Foundation would be well advised to think about that, because being the biggest open source host organization. The projects in Linux Foundation are also like sprinkled all over the place. Some are within LFN, some are outside of LFN. Free5GC, Okudu. Okudu should probably have been within the LFN also. Anyway, I mean, just as a thought. So, this probably is one of our inborn, tendencies that we need to fight, I suppose, to avoid fragmentation.
Yeah, so two quick answers. One is the reason why projects end up in some sub-organization is sometimes related to how they were conceived and funding and stuff like that. So I wouldn't pay too much attention to that. At the end of the day, they find their way they fall into the right place. So I wouldn't worry about
no need for justification, but it's just a thought.
And the other part is, I think, don't get me wrong, please. I don't think there needs to be full consolidation everywhere. I think there's great benefit in some diversity and trying things different ways. This is part of the beauty of open source, and you see it in any open source community. You go into the Cloud Native Computing Foundations. There are multiple ways to do GitOps with FluxCD or Argo CD or whatnot, and they all thrive, and there's a lot of cross-pollination. And at the end of the day, it serves for the advancement of humanity and technology. So there needs to be some diversity, but I think I agree strongly with Manu that there needs to be some roadmaps in forms of blueprints for people not to get lost. And I think to add to that, I think Lincoln has been working on blueprints for years now, and he understands the next level is also sharing the test results and benchmarking of things, because, and I had a conversation with Vijay in the hallway about the data sets, and it's the same. Like he says there are enough data sets, but where do people start? Where do they find the right data? How do they decide which data is right for me? There needs to be some sort of a benchmarking database or result database where people can find all this data. So we need to provide the roadmaps, as I said, and blueprints, but also we need to allow for some level of freedom there to not to stifle innovation.
Yeah, let's aim for some fragmentation then.
Yeah, we can all decide where the line is.
I just add two quick things. Pardon me. One is I do want to give a shout out based on something Manu said around the neutral test beds and the universities, not just for having deployed infrastructure, but also for starting to open them up to remote access to swaths of people who are not just in your own university. So Northeastern's done a great job with this. Some of the stuff they've done around the, I think it was the AI ran gym, Open Ran Gym, thank you. So the ability to give other people access to some of these things and not even just your own students starts to build, and then people take that out into the workforce or take that out into their, their next academic assignment, whatever that is. That's one thing. The other quick thing is also that the importance of nurturing the ecosystem specifically so that there is not fragmentation in other places. And that comes, you get people to stay motivated by funding, by recognition, by awards, by events. These are all things Linux Foundation knows very, very well. And so there's no magic in that sense. It's just reapplying the techniques over and over again.
Yeah, there's a lot of learned knowledge over the years, and we know how to do certain things well. We have, I think, time for a quick question from the audience, if there's any.
Just a quick question. So we saw the diagrams for the, you know, those blueprints. There's like maybe 50 different logos. So I think that's great to see, you know, all the options, but is there an effort to see what actually works when you start putting them together? Which combination of all those actually work? I think that would help, you know, the community to know. So just curious about some of those efforts.
Richard, excellent question. And yes, and this goes back to a point that you were making, Manu, about, you know, yes, there's human nature, and one of the best things about human nature is you can motivate a large group if you give us a common goal. And use cases are an example of that. So if you look at some of the work that's taken place, and this predates Okudu, it predates Duranta, within open source and the ORAN Alliance, you will see open source reference designs, which are, you know, blueprints by another name that are in place for use case X, network energy saving, you know, OpenCUDU from the open air interface, SMO from, part of it's from the software, ORAN software community, some of it's from ONAP, some of it's from what's left of Open Daylight. Let's bring in an ORU from a commercial ORU vendor. So you are seeing this starting to evolve, and I think with help from experts like Lincoln, who's standing back there, and as Mary pointed out, the collegiality, collaboration among universities, we're just going to get better at that. And we'll have university resources available to the ecosystem, not just to, you know, their own folks. And there will be a library of open source reference designs with well-defined method to get technical support. Now, is that going to happen overnight without any funding? No, it's going to take, Mary, how long is this going to take? It's going to take a while, and it's going to cost a lot of money, a whole lot of money. But it will happen.
But, well, I mean, I'll acknowledge the Innovation Fund and, you know, Accord Lab, for example. So that's a large consortium where you have essentially a major MNO, AT&T in this case, that has a slew of partners that are basically doing essentially what you said, right? It's somewhat use case specific, but essentially you have different kind of pairings that are happening for somebody brings an RU, somebody brings a DU, you're obviously doing interoperability, compliance. But then I think the key piece, and I think I'll piggyback off what Peter said in the last panel, which was the tools. Because at the end of the day, the innovation is great, the development work is great, which a lot of the people in this room are motivated by, but realistically, the operations, the day-to-day mundane part, not having an outage, 5 nines reliability, timing, legacy, all of that stuff is what the people on the other side of the bridge, the ones who have to make this stuff run day in and day out, have to do. So unless there is some level of confidence on these solutions, these blueprints, these kind of, you know, reference designs working, and essentially for those, again, there are a few students in here, so I'll say this, most of the people might be aware, but from a major network operator, if you have a solution to bring, you don't just show up on a live network, you go to their pre-certification testing, and they have a very, very strict, and each operator has their own set of parameters that, or KPIs that they're looking to accomplish. And they run you through a battery of tests to even understand what level. So you're looking at things that you probably from a innovation perspective are not focused on. So scaling, swap, energy, and those are the things that they're going to be looking at. So those KPIs, if you think of this as a closed loop system, those KPIs have to come back to the open source ecosystem on the development side so that you aren't essentially diverging too much from where the solution is going to be implemented. And let's not forget that. And I think that's the community that we really don't see. And that's why some other projects like Kubernetes, et cetera, are very successful because they're put into production. And now those people are having problems. And those problems are the ones that are then motivating the conversations and collaborations. I think for us, and hopefully Okudu and other kind of strategic ideas are going to push this into some, not even, let's say, small regions. Again, not talking about nationwide enterprise deployments, certain regional deployments. Maybe we even start OCONUS outside the continental US. So that's a part that I just wanted to piggyback and then bring back to the conversation is the tooling and the people who have to deal with these open source ecosystems and products on a day-to-day basis.
So yeah, maybe what I can say about that is, everything should work with everything, really, at the end of the day, because if and the interfaces are there for that, right? So I would believe that the Okudu CUDU will work with the OAI-UE. It should, and it needs to be maintained, right? There should be configuration files or whatever for that specific use case, and I think Robert is in the process of putting that in place. Similarly for the core network, right? Core network, bring any core, it should work with Okudu, it should work with OAI. So, when we have interfaces in place that are defined, there's no reason why things should not work. Now, benchmarking it, etc., that requires some extra effort, and that could be something that we could collectively, figure out as in a cross-community fashion, as Lincoln keeps saying. And that would be a good achievement, I think.
No, I agree. Oh, sorry.
Oh no, go ahead.
Okay. Yeah, I agree. It should. I think in practice it doesn't necessarily work that way, right? Because especially because we're looking at the innovation, right? You have all those stacks, right? Everybody's innovating and creating new stuff. They don't necessarily coordinate. So then there's an update on one open source, then the other one, then it doesn't work anymore, right? So looking at the bigger picture is.
Yeah, I must admit there is some effort that is required. Virginia Tech folks were trying to get the CU from SRS connected with the DU of OAI or vice versa, something like that. And we had to go through an effort. Our team, met with them several times, and there was some little configuration thing that was not done properly. So I agree. I mean, some of these things need to be documented properly, and that could be the cross-community work.
Yeah, we're almost out of time. I did want to leave a minute for a closing remark from each panelist. So, if you can just, if there's one thing you want this audience to take away, or one request from the audience about making the open source community of RAN more successful, what would you want to say?
So let me go first, and I'll the voice of the operator, and I'm not going to name any operator in particular. I'm just going to talk about what's in public domain. It's no secret that AT&T announced not long ago that they were teaming up with Ericsson as the commercializer of SMO, Service Management Orchestration Framework, that was incubated in Oren software community, with Fujitsu as the first of, we hope, many ORUs, radios that are, I don't want to say compliant, because there's, are reasonably consistent with the Open Frontal Working Group for specification, and of course with APIs from Camara, which is a Linux Foundation networking project. So there is some progress, but the point that everybody's making, it's got to be industrial strength. It can't fail. Of course, everything fails, which is why we need resilience gets more attention, as well as fault tolerance, because everything fails. Even proprietary single stack, single vendor stuff fails.
Okay. Any other closing remarks?
I would like to, really hail this workshop that was put together by Michele and Tommaso and the team, Manu. This is the kind of thing that we have experience with also in the past, and this is what brings people to open source. Trainings, hackathons. Just as as an example, we organized a workshop a few years back in South Africa with the university over there, and as a result, there were a few people who are now working in Europe, but they were hired at that time by companies that appeared with us. So it sort of brings more people who learn about open source, how to contribute into open source, and eventually become open source contributors. So thanks, Michele and Tommaso and the team for this wonderful event. Thank you.
He just wants to be invited back.
So I think with that we can conclude. Thank you.
So thanks for coming. We can organize events, but if no one comes, the event doesn't make sense. So thanks to all of you as panelists for coming, to the panelists that were in the audience early, to Rani for moderating this last panel. Last round of applause. And I just want to give a couple of extra thanks. No remarks. I think we're too tired for remarks, but yeah, let me mirror my screen. All right. So first of all, I'd like to thank again all the people that helped out with the organization, so all the tutors and the people who assisted with the training. So again, a round of applause for them. And this event would not have been possible without the help of Gabriella, who's right there. She has joined us just a couple of months ago and basically helped me to organize everything that you're seeing here. So the moment you've been waiting for, who's the winner for the hackathon, right? So in the spirit of the workshop, I asked Claude to draw a certificate. And so the winner is Group 4. So we really appreciated everybody's contribution and effort. And the reason why we didn't announce the winner earlier at 4 p.m. is because we were still debating on which was the team that most deserved this. So just to give you a sense of how happy we are with all the efforts that the different groups have done. We appreciated groups from a presentation point of view, as well as kind of the clarity in which the kind of simple algorithm was described, presented, and implemented, as well as the results. So if you guys want to come here, we can take a picture. But in the meantime, for everybody else, it's time to take a breath and relax and enjoy the networking part of this event. There's a little reception just outside, and we're also going to have some like demos or posters if you want to chat with some of our students around the room. All right, thanks everyone, and thanks for coming. And an applause to Group 4.